Welcome YouTubers to another episode in my Grammar Hero series. In this video I'm going to be discussing distance problems, that is D equal RT problems, which have a very high likelihood of appearing on the ASVAB. Before I do that, I just want to take a few minutes to discuss the ASVAB itself. In short, the ASVAB is a computer adaptive test that's composed of 10 different subtests. And as you can see here, those subtests are general science, arithmetic, reasoning, word knowledge, and so on. You receive a score for each subtest, and in addition to receiving a score for each subtest, you're also going to receive what's called an AFQT score. AFQT, of course, stands for Armed Forces Qualification Test. That's the score that says that you're either qualified to join the military or not qualified to join the military. More specifically, the AFQT score is determined by 4 scores, or 4 subtests. It's determined by your arithmetic reasoning subtest, your word knowledge subtest, your math knowledge subtest, and your paragraph comprehension subtest. In other words, these 4 subtests are put in a formula and you're given a percentile rank based on how well you did on these sections. And if you take a look over here, you can see that in addition to having a percentile rank, you will also be grouped into a different recruit category. Ideally, you want to score in category 3B or above. So for example, if you scored a 65, you would be considered a category 2 recruit, and your score of 65 would indicate that you perform better than 65% of all test takers on this exam. Similarly, if you scored a 31, you would be a category 3 Bravo recruit, which means you scored better than 30% of all, or 31% of all test takers. So that's all I wanted to say about the ASVAB itself. You can see here that of all the sections on the ASVAB, you're given the longest amount of time to do the arithmetic reasoning section. Again, since you're not allowed to use a calculator on the ASVAB, you're going to have to work out all of these problems by hand, including by doing long division with decimals and fractions. So that's why it's so long. With regard to distance problems, I just want to finally say that they come in 2 different flavors. The first flavor is this. You have 2 objects heading toward each other. You'll be asked to calculate when they'll meet. And similarly, the second type of problem will be 2 objects heading away from each other, and you'll be asked to calculate how far apart they are after a certain distance. So all that said, let's go ahead and get started with my presentation. My first question is this. If you traveled at a rate of 60 miles per hour, how many miles would you have traveled after 30 minutes, 45 minutes, 1 hour, 1.5 hours? Okay. The reason I start with this problem is because when you're working on distance problems, you have to make sure that if you're working with miles per hour, you're working with hours. Okay, so if you take a look here, this is 1 hour, this is 1.5 hours. We can work with these. As far as these first 2 go, though, 30 minutes and 45 minutes, again, we're working with miles per hour. These are minutes. We're going to have to do something, as you'll see shortly, to make these scenarios work. So that said, I'm going to work number 3 first, and as soon as I do that, I'm going to jump back to number 1. That way you can see what I'm talking about. So again, we're working with the distance formula, which is represented by D equals RT. D, of course, stands for distance, R stands for rate, and time stands for time, or T stands for time. Typically, distance is in miles, rates in miles per hour, and times in hours. Okay? What you do is, given the information you're provided, you go ahead and plug things into this formula and use some basic algebra skills to solve accordingly. So in this case, we're We don't know what our distance is. That's what we're trying to find out. We know our rate is 60 miles per hour, and we know our time is 1 hour. Okay, so this problem becomes 60 times 1, which is just 60. So you know that after an hour, if you're traveling 60 miles per hour, you'll have gone 60 miles. Pretty straightforward, and again, I'm purposefully making this problem easy. That way when we get to more difficult problems later in the presentation, you'll have this tool to use. Okay, so let's go to number 1. Again, we're working with the distance formula, d equals RT. We're plugging things in. We don't know how far we're going, so we're going to leave distance blank. We know we're going at a rate again of 60 miles per hour. We know our time's 30 minutes. Okay, the wrong way to do this one would to take 30 and plug it in for your time. Again, at the beginning of this question, I said if you're working in miles per hour, you cannot plug minutes into this formula. You have to make it proportional to hours. So whenever you're given something in minutes and the question's in miles per hour, you have to convert it. So in this case, what we're going to do is put 30 over 60, because there's 60 minutes an hour, and we're going to work out the problem as normal now. So typically you want to convert these fractions to decimals, which will make the math easier. So this would be 60 times 30 over 60 is 1/2, which we can represent as 0.5. Okay, now we'll just work out 60 times 0.5, and I'll do that off to the side here. When you multiply whole numbers by decimals, you make the decimal whole number by moving the decimal over, and you count how many spaces you moved it over. In this case, I moved it over 1 to the right. At the end of this problem, I'm going to move it back to the left. So 5 times 0 is 0. 5 times 6 is 30. Throw our 1 decimal back in from the right, so we get 30. We know the distance here is 30 miles. Okay. Let's try 45 minutes. Again, we're working with distance equals rate times time. We don't know our distance, but we know our rate is 60 miles per hour. We know our time is 45. If you did this, you would get it wrong. So you have to convert it to make it out of hours. 60 times 45 over 60. Okay. And as I did over here, I'm going to convert this to a fraction. 45 over 60, it turns out, is 3/4, or 0.75. I'll go ahead and work this out. Again, move your decimal place twice. Add it back in at the end. 5 times 0 is 0. 5 times 6 is 30. Bring down a 0 since we're starting the second integer. 7 times 0 is 0. 7 times 6 is 42. Add 0 plus 0 is 0. 0 plus 0 is 0. 5 plus 3 is, or 3 plus 2 is 5, and 4 plus 0 is 4. Add your 2 decimals back in. This gives you a distance of 45 miles. Okay? And because I use 60 miles per hour, the math's turning out to be pretty easy in this case. As you'll see in the next problem, when you change up the miles per hour, this math doesn't always work out this nicely. So this last example, again, we're working with the distance formula, trying to find out how far or the distance we traveled after a certain amount of time. We know our speed is 60, our rate is 60. We know our time's an hour and a half. Take a look. This one's already in decimal form for us, so we don't have to do anything in terms of fractions. This is simply going to be 60 times 1.5. Again, we want to make that decimal into whole number, so we're going to move the decimal place once. We'll add that back in at the end. 5 times 0 is 0. 5 times 6 is 30. Add a 0 since we're starting a new line. 1 times 0 is 0. 1 times 6 is 6. add 0 plus 0 is 0, 0 plus 0 is 0, 3 plus 6 is 9, add our decimal back in. Distance in this case is 90 miles. Okay? Few key takeaways. Again, if it's in minutes and you're working with miles per hour, you need to convert minutes to hours. If it's already in hours form with decimals, that's okay. You can still work that out as normal. Okay? So, question 1. If you're in a car traveling 50 miles per hour, how far will you travel in 45 minutes? Again, for every problem in this presentation, we're going to be working with the distance formula. We don't know how far we're traveling. We know the rate at which we're traveling is 50 miles per hour. And we know the time is 45 minutes. Again, we can't throw 45 minutes in there since we're working with miles per hour. We need to put 45 over 60, which, as we saw in the previous slide, our slide is 0.75. Now we can work this out. 50 times 0.75. Bring your decimal over 2. At the end, we'll add it back in. 5 times 0 is 0. 5 times 5 is 25. Bring down a 0 since we're starting a new integer. 7 times 0 is 0. 7 times 5 is 35. Let's add. 0 plus 0 is 0. 0 plus 5 is 5. 2 plus 5 is 7. 3 plus 0 is 3. Bring in our two decimals that we took away. We can see the distance in this case is going to be 37.5 miles, which is C. Okay? Now, if you didn't see that previous slide, you might have just thrown 45 in there and you would have gotten it wrong. Train A is heading west and train B is heading east at 4 p.m. They are 260 miles apart. If train A is traveling at 70 miles per hour and train B is traveling at 60 miles per hour, what time will they meet? Okay, so they're heading in the same, they're heading toward each other. Train A is heading this way. Train B is heading the same toward train A. We know train B is traveling at 60, whereas train A is traveling at 70. We know they're traveling a total distance of 260 miles. Question is, how long will it take them to meet in the middle somewhere? So one way to think about these problems is to think about the distance the trains are traveling and their speeds. Regardless of their speeds, both trains are going to travel a total distance of 260 miles per hour together. Okay? So when I think about these problems where they're traveling toward each other, a defined rate but different speeds, I always think about train C traveling 260 miles, the same distance as A and B, albeit at a combined rate of these two trains, that is 130 miles per hour. This problem right here is identical to this problem. This problem requires more work. This problem is much simpler. Again, train C traveling 260 miles at 130 miles an hour is the same as two trains traveling 260 miles, albeit at different rates. So let's go ahead and use the fact that these are the same problems and set up our problem accordingly. So distance equals rate times time. We know we're going 260 miles. We know the trains are traveling at a combined rate of 130 miles. We want to figure out when they're going to meet. So we're interested in the time it takes them to travel 260 miles. Divide both sides by 130 to get t by itself. This crosses out. We're left with t equals 260 over 130. You can cross out the zeros to make the problem a little easier. You're left with t equals 26 over 13. And of course, 26 divided by 13 is 2. So in other words, it will take these two trains at their differing rates 2 hours to cover 260 miles. They left at 4. 4 plus 2 hours is 6. Okay? Again, think about these problems as combined rates. The math is identical. A car headed west for north plot left at the same time a car heading east left at the same place. The car heading west traveled at 55 miles per hour. Car heading east traveled at 70 miles per hour. How many miles apart were the two cars at the end of 2.5 hours? So in this case, we have two cars starting at the same place. One's heading this way. One's heading this way. The question is, after 2.5 hours, how far apart would they be? This one's traveling at 55 miles per hour. This one's traveling at 70 miles per hour. As was the case in the last problem, imagine if you had car C here traveling one distance, the same amount of time, albeit at a combined rate of 70 plus 55 miles per hour. So imagine if you had car C traveling 125 miles per hour for the same amount of time. Again, this is the same problem. The math just turns out to be easier. So using this fact down here, we're going to plug these numbers into our distance formula and figure out the answer. So distance, that's what we're after. We know they travel 125 miles an hour, or a combined rate of 125 miles an hour for 2.5 hours. Okay, let's go ahead and work that out. Since we have a fraction here, we're going to move it over one spot and add it back in at the end. 5 times 5 is 25, carry the 2. 5 times 2 is 10, add 2, that's 12. Carry the 1. 5 times 1 is 5, plus 1 is 6. Bring down a 0 since we're starting a new row. 5 times 2 is 10, carry the 1. 2 times 2 is 4, add 1, that's 5. 2 times 1 is just 2. 5 plus 0 is 5. 2 plus 0 is 2. 6 plus 5 is 11. Carry the 1. 2 plus 1 is 3. Add our 1 decimal place back in. So after 2.5 hours and traveling a combined rate of 125 miles per hour, they're 312.5 miles apart. Okay? Now the other way to have done this one would be to do D equals 2.5 times 55, or D equals 2.5 times 70. Get these two distances and add them together. This way is much more efficient. You're less likely to make a mistake, and you're also, it shows that you understand the principle of distance over rate times time. Okay? Train A headed north at 65 miles per hour. Train B is also heading north on adjacent tracks at 72 miles per hour. At the end of 4 hours, how much farther will train B have traveled than train A? So let's just pretend they're heading east instead of north. We got one train heading this way, the other one's heading the same way. Let's just call this one A, this one B. Train A is going 65 miles per hour. Train B is heading 72 miles per hour. And the question is, how much further will train B be after the end of 4 hours of commuting? Now, since we're interested in the distance traveled between these two, we can't combine the rates. So we're going to have to do two separate problems. That is, we're going to have to do distance equals rate times time twice. Okay, So let's call this one train A, train B. We know we're after the distance both travel, so we're going to leave that as D. We're told that train A is traveling 65 miles per hour at a rate of 4 hours for a total of 4 hours. We're told train B is traveling 72 miles an hour, again for a total of 4 hours. Now we just do the math. 65 times 4. 5 times 4 is 20. Carry your 2. 6 times 4 is 24. 25, 26. So train A traveled 260 miles in 4 hours. Train B traveled 72 times 4. 4 times 2 is 8. 7 times 4 is 28. 288 miles per hour. The difference, of course, would be 288 minus 260, which would be 28 miles. Okay, so sometimes they set up the problem such that you have to actually work out the distance separately. Okay. Mark and Mickey are heading for the same place. Mark is 120 miles away and traveling at an average speed of 50 miles per hour. Mickey is 135 miles away and traveling at an average speed of 45 miles per hour. Who will arrive first? So let's make a little timeline. Again, they're both starting at the same place. They're both leaving at the same time. Well, they're actually starting at different places. Mark is going 120 miles. And he's traveling at 50 miles per hour. Mickey is 135 miles away from the destination. And he's traveling at 45 miles per hour. Okay? So you may be thinking about how to set this problem up, but let's think about it this way. Mark is traveling a shorter distance at a faster rate. Mickey is traveling a longer distance at a slower rate. So right off the bat, we know Mark is going to get there quicker. He's going faster and he has a shorter distance to cover. Okay? Imagine if we had a third person going 100 miles and they were traveling at 100 miles per hour. Same principle. This guy would get there before both of them. Again, shorter distance, faster speed. So in this case, you actually didn't have to do any work to solve the problem logically. Okay, and I believe this is the last problem in the presentation. You may have noticed that as we've gone through problems, they've gotten progressively more difficult. If you see a problem like this will probably be one of the tougher problems you'll see on the arithmetic reasoning section of the ASVAB. Okay, so the problem is two bicyclists head toward each other from opposite ends of Main Street, which is 6 miles long. The first biker started at 2:05 going 12 miles per hour. The second biker began pedaling 4 minutes later at a rate of 14 miles per hour. What time will they meet? Okay, so this is, again, two people starting at opposite ends and meeting somewhere in the middle. We're told that they're going a total distance of 6 miles. This one's traveling this way at 12 miles per hour. And this one's traveling this way at 14 miles per hour. Question is, when will they meet, or how long before they meet? The caveat in this problem is this guy who's pedaling at 12 miles per hour actually leaves 4 minutes before this guy. So in other words, we have to figure out how far he travels in those 4 minutes before they both start heading toward each other at the same time. So let's go ahead and do that. Distance equals rate Again, this guy is traveling at 12 miles per hour. And some of you would be tempted to put 4 right in the bracket, but again, 4 minutes, we have to put that over 60. Okay? So this is going to tell us what distance he traveled in those 4 minutes that he got a head start. Let's go ahead and work this out. 12 times 4 is 48 over 60. Okay, and let's go ahead and reduce this. 8 goes into 48. Let's see. Let me work this one out here. 8 goes into, or let's do 4. 4 goes into 48. 12 times. 4 goes into 60. Let's see, 4 goes into 6 once without going over. Subtract the 4 out. You're left with 2, 0. That's 4 goes into 25 times. So this reduces to 12 over 15. 3 goes into 12 4 times. 3 goes into 15 5 times. 4/5 is the decimal 0.8. And I'll work that out in case you don't know how to. 4 divided by 5. 5 can't go into 4, so we add a 0 and bring up a decimal. 5 goes into 48 times. 5 times 40 is, or 5 times 8 is 40. Subtract no remainder. So in 6 minutes, or those 4 minutes that this guy had a head start, he traveled 0.8 miles. Okay? So in light of that, we have to take 0.8 away from this. This becomes 5.2. Okay? So now the problem is, once they both start pedaling, how quickly did they cover 5.2 miles? Okay? So let's go ahead and work that out. And again, we're going to be using a combined rate of 12 and 14 miles per hour. So distance is 5.2. The rate is 12 plus 14 miles per hour, which is 26 miles per hour. The question is, how long did it take them to cover that distance? So we're going to divide both sides by 26. This crosses out. We're left with t equals 5.2 over 26. Okay. Let's go ahead and work that out. 26 does not go into 5. 26 does go into 5.2 or 52. So let's go ahead and work that out. 26 goes into 52 twice. Okay? 2 times 26 is 52. We subtract this out, we get a remainder of 0. So this one took 0.2 of an hour to travel this distance. Okay? So let's go ahead and convert this to a time. We know it took 4 minutes right here to go 0.8, and we know it took 0.2 of an hour to go the remaining distance. 0.2 times 60, of course, is 12 minutes. So in other words, it took a total of 16 minutes from 2:05 for them both to meet in the middle. So 16 plus 2:05 is going to be 2:21. Again, the first biker traveled for 4 minutes, and it took both bikers combined to travel 12 minutes to make up the rest of the distance. Okay, so we just add the 16 minutes combined to 2:05 and we get 2:21. Again, this is one of the hardest problems you'll probably see on the ASVAB. As you saw, it required you to calculate distance equals rate times time first to get the true distance that both of them traveled, and all throughout this problem you had to deal with decimals and fractions. Okay, so on that note, I'm going to go ahead and wrap this video up. If you found it helpful, please feel free to leave some comments in the comment section below or thumbs this video up. Again, if you can handle all the problems in this presentation, you should do very well on these problems during the real test. So on that note, I'll go ahead and cut you loose. Welcome YouTubers to another episode in my Grammar Heroes series. In this video, I'm going to be working out practice problems from the Mathematics Knowledge section of the Armed Services Vocational Aptitude battery that is the ASVAB. Before I do that, however, I want to take a few minutes to discuss the ASVAB itself. First, I want to point out that the ASVAB is nowadays a computer adaptive test for which you'll have 154 minutes to complete 145 questions. Specifically, you'll be working on questions in 10 different subtests, including general science, arithmetic reasoning, word knowledge, paragraph comprehension, mathematics knowledge, and so on. In addition to receiving a score for each of these subtests, you're also going to receive what's called an AFQT score. Of course, AFQT stands for Armed Forces Qualification Test, and that's the score that says you're either qualified to join the military or you're not qualified to join the military. As you can see, that score is broken down in two different ways. It's broken down into ranges as well as corresponding categories. These ranges are given in percentiles. So, for example, if you scored a 50 in terms of your AFQT score, that means you've scored better than 50% of all test takers, and of course that would place you in the corresponding category 3A. As a rule of thumb, you want to strive to score somewhere between category 3 and category 1. That is, you want to score somewhere between 31 and 99. My advice to anyone who's studying for the ASVAB is to focus their efforts on 4 sections. The AFQT score is comprised of your performance on the arithmetic reasoning, the word knowledge, the paragraph comprehension, and the mathematics knowledge subtest. These 4 subtests, more specifically, are your scores on these 4 subtests, more specifically, are put in a formula, and that's how your AFQT score is calculated. So again, focus your efforts on these 4 sections. If you do well on these 4 sections, everything else should fall into place. So all that said, let's go ahead and get started with today's guided practice. One thing I want to point out before we get started is for the ASVAB, you're not given any aids such as a calculator or a formula sheet. Instead, you have to rely on your knowledge of how to do arithmetic as well as your knowledge of mathematical formulas to complete this section of the test. As you'll see in my video, I'm going to make an effort to work out everything in great detail. So if you're rusty with working with decimals or fractions, you should be able to catch up just by watching what I do. Similarly, I want to finally point out that the way you should use this video is as follows. As soon as I finish reading a problem, I would recommend that you pause your video, make an effort to work out the problem yourself, and then play the video to see if you and I came up with the same solution. More often than not, I'm going to come up with a solution the quickest and most efficient way possible. So again, it's always good to see how other people work out these problems. So that said, let's get started with number 1. A box contains 3 black, 4 red, and 5 white marbles. If one marble is to be picked at random, what is the probability it will be red? So we have a box here, and I like to sketch these out for whatever reason. It contains 3 black marbles, 5 white marbles, and and 4 red. So in total, this box contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marbles. So the odds of picking any one of these marbles is going to be out of 12. The odds of picking a red marble is going to be 4 out of 12. Now at this point, I'd be looking at my answer choice to see if that's there. It's not. So we know we're going to have to reduce this. To reduce fractions, you ask yourself what number could go into the numerator, that is 4, and the denominator, that is 12. In this case, it's going to be 4, so I'm going to divide top and bottom, numerator and denominator, by 4. To reduce it, 4 divided by 4, of course, is 1. 12 divided by 4 is 3. So we can see that answer choice is going to be C. So in other words, your odds of picking a red marble are 1/3. Okay? Alright, question 2 is not a good question. It's a little confusing the way they've worded it. So in light of that, I'm going to work it out, but I'm going to say that occasionally you do come across some practice problems that are just poorly worded and they're confusing. So if you find this problem confusing, just ignore it. Usually the ASVAB is worded very clearly. So let's go ahead and tackle it. In the figure above, the sides of triangle ABC are respectively parallel to the sides of triangle DEF. So ABC, DEF. If the complement of C is 40 degrees, then the complement of F is. So whenever they talk about complements and supplements, you need to know that complements refer to 90 degrees, whereas supplements refer to 180 degrees. So when they say the complement of C is 40 degrees, this is what they mean. Imagine that there was a right angle right here. Okay? The complement of C would be angle C, and it would be 40 degrees. That would make this 50 degrees. Together they would add to the right angle 90 degrees. Now, since these are parallel, we also know that this is going to be a straight line, and it's also going to be complementary, so we got to think of another right angle right here. Again, this you just have to understand is going to be 40 since these are parallel, and this is going to be 50. That's all the question's getting at. It's just worded very poorly in my opinion, so the answer would be C, of course. Alright, number 3 is a very good question, unlike number 2. And you will see something like this potentially on the ASVAB. For some reason this OneNote's giving me some issues here, so just bear with me. The sum, number 3, the sum of the measures of the angles of a hexagon is. So to find the sum of the interior angles of any shape, use this formula. 180 n minus 2. 180 times n minus 2, where n is the number of sides in the shape. So if you had a triangle, n would be 1, 2, 3. There are 3 sides in a triangle. If you had a square or rectangle, there was 1, 2, 3, 4 sides, so n would be 4. Hexagon, as you may recall, has 6 sides, so we simply plug in 6 for n and solve accordingly. So we're going to get 180. Again, a hexagon has 6 sides, minus 2, 180. 6 minus 2 is 4, so this becomes 180 times 4. Let's work that off to the side. 0 times 4 is 0. 4 times 8 is 32. Carry the 3. 4 times 1 is 4, plus 3 is 7. So we know 180 times 4 is 720. So we know the sum of the measures of the interior angles of a hexagon is 720 degrees. Again, just a formula that you should commit to memory. Not a hard one to remember either. Okay, let's move on to number 4. If a squared plus b squared equals a squared plus x squared, then b equals. Whenever I see a problem like this, I like to think of it like this. B equals, that is, you want b by itself. So in other words, we're going to have to rearrange these equations such that we get b by itself. So let's go ahead and do that. First, I'm going to write down the original equation. Okay, and since I want b by itself, the first thing I'm going to do is subtract a squared from this side. That's going to become 0. And what I do to one side, I have to do to the other. As you can see here, I have a squared here and a positive a squared here. This becomes a squared minus a squared, which is going to go to 0. So we're going to be left with b squared equals x squared. To get rid of this square, we're going to take the square root of both sides. This becomes b equals, the square root of x squared is going to be plus or minus x. Okay, because regardless of what you plug into x squared in the square root, it's always going to be positive, so it doesn't matter if it's going to be negative or positive what you plug in. For example, if I were to plug in 2 for x squared, that would be 4. If I were to plug in negative 2 for x squared, that would also be 4. Okay, so this one is going to be a plus or minus x. Alright, number 5. Of 6 plus x plus y equals 20, and x plus y equals k, then 20 minus k equals. Okay, so let's go ahead and write everything out. 6 plus x plus y equals 20. X plus y equals k. 20 minus k equals. So this, I don't know why I put 0 there. This is what we want to find out. And to do that, we have to use these facts that are given to arrange the equation such that we get 20 minus k. If you took trigonometry, you would regard these as like identities. So what I can do right away is I know x plus y is equivalent to k. And as I can see right here, I have x plus y. I'm going to go ahead and replace that with k. So this is going to be 6 plus, again, x plus y equals k. So I can just plug k in right here. Equals 20. Okay, I'm going to subtract k from both sides. This goes away. We're left with 6 equals 20 minus k. Again, this is what we were after, 20 minus k. Do I have it? I do. It's equal to 6. Alright, the square root of 75. So in this case, we're looking for roots that are going to be even. So I know 75 is the same as 25 times 3. The square root of 25, of course, is 5. So this is going to, we can rewrite square root of 75 as square root of 25 times 3. Square root of 25, as I said, is 5. So we're left with the square root of 5 radical 3. And we can't simplify this any further. So that's going to be B. Alright, number 7. Square root of 960 is a number between what? So this is when it's helpful to be pretty good at estimating things. And I'm just going to do this because it's going to help you. 2 squared equals 4. 20 squared, therefore, equals 400. 3 squared equals 9. 30 squared equals 900. 4 squared equals 16. 40 squared equals 1600. I'm just going to do a few more. That way we can solve this problem logically, even though we can right now. 5 squared equals 25. 50 squared equals 2500. 6 squared equals 36. 60 squared equals 3600. Let's just do a couple more. 7 squared equals 49. 70 squared equals 4900. 8 squared equals 64. 80 squared equals 6400. 9 squared equals 81. 90 squared equals 8100. Okay, so you have to kind of know that these are equivalent. And if you do, this problem becomes very simple. The square root of 960 is basically asking you what times itself is going to get you 960. So we're going to be looking on at these numbers on the right. We can see 20 squared is 400, which is not big enough, and 30 squared is 900, which is not big enough. So this pair would not work because 960 is not between those two ranges. 30 squared is 900, which is close to 960, and 40 squared is 1600. So 960 falls within this range. So in other words, we know the square root of 960 is going to be somewhere between 30 and 40. Okay? If the measure of angle 2 is 80 degrees in the figure above, the measure of angle 4 is. So this is angle 2 right here. We know that's 80. These angles are corresponding, so we know that's going to be 80. We have alternating interior angles, so we know that's going to be 80. Okay? Again, this is primarily a geometry problem. So if you found it difficult, there's no other explanation I can give you other than that these are corresponding angles. I use the definition of corresponding angles to find this angle, and then I use the definition of alternating interior angles to realize that these two were equivalent. Okay, so this is a pure geometric problem. Alright, number 9, 10 to the 4th over 10. Instead of doing the big math on this problem, I'm just going to use my knowledge of exponents to make this problem a little bit easier. Let me say this. If you had a raised to the x power times a raised to the y power, the result would be a to the x plus y power. Okay? Similarly, if you had a to the x power divided by a to the y power, the result would be a to the x minus y. In other words, multiplication of exponents, as long as the bases are the same, causes you to add the exponents. Division of exponents, when the bases are the same, prompts you to subtract the exponents. Okay? In this case, we can see we have division of exponents with the bases the same. And I'm going to rewrite this as 10 to the 4th divided by 10 to the 1. Okay? So we can see we have this case right here. So that's going to prompt us to use this. So this is going to become 10 to the 4th minus 1, or just 10 to the third. On the ASVAB, you will see questions regarding the laws of exponents, and for that reason I'm probably going to make a video regarding exponents themselves pretty soon. If not, just Google for information about the laws of exponents, and there's only 3 cases you need to know, 2 of which I just mentioned right here. Alright, number 10. Angle 1 and angle 2 form a linear pair and therefore are supplementary angles. If the measure of angle 1 equals 7x plus 6, and the measure of angle 2 equals 5x plus 18, then the measure of angle 2 equals. So again, earlier I mentioned the difference between complementary and supplementary angles. Complementary angles, I mentioned, add to 90 degrees, whereas supplementary angles add to 180 degrees. That is a straight line. So in this case, these 2 angles are going to add to 180 degrees, which is a straight line. We don't know how big they are yet, so we're going to do a sketch and just break them into 2. Let's call this angle 2, and we're told that's 5x plus 18. Let's call this angle 1, and we know that's 7x minus 6. We do know, however, that when both of these angles are added together, that is angle 1 plus angle 2, they'll be 180 degrees. Instead of representing these with angles, we know we can represent them with the algebra, with the formulas given. So let's go ahead and replace those with 7x minus 6 plus 5x plus 18 equals 180 degrees. Let's combine some like terms before we do anything else, and I'm just going to drop off that degrees there. 7x plus 5x is 12x. 18 minus 6 is going to be 12x. And of course, it equals 180. Not x, just 12. There's no x associated with the 6 or the 18. So 12x plus 12 equals 180. Subtract 12 from both sides because we're solving for x in this case. That goes away. We're left with 12x equals 180 minus 12 is going to be 168. Divide both sides by 12, and I'm going to work that over here. This goes away, and we're left with x equals 168 divided by 12. Let's work that out to the side. 12 goes into 1, it doesn't. 12 goes into 16 one time without going over. 12 times 1, of course, is 12. 16 minus 12 is going to be 4. Bring down the 8. 12 goes into 48 4 times. 4 times 12, of course, is 48. So in this case, we know x is going to be 14. Now we want to know that the measure of angle 2. Well, we found x, so we can simply plug that in to our equation for angle 2, and we'll find out exactly what it is. So this is, in other words, going to become 5 times 14 plus 18. Let's work this out to the side. 14 times 5. 5 times 4 is 20. Carry the 2. 5 times 1 is 5 plus 2 is 7. So this becomes 70 plus 18. 70 plus 18, of course, is going to be 88. So we can see that this is going to be 88 degrees. Alright, number 11. If x equals y, find the value of 8 plus 5 times x minus y. Again, this is another identity problem where you have to use the fact that x equals y to find the answer. So we have x plus 5 x minus y
and we're told x equals y. So let's work this out, and we'll see when it's appropriate to use this identity to simplify the problem. So I have x, or 8 plus, and I'm going to distribute this to x and y. So this is going to become 5x minus 5y. Now we're told x is equal to y. They're equivalent. So let's say x was 1. That would mean y equals 1. In this case, if I put 1 right here, this would become 5 minus 5, which would be 0. So given that x equals y, I could even write this, 5y minus 5y, which would be 0. So you can either plug in a whole number if it makes it easier to see, or just rewrite this as x is a y. But this is going to go away, and you're just going to be left with 8. Alright, number 12, look at the figures below. We have triangle R, triangle S, and triangle T. We're told that triangle R is 3 times triangle S. Triangle S is 3 times triangle T. If triangle S is equal to 1, what is the sum of the 3 triangles? So if S is 1, we know this is 3 times as great as 1. 3 times 1, of course, is 3. And we know that this is a third of S, so we know this is going to be 1/3. Okay, all we do is have to add those numbers together. 3 plus 1 is 4, plus 1/3 is 4 1/3. Again, we were told that this is 3 times as big as S, and S is 3 times as big as T. In other words, S is to find T, we'll take S and divide it by 3. That's how I got the 1/3. Okay. Number 13, how many different combinations of jackets and pants are possible from a wardrobe that contains 3 jackets and 5 pairs of pants? In this case, you just multiply 3 by 5 to get 15. This is a statistics problem. The very first problem I did today was in regard to statistics, namely probability. This is a permutation problem. If you need help with statistics and permutations, I would Google it. But this is one of those problems you just have to be able to see it. A lot of people, I remember in elementary school, would write this out. 1 jacket, 2 jacket, 3 jacket, 5 pairs of pants. So we got 1, 2, 3, 4, 5, and they would do something like this: 1, 1, 1, 2, or something like that to do it out by hand. Again, you can combine your 3 jackets with 5 different pairs of pants, so it's going to be 15 different combinations. Alright, 14. Divide 1.672 divided by 0.08. So we got 1.672. Going to divide that by 0.08. As far as dividing decimals goes, you cannot leave this number on the outside of the division bar as a fraction or as a decimal. So I'm going to move the decimal place twice here, and when I do that to this number, I have to do it here as well. So this becomes 8, a whole number, not a decimal, and 167.2. So again, you have to convert this outside decimal to a whole number to do these problems. Off the top of our head, we're going to be able to know that 5 times 20 is 100. So 8 times 20 is going to be 160. We know this is going to be very close to 20. In other words, just by estimating the answer, we know 2.9 is way too small. We know 0.29 is way too small. And we know 200. Well, what's 200 times 8? 1600. And we know that's way too big. So without doing any math, we can solve this problem because we set up our problem such that it became very easy to see. That said, for practice, let's go ahead and work it out. 8 goes into 16 2 times. 2 times 8, of course, is 16. Subtract 16 minus 16 is 0. Got to bring down this 7 and bring down this 2. Now, when we move the decimal, the way you use it when you're doing long division is you just bring it right up in its same place. Okay? So we just brought down our 7 and 2. Does 8 go into 7? It doesn't. It's too small. Okay, so we know this is going to be a 0 here because it's too small. We have to actually go on to the 2. Does 8 go into 72? It does. 9 times 8, of course, is 72. Subtract, that's 0. Okay? If D equals RT, then R equals. So this is just prompting you to rearrange the equation. D equals R times T. We want to know what R equals, so we're going to rearrange the equation. I'm going to divide both sides by T to get rid of the T here. This cancels out, so I'm left with R equals D divided by T, or R equals D divided by T. Again, fractions are the same thing as division. D divided by T, D divided by T, and we can see that 15 is D divided by T. This is actually the distance formula, and if you take a look at my YouTube channel, you'll see that I have an entire video which is about 35 minutes long devoted to just working out problems involving this formula. So if you feel as if this is something you need practice with, go ahead and check out that video. It's pretty good. Alright, number 16, to find the radius of a circle whose circumference is 60 inches. Again, this is rearranging formulas. First, we need to know that there are 2 circumference formulas. The first of which is pi times diameter. Second of which is 2 pi times the radius. In this case, we're after the radius, so we know we're going to be working with this formula. We're told that the circumference is 60. So, again, the formula we're using is circumference equals 2 pi r. We're told the circumference is 60. So 60 equals 2 pi r. We want to know what the radius is, or r. So we're going to divide both sides by 2 pi. Divide this side by 2 pi. We're left with r equals 60 over 2 pi, and we can see that that's going to be b. Divide 60 by 2 pi. Alright, so which is not a prime number, so we have to look through all these numbers and try to figure out which one's prime. Just a rule of thumb, if something's divisible by 2, it's got to be even, and what's more, it's got to be just even. If something's divisible by 2, it's not prime. Prime numbers are only divisible by 1 and themselves, okay? Similarly, if something's divisible by 3, we know it has to be odd. We don't care if something's divisible by 4, because if it's divisible by 2, it's also going to be divisible by 4, so we're not going to include that in our check. If something's divisible by 5, it's not prime, and 5 is usually a number that something's not divisible by 2 and 3 with. And the last one I usually check is 7. Okay? So if I'm checking prime numbers, I want to ask myself, is it divisible by 2? Is it divisible by 3? Is it divisible by 5? And is it divisible by 7? Okay? Again, I'm going to focus in on 87 because I know it's not even, so I know 2 doesn't go into it. What's more, the way you know if something's divisible by 5 is if it ends in a 0 or a 5. So for example, 1 or 10, 15, 20, 25, 30, 35. So if you were to ever see a number that ends in a 0 or a 5, you know right away it's divisible by 5. So I know this isn't divisible by 5. Let's do 87 divided by 3. 3 goes into 8. 2 times without going over. 8 minus, or 2 times 3 is 6. 8 minus 6, of course, is 2. Drop down this 7. 3 goes into 27 9 times. 9 times 3, of course, is 27, so there's no remainder. So we can see right away 87 is divisible by 3, which means, by definition, it is not prime. Again, I just know from experience that this is prime, and this is prime, which is why I focused on 87 right away. Otherwise, I'd be going through my checks. I'd be saying, is it divisible by 2? It's not even, therefore it's not divisible by 2. Is it divisible by 5? Well, it doesn't end in a 0 or a 5, so it's not divisible by 5. And then I would actually do the division by 3. And then I would do the division by 7. Okay? So again, these are just my rules for checking a number of, seeing if a number is prime. There are many more of them, but these typically are the ones that will get you to the answer the quickest way possible. Just another, let me give you another example since this was kind of a bad question. Is this number prime or not? Okay, it's a big number. It's what? 100,005. Is it prime or not? Well, I just told you that if a number ended in 5 or 0, it's going to be divisible by 5. So without doing any math, I can say that this number is divisible by 5, therefore it's not prime. Okay? Alright, number 8, or 18. A is older than B. With the passage of time, the ratio remains unchanged, increases, decreases, and the difference in their ages varies. Well, we know the ages aren't going to change, so that's out of the question. So let's say A is 10 and B is 5. Let's say 10 years goes by. That would make A 20 and B 15. This ratio right here is 5 to 10. This ratio, which is the same as 1/2, this ratio is 15 to 20, which is the same as 3/4. Let's say 100 years goes by, and we can see that as more time goes by, these numbers get closer and closer to each other in terms of their ratios. So we know the ratio between them is going to be decreasing. Let's say 100 years goes by. That's going to be 110 to 105. And again, you can see that they just keep getting closer and closer. So this is going to be C. I don't like how this problem's worded personally. So if you didn't understand this explanation, don't worry about it. This is a poorly worded problem. Number 19, if you multiply x plus 3 by 2x plus 5, what will the coefficient of x be? So we're going to take x plus 3 and multiply it by 2x plus 5. To do this one, we're going to use the FOIL method. That is, I'm going to take this x, multiply it here, multiply it here. I'm going to take this 3, multiply it here, and multiply it here. So x plus 2x becomes x times 2x becomes 2x squared. X times 5 is just 5x. 3 times 2x is 6x. 3 times 5 is 15. Let's combine like terms. 2x squared plus 5x plus 6x is 11x plus 15. We're asked what the coefficient of x will be. This is x squared, so we don't want this coefficient. This has no coefficient of x. Here's the x coefficient is 11. Alright, so in the previous problem we used the FOIL method to solve it. So in this case we're going to do the same thing. That is, I'm going to take this x, multiply it here and here. Take this 3, multiply it here and here. So let's do the x first. Again, we're going to multiply it there and there. X times x is x squared. X times 2 is 2x. 3 times x is 3x. 3 times 2 is 6. Combine like terms. X squared, 3x plus 2x is 5x plus 6. So this is x squared plus 5x plus 6, which is right there. Alright, number 21. The perimeter of a rectangle is 90 degrees. So let's draw a rectangle real quick. One side of the rectangle is twice the length of the other. What is the length of the longer side? So perimeter of a square or rectangle is side plus side plus side plus side. In this case we're told one side is twice as long as the other. So this would be 2s and this would be s. In other words, this is 2 times the length of side s. So this is going to be 2s and this is going to be s because again these sides correspond and these sides correspond. Now the new perimeter is going to be s plus 2s plus 2s. Again, just adding up all the sides, albeit with the new conditions I put in. Perimeter is going to be s plus s is 2s, plus 2s is 4s, plus 2s is 6s. We're told the perimeter is 90, so 90 equals 6s. Divide both sides by 6. This crosses out. We're left with s equals 90 over 6. Let's work this out to the side. 6 goes into 9 one time. 6 times 1, of course, is 6. Subtract. 9 minus 6 is 3. Bring down this 0. 6 goes into 30 5 times. 5 times 6 is 30. Subtract. This is 0. So we know s is going to be 15. That means this side's 15. This side's 15. This is 2s. If s is 15, we know this is 30. And this is 30. So in this case, we know the longer side is going to be 30. 22, the area of the figure above can be determined by the formula. Well, this is a triangle. The area of all triangles is 1/2 base times height. So in this case, it's going to be 1/2 base times height. And again, you can see this is our base. We have our height here. So the formula works. 23 of psychological studies of college students show K% to be emotionally unstable. The number of college students not emotionally unstable per 100 college students is. So if a study found 5% are unstable, that means 100 minus 5 would get us the number or percent that are stable, or 95%. So in this case, we know this is K, so this would be 100 minus K. So it's going to be 100 minus K. Not a very difficult problem there. (24) A cogwheel having 8 cogs plays into another cogwheel having 24 cogs when the small wheel has made 42 revolutions. How many has the larger wheel made? So these are cog wheels. They look like this. They're basically gears. And in this case, we have one small cog wheel, one big cog wheel with. This one has 8 cogs and this one has 24 cogs. So in other words, by the time this one makes 3 revolutions, this one will have made 1 revolution. Again, 24 divided by 8 is 3. So it takes this one 3 times to go around to spin this one once. So if this one goes 42, we know that the big one's going to go 42 divided by 3 times around. 3 goes into 4 one time without going over. 3 times 1, of course, is 3. Subtract 4 minus 3 is 1. Bring down this 2. 3 goes into 12 4 times without going over. 3 times 4, of course, is 12. Subtract, no remainder. So if the little one goes 42 revolutions, we know the big one's only going to go 14 revolutions. 25, a quadrilateral is only a square if. So we know squares, in squares, all the sides are equal. We know they have interior angles of 90 degrees. So if it has 4 right angles, well, that's true, but what about the sides? All the sides are equal, so that's only partially true. It has at least 1 pair of parallel sides. Well, these sides are parallel, as are these sides, so it has 2 pairs of parallel sides. 25, it has 4 right angles and 4 congruent sides. Well, that's the first thing I said after I drew the picture of the square. Both of the pairs of opposite sides are parallel. That's true, albeit impartial. We need to know about the angles, and so for that reason that's not correct. So the answer is 25C. Okay, so that's all I have for you in this video. As you may have noticed, this video kind of focused more on algebra than anything else. So if you found it helpful, feel free to leave some positive feedback in the comment section below or thumbs the video up. But on that note, I'm going to go ahead and cut you loose.
Welcome YouTubers to another episode of my Grammar Hero series. In this video I will be discussing the ASVAB, that is the Armed Services Vocational Aptitude Battery. In particular, I'm going to be working out problems from the Arithmetic Reasoning section of that test. Before we get started, I just want to make some comments about the ASVAB in general. The ASVAB is a test that everyone who aspires to join the U.S. military must take. It's a test, more specifically, that's broken down into 10 sections, and as you can see on the side here, it starts with general science and ends with assembling objects. What's more, the ASVAB is a test that's given in 2 different variations. That is, there's a CAT ASVAB as well as a P&P ASVAB. CAT simply stands for Computer Adaptive Test, and P&P stands for pencil and paper. More often than not, you'll be given the CAT ASVAB. So if you take a look under CAT ASVAB, you'll see that it's a total of 145 questions and you have 154 minutes to complete it. One thing I want to note about the CAT ASVAB is this. Basically, the CAT ASVAB adapts to each test taker's ability level. So you start with a question that's moderate in terms of its difficulty, And if you get it right, you get a question that's slightly more difficult. If you get it wrong, you get a question that's slightly easier, and so on and so forth. Okay. In terms of the arithmetic reasoning section of the test, or as far as the arithmetic reasoning section of the test goes, you can see that you are given the most time to complete this of any of the sections in the ASVAB. So that said, it's pretty important to do well on this section. You're not allowed to have a calculator as you complete this section. Again, arithmetic reasoning. It's testing your ability to do arithmetic and to use some reasoning skills to set up your arithmetic. So no calculator. What's more, once you complete the ASVAB, you're going to be given a slip of paper with all these scores, as well as another score called the AFQT. The AFQT is the Armed Forces Qualification Test. Basically, that score is calculated based on how you do on the word knowledge section, paragraph comprehension section, the mathematics knowledge section, and the arithmetic reasoning section. Okay? Basically, all these numbers are taken, added together in some formula, and you're given a rank. In general, you want to score above a category 4. So in other words, you want to score between 31 and 99 when you get your AFQT score. The AFQT is basically the score that says, yes, this person's qualified to join the military, or no, this person's not qualified to join the military. Okay? So all that said, let's go ahead and get started. I know we have 39 minutes, or you'll have 39 minutes to do this section when you take the test. That said, since many of you probably haven't seen these concepts in a while, I'm going to take things nice and slowly. Okay? Again, I'm using a sample test that I pulled offline. I'll go ahead and post a link to that PDF in the description of this video. Okay? So number 1, family video stocks 1003 drama videos, 518 science fiction videos, and 253 children videos. How many more drama titles than children's titles does family video have in stock? Okay, so they stock 1003 drama movies or videos and only 253 children's videos. To find out how many more there are of drama than children's videos, you simply set up a simple subtraction equation, and again you just work from left to right and top to down, or top to bottom. 3 minus 3, 0. 0 minus 5. You probably haven't seen this in a while. You would basically look at this to carry. You can't do that, so you got to carry from here. This becomes a 0. This becomes a 10. Now you have to carry from this 10, so this will become a 9. This will become a 10. 10 minus 5 is 5. 9 minus 2 is 7. And this became a 0. So there are 750 more drama videos than there are children videos. Now, as you follow along at home, one thing you may want to do is pause the video, work out the problem yourself, and then resume playing the video to see if you and I come up with the same answer. And if not, you'll know why. Okay. Number 2, Mr. Vlasic needs to buy 2 pens for 2 pens each for the 17 students in his class. If pens come in packs of 6 and each pack costs $2.35, what is the minimum amount that Mr. Vlasic must spend? Okay, so he has 17 students and each of them are required to have 2 pens. So in total, he needs to buy 17 times 2, 7 times 2 is 4. Carry the 1. 2 times 1 is 2. Add the 1 is 3. So in total, he needs 34 pens. Okay? Pens come in packs of 6 for $2.35 a piece. So one pack has 6 pens. 2 packs has 12 pens. 3 packs has 18 pens. 4 packs has 24 pens. 5 packs has 30 pens. And 6 packs has 36 pens. Again, for each student, he needs 2 pens for a total of 34 pens. He can't short any students' pens, so he needs more pens than he's required. So he's going to need 6 packs of pens right here. We can see 36 pens is greater than 34. So now we just got to figure out how much 6 packs of pens cost. So we simply do 235 times 6. 5 times 6 is 30. Carry the 3 up here. 6 times 3 is 18. 19, 20, 21. Bring the 2. 6 times 2 is 12. Add 2, 14. Now you may be saying, what do I do now? Well, technically you have 2 decimal places here, so you got to add those back in at the end for 1410. Okay. Brandon earns $1,000 and $1,050 a week, and Brad earns $160 a day. If both of them work 8 hours a day, 5 days a week, who earns a higher hourly wage? How much higher is it? Okay. So this is a 2-part question. We're told Brandon earns $1,050 a week. Whereas Brad earns $160 a day. What's more, we're told that they both work 8 hours a day, 5 days a week. So in total, they work 40 hours a week. 8 times 5 is 40. To find Brad's hourly wage, we simply take 160 and divide it by 8. 160 is how much he makes per day, and we know he works 8 hours a day. 8 goes into 16 2 times, and then we know that 8 goes into 16 2 times, so 8 is going to go into 160 20 times. So his hourly wage is $20 an hour. His was fairly easy to figure out. Brandon, on the other hand, earns $1,000 and $1,050 a week. We need to figure out what 1,050 divided by 40 is to get his hourly rate. Instead of doing this math, let's make it easier. Let's kick off this 0 and kick off this 0. So now we have a simpler division problem. 4 goes in 105 divided by 4. 4 goes into 10, or 4 goes into 1, it can't, so 4 goes into 10 twice. 4 times 2 is 8. We're simply going to bring down this 5. 10 minus 8 is 2. And then this becomes 5. 4 goes into 25 how many times? 4 goes into 25. 4 times 5 is 20. 4 times 6 is 24. So we got a 6 here. Going to need a decimal. 4 times 6 is 24, as I said. Subtract. 25 minus 24 is 1. 4 goes into 1, it doesn't. 4 goes into 10, we could just drop down a 1. 4 goes into 10 how many times? 4 goes into 10 twice. 4 times 2 is 8. Subtract. 10 minus 8 is 2. 4 doesn't go into 2. 4 goes into 25 times. Okay? So Brandon's hourly wage is $26.25, whereas Brad's is 20. We simply subtract that. 2625 minus 20, simply going to be 625. So Brandon, 625 more an hour. Again, this is arithmetic, so you have to be comfortable, as you can see, doing long division. If for some reason you struggle with long division, you should check out my Test of Adult Basic Education videos on the mathematics computation section there. That whole video is based on division, fractions, and so on. Okay. Matthew's dad is 5 times as old as him. If the difference of their ages is 28, how old is Matthew? Okay, so this one is interesting. Basically, there are 2 ways to go about doing this one. You can simply multiply all these by 5, since we know the dad is 5 times as old as the son, and see if the difference is 28. 4 times 5 is 20. 20 minus 4 is 16. Is that 28? No. 5 times 5 is 25. 25 minus 5, is that difference 28? No, it's 20. 6 times 5 is 30. 30 minus 6 is 24. 7 times 5 is 35. 35 minus 7 is 28. Okay, that is the easiest and quickest way to do that one. Number 5, Dana and Megan have to fill 500 envelopes for charity. At the end of the morning, Dana has filled 3/20 of the envelopes and Megan has filled 1/4 of them. How many envelopes have they filled together? Okay, so Dana filled 3 out of 20 times 500 of the envelopes, whereas Megan filled 1/4 of the 500 envelopes. We're simply going to multiply these to get how many they filled. So 3/20 times 500, 1/4 times 500. This is fairly simple to do. Let's start with 1/4 since that's easier. Let's put this over a 1. When you multiply fractions, you multiply straight across the tops and straight across the bottom. So this becomes 500 divided by 4. And we can rewrite that to look like this. 4 goes into 5 wants with a remainder. So 4 times 1 is 4. Subtract that, that becomes 1. Bring down the 2 zeros. 4 goes in 125 times. So Megan filled 125 envelopes. This one, the 3/20 times 500 over 1 is the same idea, but you can reduce before you do this one. 5 goes into 24 times. 5 goes into 500 100 times. So this becomes 300 over 4, because we got 3 times 100 and 4 times 1. Again, we're just multiplying straight across now that we've reduced. And let's go ahead and do this math. 300 divided by 4. 4 doesn't go into 3, so 4 into 30. What's the closest we can get there? 4 times 7 is 28. Let's go ahead and subtract that out. That gives us 30 minus 28, which is 2. Bring down this 0. 4 goes into 25 times. So Megan filled 125. Dana filled 75. That gives us 125 plus 75, which is 200. Together they've filled 200 envelopes. A school garden has been divided into 7/8 square meter plots for students. If the area of the garden is 210 square meters, how many students can get plots? So the way you want to think about this is each student is given less than a square meter of a plot. They're given 7/8 of 1 square meter of a plot. Okay? So if each student was given 1 plot, 210 students would be able to have plots. So we know that's wrong, we know that's wrong, we know that's wrong. It's got to be 240. Okay? And to prove it, let's do the math. 210 divided by 7/8. When you do division like this with fractions, you do what's called keep, change, flip. So this becomes 210 over 1. We keep the 210. We change this from division to multiplication. And then we flip this bottom fraction to be 8 over 7. Then we simply multiply it out. Okay? Now we can reduce this before we do that. Let's take a look. 7 goes into 7 one time. 7 goes into 210 30 times. Okay? So this just becomes 30 times 8, which is 8 times 0 is 0. 8 times 3 is 24. Okay? Number 7, 300 school children went on a field trip. 30% of them were first graders, 45% of them second graders, and the rest were third graders. How many more first graders were there than third graders? Okay, so we got 300 students total. We know 30%, which we can represent by 0.3, were first graders. So 300 times 0.3, again, 0.3 is equal to 30%, which is equal to 3 over 10. Got to be able to know that those are all equivalent. 300 times 0.3. Whenever you multiply with decimals, you move it over 1, so you have all whole numbers, and you remember how many places you moved it. So you moved it 1 place to create the 0.3 to become a whole number, and then at the end you'll go ahead and add that decimal back. So 3 times 0 is 0, 3 times 0 is 0, 3 times 3 is 9. Again, we took 1 decimal place away here, so we're going to add it back here. So that's going to be 90 in first grade. 45% were second graders. So again, same concept. 300 times 0.45. Okay, again, we're going to move this decimal 1 2 this time to create a whole number, and then we'll add it back at the end. 5 times 0 is 5. 5 times 0 is 0, sorry about that. 5 times 0 is 0. 5 times 3 is 15. Since we're moving to a new number, we have to bring down a 0. 4 times 0 is 0. 4 times 0 is 0. 4 times 3 is 12. We'll add it. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 5 is 5. 1 plus 2 is 3. And 0 plus 1 is 1. Took 2 decimal places away. Let's add them back. 1, 2, 135. So we're not told what percentage were third graders, but we know how many out of 300 are first and second graders. So we got 135 plus 90. That becomes 0 plus 5 is 5, 9, 10, 11, 12. 9 plus 3 is 12. Bring the 1. 1 plus 1 is 2. So that's 225 between first and second grade. That must mean 75 are in third grade. So these are the numbers we have to work with. 90 first graders, 135 second graders, 75 third graders. Question is, how many more first graders were there than third graders? 90 minus 75, 15. A dress cost $155 is on sale. A dress that cost $155 is on sale with a discount of 25%. What is the sale price of the dress? So first we're going to calculate the amount by which the dress is discounted. Then we're actually going to take that amount away from the original price to get the sale price. To do that, we take 155, we multiply it by 0.25. Again, 0.25 is the same as 25%, and that's the same as 1/4. Got to know those. Okay, so again, to work with whole numbers, I'm going to take this decimal and move it over twice to make that 25, not 0.25, and I moved it 2, so I'm going to add 2 decimal places back at the end. We're starting here and multiplying across. 5 times 5 is 25. Carry the 2. 5 times 5 is 25, plus 2 is 27. Carry the 2. 5 times 1 is 5, plus 2 is 7. Bring down a 0 since we're starting a new number. 2 times 5 is 10. Bring the 1. 5 times 2 is 10. Plus 1 is 11. Carry the 1. 2 times 1 is 2. Add the 1, that's 3. Add. 5 plus 0 is 5. 7 plus 0 is 7. 7 plus 1 is 8. And 0 plus 3 is 3. Again, we took away 2 decimal places. Let's add it back at the end. So the dress is discounted in the amount of $38.75. But we're not done. This is just the amount by which the dress is discounted. So we got to take this number away from 155 to get our final sale price. So 155 minus 38.75. Okay. You can just take a look at the answer choices and eliminate some ones that are obviously wrong, like this one. Okay. Again, subtracting decimals, I can't take away 5 from nothing. Similarly, I can't take 7 away from nothing or 0. So I have to start borrowing from this 5. So I'm going to take this 5, make it a 4, and make this 0 a 10. So I can do this one now. But to do this one, I'm going to make this 10 a 9, make this 0 a 10. Now we can do it. 10 minus 5, 5. 9 minus 7, 2. Just bring down the decimal. 4 minus 8, I can't do it, so I got to borrow a 1 from there, and this becomes a 4. We add the 10 there. 14 minus 8 is 6. 4 minus 3 is 1, and 1 minus nothing is 1. So the final sale price is $116.25. Marlowe pays $750 rent each month. Bea's rent is 12% higher. What is the ratio of Marlowe's rent to Bea's rent? Okay. So first we got to find out how much Bea's rent is, and we know it's 12% higher than Marlowe's. So let's go ahead and do $750 times 0.12 or 12%. Again, I'm going to move this decimal over twice so that I can work with whole numbers. And this is going to give us the amount by which Bea's rent is more expensive. We still have to add that to Marlowe's to get her full amount. So let's go ahead and do this. 2 times 0 is 0. 2 times 5 is 10. Carry the 1. 2 times 7 is 14. Add the 1. 15. Start a new line, so let's add a 0. 1 times 0 is 0. 1 times 5 is 5. 1 times 7 is 7. Add these. 0 plus 0 is 0. 0 plus 0 is 0. 5 plus 5 is 10. So we carry the 1. 7 plus 1 is 8. Add the 1. 9. 2 decimal places that we took away, we're going to add back in. So her rent is $90 more than Marlowe's.
So in other words, Marlo pays $750, whereas Bea pays $750 plus $90, which is 0 plus 0 is 0, 9 plus 5 is 4, carry the 1, $840. She pays $840, he pays $750. Now we got to find the ratio of their rents. So we got $750 to $840. Let's go ahead and reduce this by a factor of 10 by throwing away both zeros. So we got 75 to 84. Okay. Let's keep reducing these. So we can take a look at our answer choices, and we know 15 is over here, so we know we could possibly reduce 75 to 15, or more than likely we're going to reduce 75 to 25, and we know that to do that we would divide it by 3, okay, because 75 divided by 3 becomes 25. What we do to that side we do to this side, so 84 divided by 3. Let's see, does 3 go into 8? It does, twice. 2 times 3 is 6, subtract it. 8 minus 6 is 2, bring down the 4. 3 goes into 24 8 times. So we get a ratio of 25 to 28, and this cannot be reduced anymore. Okay? A lot of work for that problem, but in the end the math was pretty simple. Number 10, a cake recipe calls for 5 cups of flour to bake 2 cakes. How many cups of flour will be needed to bake 7 cakes? For questions like these, the best thing to do is to find a unit ratio. That is, how many cups of flour it takes to bake 1 cake. So we know it takes 5 cups to do 2 cakes. 5 divided by 2, as we know, is 2.5. So it takes 2.5 cups of flour per 1 cake. Again, that's our unit ratio right there. So using this unit ratio, we can figure out how many cups of flour it would take to make 7 cakes. To do that, we simply do 2.5 times 7. Again, I don't like working with decimals, so I'm going to move this over one place, and then I'll add it back in the end. 7 times 5, as we know, is 35. Carry the 3. 7 times 2 is 14. Add 3. 14, 15, 16, 17. Add our 1 decimal back in. Takes 17.5 cups of flour to make 7 cakes. Okay. Number 11, the scale model of a car is 1 to 24. If the full-size car is 12 feet long, how long is the model? So there are a few things wrong with this problem right off the bat. We're given a scale of 1 to 24, and we're given an answer choice in inches and a scale in feet. So to make this simple, I'm going to convert this 12 feet to inches by multiplying by 12. This becomes 144 inches. 12 times 12 is 144. It's times table, you should know that. So now we got to find the ratio that will give us 1 to 24, and we know the bigger side is going to be 144 inches. So 144 inches. What number is going to give us this? And in the end, we're going to want this to be 1 to 24 when we reduce it. So I'm going to go ahead and just say 6. So let me plug in 6 here and see if we can reduce it. 6 goes into 6 once. 6 goes into 144. Let's work it out over here. 6 goes into 14 2 times. 6 times 2 is 12. We subtract. That gives us 2 and 4. 6 goes into 24. What is it? 4 times. So this becomes 24. Does it work? It does. So 6 inches. On the throw of a 6-sided die, what is the probability that you will roll a number less than 3? So let's go ahead and make some dies here. There's 6 sides on every die with numbers 1 through 6 on each face. So the first one just has 1 dot representing number 1, 2 dots, 3 dots, 4 dots. Let me just separate these. 5 dots, and 6 dots. So these are the 6 faces of the die. When you roll a die, each of these faces has the same probability of coming up. So this one has 1 over 6 odds, 1 over 6 odds, 1 over 6 odds, 1 over 6 odds, and so on. Okay? The question is, what is the probability that you'll roll a number less than 3? So we're not including 3. We're basically saying if you roll the dice, what's the odds a 1 or a 2 is going to pop up? It's very simple. We simply add these two together. So the odds are 1 over 6 plus 1 over 6. Add fractions, you just add straight across if the denominators are the same. It's 2 over 6, which can be reduced to 1/3. Your odds of rolling a 1 or a 2 are 1/3. Okay? It's very useful to know that 1/6 corresponds to the odds of rolling any of the numbers on a die. A bag contains 6 black marbles and 4 white marbles. Sally takes out a black marble and does not put it back. What is the probability that the next marble she picks up will also be black? So let's draw a little picture here. She has 6 black marbles. 1, 2, 3, 4, 5, 6, and 4 white marbles. So right now there are 10 marbles in the bag. So that's going to be our probability of picking a certain number. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 marbles total. Okay? She takes a black marble and doesn't put it back. Okay? So now we're down to 9 marbles left in the bag. What is the probability the next marble she picks will also be black? Well, basically, given the 9 marbles in the bag, what is the odds that she's going to pick a black marble? There are 1, 2, 3, 4, 5 black marbles left and 4 white marbles left, so she has 5 over 9 odds of picking a black marble, since there are 5 left in the bag out of 9 total marbles. Okay, number 14, mangoes are sold at $8.40 a dozen. How much will 15 mangoes cost? Again, it's always helpful to find out the unit price of a mango, how much that is, how much does one mango cost? Okay, so we know it's $8.40 for 12. So let's go ahead and divide that out. Again, I like to do whole numbers. So I'm just going to move this decimal here and bring it up here. And we'll start by just 12 divided by 48. That is going to be, I think it's going to be 7. 12 times, or 2 times 4 is, or 2 times 7 is 14, carry the 1, 1 times 7 is 7, plus 1 is 8. So that's going to be 7. In other words, each mango costs 70 cents. How many does 15 cost? 15 times 0.7. Again, unit cost is 0.7 per mango. Got that decimal. Let's get rid of it till the end. I moved it over 1. 5 times 7 is 35. 7 times 1 is 7 plus 3 is 10. Bring our decimal back that we took away.
It's going to be $10.50. Rosita buys 300 feet of yarn for a craft project. If the yarn costs 12 cents a yard, how much does Rosita spend? So she buys 300 feet, and we know it's 12 cents per yard. Question is, how many feet are in a yard? Turns out there are 3 feet per yard. Again, we're given a price of 12 cents per yard, and she bought 300 feet. So we either need to convert the cost per feet, which would be hard to do, or convert the feet to yards. Okay, 300 feet, there are 3 feet in a yard. We simply do 300 divided by 3. That's 100. So there are 100 yards. 100 or 300 feet is equal to 100 yards. Now we just multiply 100 times 12, or 0.12, and we know that's going to be $12. 1200 is way too big, and 360 is way too big. You can eliminate those right off the bat. Number 16, Mr. Lafferty's 5 children are 6, 8, 14, 15, and 17 years old. What is their average age? So, in other words, what is the mean of their ages? To find the mean or average, we use a little formula that's not too hard to remember. We take all the values, which I'm going to represent as x, 1, to some number x, n, and we add them, and we divide by the total number that we added up top, n. Okay? So how does this work? How many numbers did they give us? 1, 2, 3, 4, 5. So we know there are 5 numbers we're going to add together up top, namely 6 plus 8 plus 14 plus 15 plus 17. As long as you know averages, take all the numbers, add them together, and then divide by the number of numbers that you added, you'll be fine. Again, there's 1 here, 2, 3, 4, 5. Okay? Let's go ahead and work this out. 14 plus 15 is 29. 6 plus 8 is 14. And 17. So we have 29 plus 14 plus 17. Let's go ahead and do this. 9 plus 7 is 6. Plus 4 is 0. So that's going to be 0. Carry a 3. 2 plus 1 is 3. Plus 1 is 4. Plus 3 is 7. So we got, oops, I made a mistake. It should be plus 2 up here. So this should be 60. So we get 60 divided by 5, which is the same as 12. The average age of his children is 12. Okay. So that's the end of this video. As you can see, you have to be comfortable with fractions, decimals, long division, and so on. Again, if you struggle with those things, take a look at my test of adult basic education math computation video. In that video, I spend over an hour just working out problems like that by hand, albeit at a much slower pace. Similarly, you may want to pick up the ASVAB for Dummies book at Barnes & Noble or any bookseller. Not only do they explain some of the concepts I touched on in this video, they also have some additional full-length practice tests. Again, the best way to practice for this test is the best way to prepare for this test is just to practice. That is to say, the more practice tests you do beforehand, and the more you work on your weaknesses, the better you're ultimately going to do. That said, that's the end of this video. Please feel free to give me some feedback in the comment section below. If you want any additional help, feel free to send me a message as well. But on that note, I will go ahead and cut you loose. Welcome YouTubers to another episode in my Grammar Heroes series. In this video, I'm going to be working out practice problems from the Arithmetic Reasoning section of the ASVAB. Before I do that, I just want to make a few comments about the ASVAB itself. The ASVAB, as you can see here, is broken down into 10 subtests, including general science, word knowledge, and so on. What's more, you're given a different amount of time to complete each subtest. For example, to complete the Arithmetic Reasoning section of the test, you're given 39 minutes to do 16 questions, whereas the other times vary for all the other sections. Similarly, you'll be given either one of two versions of the ASVAB. That is, you'll either receive the CAT ASVAB or the P&P ASVAB. CAT ASVAB simply stands for Computer Adaptive Test, whereas P&P stands for Pencil and Paper. Nowadays, they only give the CAT ASVAB, so more often than not, you'll likely receive that version. In case you don't know what Computer Adaptive Test means, it means your first question is moderate in terms of its difficulty. If you get it right, the next question's slightly harder. And if you get it wrong, the next question that you receive slightly easier. And it pretty much progresses like that throughout the test. Okay? What's more, once you complete the ASVAB, you're going to be given scores for each of those 10 subtests, as well as an AFQT score. AFQT stands for Armed Forces Qualification Test. And it's the score that says this person is yes, qualified to join the military, or no, not qualified to join the military. More specifically, the scores made up of the 4 composite scores, specifically the word knowledge section, the paragraph comprehension section, the mathematics knowledge section, and the arithmetic reasoning section. Those 4 composite scores are put into a formula, and then you're ranked against how others perform on this test. In other words, if you score 99, that means you scored better than 99% of all test takers. Okay? In general, you want to score at least a category 3 or above. There are some limits in terms of what recruiters can do if you score below that. Similarly, I want to point out that these 4 sections are very important to your career in the military. As long as you do well on these 4 sections of the test, your chances of getting the career that you want are very high. So instead of wasting your time studying how to assemble objects or mechanical information, I would devote 100% of your time to studying these 4 sections. Everything else will fall into place. Okay? One comment regarding studying, I would say before you take the real ASVAB, you should take at least 10 full-length practice tests before then. Okay? So all that said, let's go ahead and get started with today's video. Again, I'm just going to work out 16 problems, and I'm going to work very slowly. More specifically, I am going to take the time to work out long division problems, long multiplication problems, and so on. That way, if you're rusty in those areas, by watching this video, you'll know what you need to improve on. Question number 1. Patty is 45 years old. She is 15 years older than twice her daughter's age. How old is Patty's daughter? Okay. The chances of you seeing a question like this on the ASVAB are pretty high. We know Patty is 45. So let's just say P is equal to 45. We don't know how old her daughter is, so let's say We don't know her daughter's name either, so we're going to say her daughter is X years old. So that means Patty is twice her age, that is 2X, plus 15 years. How old is Patty's daughter? Okay, that's the question. So if Patty's 2X plus 15 years older than her daughter, let's go ahead and make this into equation and solve it. 45 equals 2X plus 15. Okay, that gives us 45 equals 2X plus 15. Let's subtract 15 from both sides. This goes away. 15 minus 15, 0. 45 minus 15 becomes 30. We still have this 2x over here. To get 2x by itself, we divide both sides by 2. 2 divided by 2 becomes 1. 30 divided by 2 becomes 15. 15 equals x. And over here I said her daughter's age is going to be represented by x. So her daughter is 15 years old. If we plug this in, again, Patty's twice as old. 15 times 2 is 30. And another 15 years on top of that, twice as old. 30 plus 15 is 45. So the math checks out in this case. On number 2, Patrick was going to buy a car for $5,800. The car dealer offered him 2 options for buying the car. He could pay the full amount in cash plus 10% for tax and license, or he could pay $1,000 down and $230 a month for 24 months. And the dealer would pick up the tax and the license cost. Which is the better deal? So let's just work these out one by one and find out the better deal. So I'm going to call this deal 1. He paid $5,800 in cash and 10% for tax and title. So we need to add the cost that he paid in cash plus the tax amount. So we know that's $5,800, that should be a comma, times 10%, or 0.1. Again, you need to know to do these problems that 1 over 10 is the same as 0.1, which is the same as 10%. Okay? When you multiply decimals, the trick is to make this a whole number. Remember how many decimal places you moved. You moved it 1 in this case. At the very end of this multiplication problem, we'll add that back in. So 1 times 0 is 0. 1 times 0 is 0. 1 times 8 is 8. 1 times 5 is 5. 1 decimal place we moved, so we're going to add that back in. This is $580. In other words, Patrick paid $580 in tax. That's in addition to the $5,800 he paid in total. So let's go ahead and add those together to find the total for deal 1. 0 plus 0 is 0. 0 plus 8 is 8. 8 plus 5 is 8, 9, 10, 11, 12, 13. Carry the 1. 5 plus 1 is 6. So in total, he paid $6,380 for deal 1. Deal 2. We know he's putting $1,000 down, so we'll add that in at the end, and he's paying $230 over the course of 24 months. So we need to find out how much that is. This is a simple multiplication problem. 4 times 0 is 0. 4 times 3 is 12. Carry the 1. 4 times 2 is 8. Add the 1. That's a 9. In multiplication, whenever you start a new row, you add a 0. 2 times 0 is 0. 2 times 3 is 6. 2 times 2 is 4. Let's add this up. 0 plus 0 is 0. 0 plus 2 is 2. 9 plus 6 is 15. Carry the 1. 4 plus 1 is 5. So this is the cost for the $230 over 24 months. Remember, he put $1,000 down, so let's add 1,000 to that. 0 plus 0 is 0. 0 plus 2 is 2. 0 plus 5 is 5. 5 plus 1 is 6. So for this, deal number 2, he paid a total of $6,500, $6,520. Okay, 6,300 is less than 6,500, so we know deal 1 or the cash plan is cheaper. A rectangle with a square area of 60 square inches is 4 inches longer than it is wide. What is the width of the rectangle? So we got a rectangle, looks something like this. We know the area is 60. How do you find the area of a rectangle? In case you forgot, it's length times its width. In this case, we're given neither of those pieces of information. Instead, we're told that the length is 4 inches longer than the width. I'm going to represent width with an x since it's unknown. Since the length is 4 inches longer, I'm going to make this 4 or x plus 4. Now we can do some math. Let's go ahead and plug these two variables into our area formula. So area equals x times x plus 4. Again, I just plugged that right into this equation. What's more, I know the area is 60, so A is equal to 60. Let's fill that in this next line. Okay. Now I got to distribute this x specifically to here and here. So 60 equals x times x is x squared. X times 4 is 4x. Okay, now we have a quadratic equation. The only way to solve these is via the quadratic formula, graphing, or factoring. The quickest way, as I'm sure you know, is by factoring. So to get it set up to factor, I have to move this 60 over here, so I'm going to have to subtract it from both sides. 60 minus 60 is 0, and we just subtracted it off the end here, so we're left with 0 equals x squared plus 4x minus 60. Okay. To put this in a form you're used to, I'm just going to rewrite it one more time. X squared plus 4x minus 60 equals 0. Now we're going to factor. If you remember how to set that up, it looks like this. To fill in the blanks, which are right here and here, you're saying to yourself, what can I multiply to get negative 60 that adds to positive 4? Again, what can I multiply by each other to get negative 60 but adds to negative 4? Let's do a positive 10 and a negative 6. Again, negative 6 times 10 is negative 60, so it checks out there. 10 plus negative 6 is positive 4, so it checks out there. So these are going to be our two factors. Now we take these and set them to equal to 0 separately. X minus 6 equal to 0. X plus 10 equal to 0. Solve by simply moving this 6 over. X is going to be 6. Solve by moving this 10 over. X equals negative 10. Okay. Since area is in regard to real shapes, we can't have a negative number, so we know this isn't going to be a solution. We know x is going to be 6, so in other words, we know 6 is going to be the width. We know the length is 4 inches longer, so that's got to be 10. The question is, what is the width? 6. I forgot what number this is, but let's just go with it. In the town of Rod-Powersville, all the license plates have 4 characters. The first character is always an R or a P. The second and third characters are digits between 0 and 9. The fourth character is a single letter of the alphabet between A and Z. How many possible license plates are there? Okay, so let's try to do this one visually, since a lot of you probably haven't seen statistics in a while. Again, on the license plate in this town, there are 4 blank spaces. 1, 2, 3, 4. Okay. In the first one, the choices are R or P. And I put R twice. That should be a P. Sorry about that. In other words, there are 2 choices here. In the second and third blank spaces, there are 10 choices. That is 0, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. Again, 0 to 9 is 10 choices. Again, that applies for here and here. In the fourth space, there are 26 choices. Again, from A to Z, there's 26 letters in the alphabet. To find out how many different possible combinations there are, you simply multiply these all together. 2 choices times 10 choices by 10 choices by 26 choices. And this turns out is not that hard to do mentally. 10 times 26 is 260, times 10 is 2600, times 2. So let me just work this last part out for you. 2600 times 2, 2 times 0 is 0, 2 times 0 is 0, 2 times 6 is 12, carry the 1, 2 times 2 is 4, plus 1 is 5200. There are 5200 different types of possible license plates, given all the different parameters set on this question. Okay? John wants to buy a new computer that cost $3,280. He decides to use his own car and hire out as a taxi during the 4 months of the summer. It cost him $693 to insure his car for those 4 months. He spends $452 per month on gas. Assuming no other expenses, how many fares will he have to get before he earns enough money for the computer if he charges an average of $7 per fare? Okay, so we know the computer cost is going to be $3,280. We know he's going to use his car as a taxi. That's going to cost him $693 for 4 months. So let's add that into the total he's going to have to spend before he can afford the computer. 0 plus 3 is 3. 8 plus 9 is 17. Add the 1. 6 plus 2 is 8. Plus 1 is 9. Bring down the 3. And we're told that it's going to cost him $452 in gas for the 4 months during the summer. So let's go ahead and work that out. 2 times 4 is 8. 5 times 4 is 20. Carry the 2. 4 times 4 is 16. Add the 2. 18. So let's add that into our running total here. 3 plus 8 is 11. Carry the 1. 7 plus 1 is 8. 9 plus 8 is 17 again. Carry the 1. 3 plus 1 is 4. Plus 1 is 5. So all told, he's going to spend $5,700, $5,781 for the 4 months during the summer. We know he charges $7 per fare. So let's go ahead and do the long division to find out how many fares it's going to take for him to purchase the computer, including all the cost it takes him to earn the money. So we're going to do long division here. I'm going to do it slowly in case people haven't seen it in a while. What times 7 could get us close to 5? Nothing except a fraction, which we can't do for long division. What times 7 will get us close to 57? 7 times 7 is 49. 7 times 8 is 56. So we're going to go with 8. Subtract it. 57 minus 56 is just 1. And you just bring down the 8 and the 1. Simply just drop that down. Now we're saying what times 7 could get us close to 1? Nothing except a fraction. Can't do that. What times 7 will get us close to 18? 2 will get us 14. 3 will get us 21. So we're going to have to use 2. We can't go over. 7 times 2 is 14. Subtract it out. 18 minus 14 is 4. Bring down the 1. We can stop right here if we wanted to because we already know what the answer is going to be, but let's just work it out for practice. Again, we already dropped down this 1. What times 7 will get us close to 41? That's going to be 5. That would get us 35. So we know this answer is going to be 825 and some amount of change. In other words, $826. Or 826 fares at $7 per fare will get him enough money to purchase the computer as well as the cost he incurs to save up for the computer. So the answer is C. Rod is a very fast runner. One day he ran 100 meters in 40 seconds, 200 meters in 1 minute and 10 seconds, and 200 meters over low hurdles in 1.5 minutes. How many more seconds did it take him to run the 200 meters over low hurdles than it did to run 200 meters, the 200 meter dash? So we're given 3 pieces of information in this case. We're told it takes him 40 seconds to do 100 meters, a minute 10 to do 200 meters, and a minute 30 to do 200 meters with low hurdles. Question is, how much longer does it take him to do the low hurdles than the 200 meter dash? So we're not interested in this first piece of information at all. If you wanted to make this math simple, you can convert these all to seconds and then just do subtraction. Again, there's 60 seconds in a minute, so 60 plus 10. A minute 10 is the same as 70 seconds. And in this case, we got a minute 30, so we got 60 plus 30. A minute 30 is going to be 90 seconds. You can subtract this out if you want, but clearly you can see that it takes him 20 more seconds to do the hurdles than just the 200 meter dash, which is D. Triangle with a perimeter of 60 inches has one side that's twice as long as the shortest side and a third side that's 8 inches longer than the shortest side. What is the length of the shortest side? Okay, so we got some triangle. Doesn't matter what it looks like. We're given all this information about its sides, but we're not told specifically what any one side is in terms of length. But we are told that its perimeter is equal to 60 inches. And to find the perimeter of a triangle, we simply just add up its 3 sides. That is side plus side plus side. And in that case, that would be side plus side plus side. We can't do that because we don't know what these sides are. So let's go ahead and try to make this into something we can do. I'm going to represent the shortest side as x. And we're told that one side is twice as long as the shortest side. So if the shortest side's x, twice as long as that is going to be 2x. And we're told a third side is 8 inches longer than the shortest side. If the shortest side's x, 8 inches longer than that's going to be x plus 8. Now we can plug things in. Again, perimeter is side plus side plus side. So we have perimeter equals x plus 2x plus x plus 8. We know the perimeter, or P, is equal to 60, so let's plug that in as well. 60 equals x plus 2x plus x plus 8. Combine like terms. 60 equals x plus 2x plus x. X plus 2x is 3x, plus x is 4x. Then we just have that 8 hanging out there. Let's keep reducing. I'm going to subtract 8 from both sides. 8 minus 8 is 0. 60 minus 8 is 52. Still left with this 4x. Divide 4x by 4. What you do to one side, you have to do to the other. This crosses out. We're left with x equals 52 divided by 4. Now we need to reduce that. If you're not good with times tables, you can turn this into long division. 52 divided by 4. 4 goes into 5 one time. 4 times 1 is 4. Subtract. 5 minus 4 is 1. Bring down this 2. 4 goes into 12 3 times. So we know x, which represents this short side, is going to be 13. Your commander orders you to fly a weather balloon at the end of a 500-foot string. Your first sergeant comes out of a nearby building and stands directly under the balloon 300 feet away from you and yells, "How high is the balloon?" Assuming the ground is level, what is the correct answer? Okay, so let's draw a little sketch. Here you are. You're holding a string that's 500 feet long, and we're assuming also that you've let out all the string. Here's the end of your little balloon, and the sergeant comes out and he's directly under the balloon. Say here he is, and he's 300 feet according to the problem away from you. How high is the balloon in the air is the question. So again, unknowns I like to represent with x. In other words, how high is that distance x? This, it turns out, forms a right angle with the ground, and we can use the Pythagorean theorem to figure out what x is. Pythagorean theorem is this: a squared, let me go back one, it's not capital A, it's always a squared lowercase plus b squared lowercase equals c squared, where c is the hypotenuse and a and b are the legs of the triangle. The hypotenuse is always the leg that's across from the right angle. So in this case, this would be our c, and then we can label this one a or b. It doesn't matter how we did that. Okay? So let's just plug things in. I'm just going to copy this formula down here again. A squared plus b squared equals c squared. I told you that hypotenuse is always across from the right angle, so we know that's 500. We know a is going to be 300 squared plus b, which we're going to represent as x squared. Rather than doing this difficult math, and again this is squared right there, rather than doing this difficult math, I'm going to simplify things. I'm going to kick off these two zeros and I'm going to kick off these two zeros. It's going to preserve the same proportionality, but it's going to make the math much simpler. So let's go ahead and work this out. 3 squared, 9, plus x squared just becomes x squared. 5 squared is 25. Now we're just solving for x. We're going to subtract 9 from both sides. 9 minus 9 is 0. 25 minus 9 is 16. I'm left with x squared equals 16. To get rid of the square, we're going to do the opposite, which is square root. That goes away. It becomes x equals the square root of 16, which is plus or minus 4. Think about what we did up here. We took away 2 zeros, so let's add them back in. So x is equal plus or minus 400. Just adding those 2 zeros back in. And could we have a negative value for distance up? No, so we know it's going to be plus 400, which is right here. Your boss tells you to neatly stack a pile of boards behind a building. Each board is 8 feet long, 6 inches wide, and 4 inches thick. She tells you to place 4 boards side by side, then 4 more boards on top of those, and then 4 more boards on top of those, and so on to create your stack. When you're finished, the stack is 10 feet tall. How many pieces of lumber are there in the entire stack? So let's start thinking, let's draw ourselves a mental picture. We're basically stacking the pieces of lumber in rows that are touching. Specifically, we're stacking them in 4 piles. Okay. We know each piece of lumber is 6 inches wide and 8 feet long. This is not drawn to scale. So this is basically a top view. If you were standing on top of the building looking down at the lumber, this is what you would see. Stack 1, stack 2, stack 3, stack 4. Okay? If you were to look at the side of the stack, you would know each piece of lumber is 4 inches wide. That is, it goes up by 4 inches every time you stack a new piece of lumber in the pile. So in other words, 3 pieces of lumber stacked on each other would be 12 inches or 1 feet tall. Okay? So with that in mind, let's think about what the problem's asking. The stack is 10 feet high, and we know each piece of lumber is 4 feet wide, or 4 inches wide. Let's convert all this to inches first to make it simpler. So 10 feet is the same as 10 times 12. There are 12 inches in a foot. That's the same as 120 inches tall. Okay? If each stack is 120 inches tall, how many pieces of lumber are there in one stack? We know each piece of lumber is 4 feet tall, or 4 inches tall. So we do 120 divided by 4. 4 goes into 12. 3 times 4 goes into 120. 30 times. So in each stack, we know there are 30 pieces of lumber. Okay? We're asked how many pieces of lumber are there in the entire stack of 4? 30, 60, 90, 120. You have to carpet a room that measures 8 feet by 14 feet. How many square feet of carpet should you buy? Again, we're assuming the room's a rectangle. It's 8 feet wide by 14 feet long. Again, area of a rectangle is length times width. So in this case, it's going to be 14 times 8. Let's go ahead and work that out. 8 times 4 is 32. Bring the 3 up. 8 times 1 is 8 plus 3, 8, 9, 10, 11. So you're going to need 112 square feet of carpet. Patricia is twice as old as Laura. In 3 years, the sum of their ages will be 42. How old is Patricia? Okay. Patricia is twice as old as Laura. So I'm going to let Laura equal X years old. That means Patricia is going to be 2x years old. She's twice as old as Laura. In 3 years, the sum of their ages will be 42. So if we add 3 here and add 3 here, we know when we add them together, the sum's going to be 42. So let's go ahead and work that out. X plus 3 plus 2x plus 3 equals 42. Again, this is just saying L plus P equals 42. I let L be represented by X since we didn't know what her age, and P be represented by 2X since she's twice as old. 3 years affects both of them, so I had to add 3 to both of them. Okay, and that's how we came up with this. Combine like terms. We got X's here. X plus 2X is 3X. 3 plus 3 is 6. Equals 42. Let's subtract 6 from both sides. 3x equals, what's 42 minus 6? That is going to be 36. Divide both sides by 3. X equals 36 divided by 3. I'll do it the long way in case people can't see it. 3 goes into 3 once. 3 times 1 is 3. Subtract. 3 minus 3 is 0. Bring down the 6. 3 goes into 6 twice. 2 times 3 is 6. Subtract, no remainder, so x is equal to 12. So we know Laura's 12 because we represent it. We said Laura's X years old. Patricia is twice as old, so Patricia is going to be 24 years old. Train A is heading west. Train B is heading east at 4 p.m. They are 260 miles apart. train A is traveling 70 miles per hour and train B is traveling at 60 miles per hour. What time will they meet? So we got train A somewhere over here. Got train B somewhere over here. We know train A is heading this way at 70. Now train B is heading this way at 60. And we know the total distance they have to travel is 260 miles. Question is, at what time or how long will it take them to meet somewhere in the middle here? I don't like these problems because they force you to use distance equals rate times time and actually do a little cheat. Let me ask you to think about the problem like this. If train A is traveling 260 miles, that is the same distance as above, but train A is traveling at 130 miles per hour, how long will it take train A to go 260 miles? Isn't that the same question? Here they're traveling 260, albeit at different rates. Here train A is traveling 260, albeit at a combined rate of these two, or the same speed both of these are traveling. Okay? These answers would be the same. Okay? So whenever you see questions like this, you can think of them as one train traveling the same distance at a combined rate of the two trains. So let's go ahead and plug that into our distance equals rate times time formula. We're interested in how long it takes them to meet. So distance, they're both traveling 260. This train's traveling at 70, this train's traveling at 60. We have to combine those, so that's going to be 130 miles per hour, and that's the trick to this problem, times time. Okay? Solve for t, divide both sides by 130. 130 divided by 130 crosses out, so we're left with 260 over 130 equals t. Think about this. 13 times 2 is 26, so 130 times 2 is going to be 260, so we know t is going to be 2. Okay? Similarly, we could have done this, 260 divided by 130, could have crossed out this 0, could have done 130 or 26 divided by 13. You just have to see that that's 2, otherwise you would have to do the long division. So it's going to take 2 hours for these trains to meet, or if you viewed it as one train traveling the combined rate of them, it would take train A 2 hours to go 260 miles. So we left at 4, add 2 hours, 6 p.m. they'll meet. A store manager makes $35,000 per year. Of this, 28% is withheld for federal and state taxes, but he receives 52% of his withholdings back at the end of the year. When he files taxes, what is his net income for the year? So we got to take the taxes out of the $35,000 and then add back in 52% of that which we took out. So let's go ahead and do that. $35,000. He loses 28% to taxes, which is 0.28. Again, I'm going to move this decimal place 2 places over to make it 28 instead of 2.2 or 0.28, and I'm going to add those back in at the end. 8 times 0 is 0. 8 times 0 is 0. 8 times 0 is 0. 8 times 5 is 40. Carry the 4. 8 times 3 is 24 plus 4, 28. Bring down a 0 since we're starting a new line. 2 times 0 is 0. 2 times 0 is 0. 2 times 0 is 0. 2 times 5 is 10. Bring the 1. 2 times 3 is 6. Add the 1. That's 7. Add. 0 plus 0 is 0. 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 8 plus 0 is 8. 7 plus 2 is 9. Okay? add the 2 decimal places we took away back in. 1, 2. So we know that 28% of $35,000 is $9,800. Okay? So we got to go ahead and take that away from the $35,000. But of this $9,800, he's going to get 52% back. So let's multiply this 98 times 0.52 to find out how much he's going to get back. Again, move this decimal over twice. We're going to add that back in. So that's 52 times 98. Add the decimals back in. 2 times 0 is 0. 2 times 0 is 0. 2 times 8 is 16. Carry the 1. 2 times 8 is 18. Plus 1 is 19. Bring down a 0 since we're starting a new row. 5 times 0 is 0. 5 times 0 is 0. 5 times 8 is 40. Carry the 4. 9 times 5 is 45. Plus 4 is 49. Add 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 6 is 6. 9 plus 0 is 9. 9 plus 0 is 1. Bring the 1. 4 plus 1 is 5. Bring back in our 2 decimals. So we know he's going to get 5,096 back after the 9,000's taken away. So basically he's going to have 35,000 minus 9,800 plus 5,096. Let's make this, we can either do it in 2 steps like that, or we can just do it in 1 step. Let's do it in 2 steps. 35,000 minus the 9,800 in taxes. Again, 0 minus 0 is 0. 0 minus 0 is 0. 0 minus 8 we can't do. We have to borrow a 1 or a tens place from here. That becomes 4. This becomes 10. 10 minus 8 is 2. 4 minus 9 we can't do. Got to borrow a tens place. That becomes a 2. That becomes a 14. 9 goes into 14. 9 minus 14 is 5. 2 minus 0 is 2. So that brings him down to 25,200. Let's add the 5,096 back in. Okay. 0 plus 6 is 6. 0 plus 9 is 9. 0 plus 2 is 2. 5 plus 5 is 1. Carry the 1. So that bumps him back up to 31,296. Oh, did I make a mistake somewhere? Did I? That should be 0. Sorry about that. 5 plus 5 is 0. Carry the 1. So 3,296. NASA decides that it's a fine day to launch a rocket. The rocket blasts off at 3:52 p.m. At 3:55 p.m., the rocket has reached point A, 35 miles above ground level. At 4:10, the rocket reaches point B, 232 miles above ground level. Assuming a constant rate of speed, how fast is the rocket traveling between point A and point B? So again, we know we're working with distance equals rate times time. In this case, we're looking to find out what the rate is. How fast? Fast is rate. Let's draw a little sketch. Rockets take off from the ground. We're told that by the time it reaches point A, it's traveled 35 miles, and it blasted off at 3:52 p.m. It reached point A at 3:55 p.m. Then it continued traveling to point B. It reached point B by 4:10, and at that point it had traveled 232 miles. Okay? Now this 232 refers to the distance it traveled from the ground to point B. We want to find the distance or the speed it traveled from point A to point B. So what I have to do is take this 232 minus 35 to find just this A to B distance. So that's the first step. 232 minus 35. 2 minus 5 we can't do. We got to borrow a 10 from here. This becomes 12. 12 minus 5 is 7. 2 minus 3 we can't do. We got to borrow a 10's place. This becomes 12. That becomes 1. 12 minus 3 is 9. 197. So we know this distance is 197. Okay, so we have the distance aspect of this formula. We do not have the time yet. We know that at 3:55 it reached point A, and at 4:10 it reached point B. Well, 3:55 to 4:10 is a total of 15 minutes. Okay, so from point A to point B it took 15 minutes. Now we have the time part. Now we can solve for rate. Again, rate equals, or to find rate, we simply do distance equals rate times time. In this case, we know the distance from A to B is 197. We don't know what the rate is. The time is 15 minutes. Let's take a look at this. 15 minutes, miles per hour. Do you see a conflict? Minutes, hours. So to be safe, we have to convert this minutes to hours. Okay? And to do that, we divide it by 60. 15 minutes is the same as 15 over 60 hours. 15 times 4 gets you 60, so you know this is going to be a quarter of an hour or 1/4. So we know in terms of hours, we're working with 1/4 of an hour. Okay? To get rid of this 4, or 1/4, we multiply by 4. What we do to one side, we do to the other. This crosses out. We're left with R equals 197 times 4. Let's go ahead and work that out. 7 times 4 is 28, carry the 2. 9 times 4 is 36, plus 2 is 38, carry the 3. 4 times 1 is 4, plus 3 is 7. So this is 788 miles per hour. So if you didn't calculate the distance from A to B or convert minutes to hours, you would have gotten this question wrong. Igor wants to paint his back patio and front porch. The patio measures 14 by 12 feet and the porch measures 10 by 8. If each can of paint covers 48 square feet, how many cans of paint should Igor buy? So let's say his porch looks like this, and his patio looks something like this, or vice versa. We know this one's 14 by 12. This one's 10 by 8. Again, we're looking for area of rectangles, so that's going to be length times width. And specifically, we're going to have to find the area of this shape and add them together. So in other words, we're going to have to do area equals 14 times 12 plus the area of 10 times 8. Let's go ahead and work that out, and then we'll be able to figure out where we need to go from there. So 10 times 8 is just 80. 14 times 12 we'll have to work out. 2 times 4 is 8. 2 times 1 is 2. Bring down a 0 since you're starting a new row. 4 times 1 is 4. 1 times 1 is 1. Add. 8 plus 0 is 8. 2 plus 4 is 6. 1 plus nothing is just 1. So we have 168 plus 80 for the areas of each respective shape. Now we add them together. 0 plus 8 is 8. 6 plus 8 is 14. Carry the 1. 248. So we know the area of the combined spaces is 284 square feet. We know one can of paint covers 48 square feet. So to find out how many cans he needs, we have to divide 248 by 48. 50. Imagine this 48 were 50. 50 times 5 would get us 50, 100, 150, 200, 250. Okay? So let's go ahead and multiply 48 times 5 and see how close that gets us. 5 times 8 is 0, is 40. Carry the 4, 20, 24. So 48 times 5 is 240. Again, 5 cans of paint would only cover 240 square feet. That means we wouldn't be able to paint 8 square feet. So we're going to need at least 6 cans of paint. Find the missing length in a right triangle where the lengths of the two known legs are 10 inches and 24 inches. Okay, we're told it's a right triangle. We're told the legs are 10 and 24 inches respectively. We need to find this measure, the measure of this length for this problem. In the previous problem, I told you that Pythagorean theorem says a squared plus b squared equals c squared, where c squared, which is the length opposite the right angle, is the hypotenuse. So we'll go ahead and call this one a, this one b, plug it in and find c, or x in this case. So a is 10 squared plus b 12 squared equals c squared, which is the unknown length right here, the hypotenuse, which is across from the right angle. 10 squared is 100 plus 12 squared, which is 144, equals c squared. Oh, this is 24, not 12. So let's start over. 10 squared plus 24 squared equals c squared. 100 plus 24 times 24. 4 times 4 is 16. Carry the 1. 4 times 2 is 8. Add the 1. That's 9. Bring down a 0. We're starting a new row. 4 times 2 is 8. 2 times 2 is 4. Let's add 6 plus 0 is 6. 9 plus 8 is 7. Carry the 1. 17. Carry the 1. 576. So this is 576 equals c squared. 100 plus 576 is 676 equals c squared. To get rid of the squared, we take the square root of both sides. We're left with c equals the square root of 676. So we know it's going to be a whole number. Instead of doing, since I'm not very good with squares, let's just multiply this. We know 20 squared is 400, so we know that's too big. 30 squared is going to be 900, so that's too big. Let's go ahead and square 26 and see if that gets us that number. 6 times 6 is 36. Carry the 3. 6 times 2 is 12. Plus 3 is 15. Bring down a 0. 2 times 6 is 12. Carry the 1. 4, 5. 6 plus 0 is 6. 5 plus 2 is 7. 5 plus 1 is 6. So we know it's going to be 26 inches. Okay, so that's all I have for you today. Hopefully you found this guided practice helpful. If not, feel free to send me a private message, and also feel free to leave comments in the comment section below. But on that note, I will go ahead and cut you guys loose. Welcome YouTubers to another episode of my Grammar Hero series. In this video, I'm going to be working out practice problems from the Arithmetic Reasoning section of the ASVAB. Before I do that, I just want to take a few minutes to make some general comments about the ASVAB itself. First, I want to point out that the ASVAB is comprised of 10 different subsections, including general science, arithmetic reasoning, word knowledge, paragraph comprehension, and so on. As you can see, the length varies, as does the time length or time limit for each section. Since we're talking about arithmetic reasoning today, I more specifically want to point out that on test day, you'll have 39 minutes to complete 16 questions. Okay? And of all the sections in the ASVAB, you're given the most amount of time to do this one. Okay? What's more, I also want to stress that there are a few sections you want to do especially well on. The arithmetic reasoning section, the word knowledge section, the math knowledge section, and the paragraph comprehension section, all of these subtests form what's called your AFQT score. That is your Armed Forces Qualification Test score. That, in other words, is the score that says, yes, this person's qualified to join the military, or no, this person's not qualified to join the military. In addition, your AFQT score is typically what opens up different career paths to you in the military. The higher you score in terms of your AFQT score, the more jobs that become available to you. As a rule of thumb, you want to try to score in the third category or higher. So in essence, these three composite scores are going to be added together in some formula, and you're going to be given a percentile rank. For example, if your AFQT test score was 65, that means you scored better than 65% of all the test takers. Okay? I just want to take another minute to point out that practice makes perfect for this test. As a rule of thumb, I would say you should take at least 10 full-length practice tests before you take the real ASVAB. And again, I would devote 100% of your studying efforts to focusing on these four sections rather than looking at electronics information or anything else. Okay? Because again, if you do well and if you get a good AFQT score, everything else will fall into place. Okay? Just a reminder, there's no calculator on the ASVAB at all, and that's not surprising given that this is the arithmetic reasoning section. This section is testing your ability to use some basic reasoning skills to set up your arithmetic problems. Okay? So if you're rusty with division, multiplication, and fractions, now's your time to pay close attention. I'm going to work out these 16 problems as slowly as I can. Okay? So that said, let's go ahead and get started. Question 1. A car headed west for north plot left at the same time a car headed east left the same place. The car headed west traveled at 55 miles per hour. The car headed east traveled at 70 miles per hour. How many miles apart were the cars at the end of 2.5 hours? Before I set this problem up, I'm going to say any problems involving distance times rate times time, or distance equals rate times time, you're going to see these problems on the ASVAB. You're going to see several of them. So I believe in this presentation I'm going to have 3 of them. Pay close attention to these problems. You will see them on test day. Guaranteed. So again, as far as this problem goes, we have 2 cars starting at the same spot. One's heading east, which is this way. One's heading west, which is this way. We know this car is traveling at 55 miles per hour, whereas this car is traveling at 70 miles per hour. The question is, how far apart were they after 2.5 hours? Okay? This formula says distance equals rate times time. I just want to point something out to you. We're talking about miles per hour, so our time is always going to be in hours. In other videos, I did problems where the time was in minutes. You need to convert minutes to hours or fractions of hours whenever you get DRT problems. Okay? Fortunately enough, this one's in hours, so we can proceed. The trick to this problem is to think about it this way. Imagine you had one car traveling this distance, just one direction, albeit at a combined rate of 55 plus 70 miles per hour. Okay, and I'll do that math in case you guys don't know what that is. 7, 8, 9, 10, 11, 12. So imagine if you had one car heading in one direction at 125 miles an hour for 2.5 hours. That's the same problem, okay? You're going to travel the same distance whether it's two cars heading in opposite directions at different speeds or one car heading in one direction at one speed. Okay, so that said, let's go ahead and plug in numbers to our equation and see what we come up with. So we don't know how far we're traveling, so we're going to leave distance in our D equal RT formula blank. We know we're traveling either at a 55 plus 70 miles per hour or 125 miles per hour combined. And for a total of 2.5 hours. Okay, so this just becomes a simple multiplication problem. 125 times 2.5. When we're multiplying fractions, it's easier to make them whole numbers and add the decimals in at the end. So we're going to take this 2.5, move it over here. We moved it one spot to make 2.5 25. At the end, we're going to add one decimal into the left. Okay, so 5 times 5 is 25. Carry the 2. 5 times 2 is 10. Plus 2 is 12. Carry the 1. 5 times 1 is 5. Plus 1 is 6. Bring down a 0 since we're starting a new row. 5 times 2 is 10. Carry the 1. 2 times 2 is 4. Plus 1 is 5. 2 times 1 is just 2. 5 plus 0 is 5. 5 plus 2 is 2. 6 plus 5 is 11. Carry the 1. 2 plus 1 is 3. Bring our decimal back in. And we can see that that's going to be a distance of 312.5 miles. Okay, so that's that one. If in another problem you had the cars traveling toward each other at a specified distance and it said how long before they meet, you would think of it the same way. That is, you combine their speeds, and in that case you'd be finding the time, not the distance. Okay, Joshua has a jar with 12 marbles. The jar contains twice as many red marbles as yellow marbles, 3 times as many green marbles as yellow marbles, and twice as many purple marbles as red marbles. How many yellow marbles are in the jar? So since all the other marbles seem to reference the yellow marbles, I'm going to let the yellow marbles be represented by X. Which I can then say is there are twice as many red marbles as yellow marbles, so I can say red marbles is 2x. There are 3 times as many green as yellow, so I can say the number of green marbles can be represented as 3x. And then there are twice as many purple as there are red, so I can say purple is twice of red, which I can represent as 4x. Okay, I want to know how many yellow there are out of 100, so I'm going to set up an equation that looks like this. X plus 2x plus 3x plus 4x equals 100. Combine our like terms. X plus 2x is 3x plus 3x is 6x plus 4x is 10x. So we're given 10x equals 100. Divide both sides by 10. This cancels. 100 divided by 10 is just 10. Again, we said yellow is just going to be represented by X. X is 10, so we know there are 10 yellow marbles. Mac travels 1,100 miles during a 40-hour work week. If he spends 2/5 of his time traveling, how many hours does he spend traveling? This is not a D equals RT problem. It's not a distance rate time problem. We're told he works 40 hours a week, and he spends a proportion of that, specifically 2/5, traveling. So in other words, we want to know what 40 times 2/5 is. We can think of 40 as 40 over 1. So when we're multiplying fractions, we multiply straight across and then reduce. 40 times 2 is going to be 80. 5 times 1, of course, is 5. Now we have 80 divided by 5. Let me show you the long division in case you forgot how to do this, or you don't know, or it's not obvious to you. 5 goes into 8 one time without going over, so 5 times 1 is 5, subtract it out. 8 minus 5 is 3, bring down this 0. 5 goes into 30 6 times. So he spent 16 hours of his work week traveling. Okay? A teacher deposited $3,000 in a retirement fund. If she didn't add any more money to the fund, which earns an annual interest rate of 6%, how much money would she have in a year? So basically her funds earned her 6% a year. So that's going to look like this. 3,000 times 0.06. Okay? And again, when we're talking about percents, we have to be able to convert percents to fractions to decimals and vice versa. In this case, we would represent 0.06 like this. 6 over 100, which is the same as 0.06, which is the same as just 6%. So you got to be able to think about decimals, fractions, and percents in the same way. You have to be able to convert from one to the other fairly easily. Okay? Again, we're multiplying a decimal to make this math simpler. I'm going to move this over here. So this, in other words, is going to become this. 3,000 times 6. And again, I moved my decimal place twice. So at the end of this math, I'm going to add 2 decimal places back into the left. So 0 times 6 is 0, 0 times 6 is 0, 0 times 6 is 0, 0 times 6 is 18. Add our 2 decimal places back in, 1, 2. So after a year, the account has accrued $180 in interest. We take 180 and add it to 3,000 to get our total amount in the account after a year. It's going to be 0 plus 0, 0, 0 plus 8 is 8, 0 plus 1 is 1, and 3 plus 0, of course, is 3. So after a year, there should be a total of $3,180 in the account. A farmer constructs a wooden bin. The bin is 6 feet long, 4 feet wide, and 3 feet deep. The bin rests on legs that are 3.5 feet tall to keep grain away from the damp ground. How much grain can the farmer store in his new bin? So a bin is basically a cube. Let me go ahead and sketch one of those out real roughly for you. And if you take a look at our answer here, we're talking about cubic feet, so we know we're going to be working with volume. The volume of a cube or a rectangle is going to be this. Volume equals length times width times height. If it was a cube, it would simply be one side cubed. But since all these sides are different, we do length times width times height. We know it's 6 feet long, 3 feet deep or 3 feet tall, and 4 feet wide. Okay, and we know it's sitting on these legs. That's irrelevant. The information about the legs is extraneous information. So let's go ahead and plug these numbers into our volume equation. We know the length is 6, the volume is, or the width is 4, and the height is 3. Let's keep working that out. This becomes 12 times 6. And in case you don't know your times tables for 12s, let's work that out. 6 times 2 is going to be 12. Carry the 1. 6 times 1 is 6, plus 1 is 72. So the volume is going to be 72 feet cubed, or 72 cubic feet. Denise buys a soda for 90 cents, a candy bar for $1.20, and a bag of chips for $2.90. Assuming there a 3.5 sales tax, how much change would she receive from a $10 bill? Okay, so let's go ahead and total up how much she spent. We know she spent $2.90 plus $1.20 plus 90 on the food itself, excluding tax. 0 plus 0 plus 0 is 0. 9 plus 9 is 18, plus 2 is 20. Carry the 2. Bring down the decimal. 2 plus 1 is 3, plus 2 is 5. So on the food alone, she spent $5 excluding tax. We know this, since it's 482, is wrong. It's less than 5. Okay, let's find out how much she spent on tax. Let's do 5 times 3.5. And again, I'm going to move this decimal one place to the left, or to the right. At the end, I'm going to move it back in. So 25, or 5 times 5 is 25. Carry the 2. 5 times 3 is 15, plus 2 is 15, 16, 17. And I actually made a mistake. 3.5% is actually 0.035. So to get this to 35, I had to move it 1, 2, 3 decimal places. So disregard this 1 that I said. We moved it 3 decimal places to make 0.035 to 35. Let's add those 3 back in. 1, 2, 3. So we know she spent 17 cents and a half, or 18 cents on tax. So 17.5 or 17.5 cents is rounded up to 18 cents. So in total, she spent $5.18, including tax, for food. How much change will she get back from a $10 bill? Let's go ahead and do the subtraction. Some of you could probably do this without working it out. That's great. We have 8 minus 0 and 1 minus 0. We know we can't take anything away from 0. So I'm going to make this a 9. And I'm going to bring this. This is going to become a 10. So now I can do 10 minus 1, but I still can't do 0 minus 8. Let me make this a 9. And I'm going to make this a 10 now. Always keep your decimal place in the same spot. So 10 minus 8 is 2. 9 minus 1 is 8. 9 minus 5 is 4. So she's going to get back 482, which is the one I crossed out, it turns out. My mistake on that, I wasn't thinking when I said this, so disregard. It's going to be 482. If it costs $5.50 per square foot to build a new patio, how much would it cost to build a patio that's 9 by 20 feet? So a patio can be a square or a rectangle. In this case, it's a rectangle. It's 9 feet wide by 20 feet long. Costs $5.50 per square foot. So we need to find the area of this and then multiply by square foot. Area of a rectangle is simply length times width. We have 20 times 9, so let's plug that in. We know the length is 20, the width is 9. So 20 times 9, let's work that out. That's 0, 18. So we know this whole thing is 180 feet squared. We know it costs $5.50 per square feet or square foot. So let's take $5.50 and multiply it by 180 to determine how much we would spend to build the new patio. Again, We're going to move this 2 decimal places to the right, and we'll add those back in at the end. We got to be careful now because we're multiplying 3 digits by 3 digits. This can get very tedious. So let's take our time. 0 times 0 is 0. 0 times 5 is 0. 0 times 5 is 0. We drop down a 0 since we're starting the second digit. 0 times 8 is 0. 5 times 8 is 40. Carry the 4. 5 times 8 is 40 plus 4. That's 44. Starting a new row, so we drop down 2 more zeros, especially since we're on the 2 digits. Again, second digit, 1 0. Third digit, 2 zeros before you do anything. 1 times 0 is 0. 1 times 5 is 5. 1 times 5 is 5. Let's add everything up. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 0 plus 4 plus 0 is 4. 5 plus 4 is 9. 5 plus 4 is 9. Okay? We took 2 decimals away. Let's add them back in. 1, 2. So we know... Oh! What did I do wrong here? I made a mistake here. The answer should be 990. I made another math mistake. Let's see what I've done. It was right here. This would probably be a 0. So let's think about it. 8 times 0 is 0. 8 times 5 is 40. Okay. Which I put. 8 times 5 is 40 plus 4, which is 44. Let's see what I did wrong here. 550 times 180. Again, guys, I do make mistakes. This is proof of that. 0 times 0 is 0. 0 times 5 is 0. 5 times 0 is 0. Drop down a 0 since we're starting the second digit. Again, 2 decimal places. 8 times 0 is 0. 8 times 5 is 40. Carry the 4. 8 times 5 is 40. Add 4. That's 44. You can see my mistake. This should have been a 0, not a 4. Okay, let's work the final row. We're going to drop down 2 zeros since we're starting the third digit. 1 times 0 is 0. 1 times 5 is 5. 1 times 5 is 5. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. This is going to be 9 and 9. Let's add those 2 decimals back in. So this is going to be $990. Okay. When you multiply 3 digits by 3 digits, you're prone to make mistakes. If you ever make a mistake like this, always just redo the math. You already did the hard part here, and this is fairly obviously correct. This is where you make the mistakes, so you would just have to simply pull it to the side and try it again. And you will experience that on test day. You will make at least one mental mistake. Okay, a road map is drawn on the scale of 1 inch equals 10 miles. When planning your trip, you notice that you'll have to travel 10 inches on the map to the first turn, 7 inches to the second turn, and then 15 inches to your destination. Your car gets 28 miles per gallon, and gas costs $2.73 per gallon. How much gas money will you need to spend for round trip? Whenever you hear miles per gallon, always think miles divided by gallon. And you'll see why in just a minute. But whenever you hear how much does it cost per gallon or miles per gallon, always think miles divided by gallon. You'll never go wrong if that immediately pops into your head. So let's do a little sketch. You start here. You go 10 miles to your first turn. Let's say you make a turn to the right. You go 7 more miles to your second turn. Then you go 15 miles to get to your destination, and then you make the round trip, which is basically the same way back. So we're going to have to double this. We know 1 mile represents 10 miles according to our scale. So in total we went 10 plus 15 plus 7. Let's go ahead and add that up. That's 25, 26, 27, 28, 29, 30, 31, 32. That's 32 miles one way to go round trip. That is this way once, this way back. We have to multiply it by 2, so that's going to be 4, 6. So we traveled a total distance of 64 miles. Okay? And again, we know this is 1 mile equals 10 miles, so we're just going to add a 0 onto that, so we traveled a distance of 240 miles. Again, these are inches, so this should have been 64 inches, which is 640 miles. Okay? You get 28 miles per gallon, and gas cost $2.73 per gallon. How much did you spend? Okay? So we got to take this 640 divided by 28. This is going to give us how many tanks of fuel we used, and then we'll multiply that by 273. Okay, so we need to say how much, or 28 times what gives us 64, or what gets us closest to 64. Let's try 2, and if not, we'll drop down to 1. This is 8 times 2 is 6, carry the 1. 2 times 2 is 4, plus 1 is 5, so this is going to be 2. It's going to be 56. Subtract it. 64 minus 56 is going to be, let's see, we're going to have to borrow 10 from there. This is going to become a 5. This is going to become 14. That's going to be, what? 6 plus 6 is 12. 6 plus 8 will get you 14. 5 minus 5, 0. Drop down this 0. So now we're saying to ourselves, 28 times what will give us 80 or closest to 80? Well, 30 times 2 will give you 60. 30 times 3 will give you 90. So if we were to do 28 times 3, that would probably put us over. Let's just confirm that. 8 times 3 is 24. 2 times 3 is 6, plus 4 is 84. That puts us over, so we're going to have to do another 2 there. And we know that's going to get us 56. So 2 times 28 is 56. Subtract this out. This drops down to 7. This becomes a 10. This is 4. 7 minus 5 is 2. And we drop down an imaginary 0 because we're going to need it. Okay. And now we're actually going to be working on decimals here. So we're at 28 times what will get us close to 240? Well, 30 times 7 would get us 21. 30 times 8 would get us 240. So let's go with 28 times 8. 8 times 8 is 64. 8 times 2 is 16. Plus 6 is 22. So this actually gets us 224. Subtract. So we know this is going to be 0.8. Let's go ahead and take it to another decimal place, and then we'll stop and round, because as long as we got one decimal place, we know our answer is not going to be way off. We can't take away 0 from 4, so let's make this as 3 and this a 10. It's going to be 6. This is going to be 1. So 2 minus 2 is 0. Let's bring down another 0. 28 goes into 160. Well, 28 times, or 30 times 5 would get us 150. So let's go with 5. So we know this number is, if we round it, is going to be 22.9. Okay? And again, I'm just rounding to one decimal place. When you round, if it's a 5 here or greater, it kicks this up to the next digit. If it's a 4 or later or lower, you would just leave it as the 8. So now we know how many tanks of fuel it takes to go the 640 miles round trip. Let's take 22.9 and multiply it by 2.73 dollars. Let's move our decimals to make the math easy. 1, 2, and 1. So we moved it 2 here, 1 here, a total of 3. I'm going to rewrite it just so I don't make mistakes. This is 273 times 22.9 or 229. Again, we're working with 3-digit multiplication. Take your time. You can make mistakes pretty easily. And again, we moved it 3 decimal places, so we'll have to add those back in at the end. 9 times 3 is 27. Carry the 2. 9 times 7 is 63. 64, 65. Carry the 6. 9 times 8 is 18. Plus 6. 18, 19, 20, 21, 22, 23, 24. Bring down a 0. 2 times 3 is 6. 2 times 7 is 14. Carry the 1. 2 times 2 is 4. Add 1 is 5. Add 2 zeros now since we're working with the 3rd digit. 2 times 3 is 6. 2 times 7 is 14. Carry the 1. Again, that's going to be 5. Add it up. 0 plus 7 is 7. 5 plus 6 plus 0 is 11. Carry the 1. 6 plus 4 is 10. Plus 4 plus 1 is 15. Carry the 1. 5 plus 4 is 9. Plus 1 is 10. Plus 2 is 5 plus 4 is 9, plus 1 is 10, plus 2 is 12. Carry the 1. So this is going to be 62.517. I must have made a mistake somewhere, but the answer fairly obviously is going to be 62.14. Let me just grab a calculator to check my work. Okay, so I'm confident about 640. Let's go ahead and check my math here. 640 divided by 28, 22.85, which I got right. I rounded it to 22.9, and I multiplied that by 2.73, which should give us 62.51. Let me check my math up here. 10 plus 7 plus 15. 32 times 2. That's 640 times 10. 640. We know it's 28 miles per gallon. Okay. 22.857. Let's not round it this time, and let's just multiply this by 2.73. Gets us 62.4. Okay. So in other words, they used a different rounding than we did. This 62.5 is different than 62.41 because of a rounding error. They should have told you to round to a specific number here, which I did not do. So we actually did this correct. And in the real ASVAB, you're going to see that sometimes these problems get very tedious, and sometimes you choose to round one way, but they rounded another way. As long as you're confident with your math and you get something close, you can chalk up the difference to a rounding error, which is what happened in this case. The smoke detector in your house has a malfunction and beeps every 5 minutes. If it first beeps at 10 p.m., how many times will it beep by 4 a.m. when you finally give up and take a hammer to it? So first, let's go from 10 to 4 and count how many hours that is. So we go 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, and 3 to 4. That's 1, 2, 3, 4, 5, 6 hours. Okay, so you finally smashed your alarm clock or smoke detector after 6 hours. Every 5 minutes it beeps. How many times does it beep in 6 hours? So we have this in hours and this in minutes. Let's make sure our question we're working with the same units. So 6 hours is the same as 6 times 60 minutes. Again, there are 60 minutes an hour. So 0 times 6 is 0. 6 times 6 is 36. There are 360 minutes in 6 hours. Those are equivalent. We know it's beeping every 5 minutes, so let's take this 360 divided by 5 to find out how many times it beeps total. 5 doesn't go into 36 or 3, but it does go into 36 7 times. 7 times 5, of course, is 35. Subtract that out. 36 minus 35 is 1. Bring down this 0. Just drag it down. 5 goes into 10, of course, just twice. So over the course of 6 hours or 360 minutes, it's going to beep 72 times. A display is selling bunches of bananas. A display selling bunches of bananas contains 6 dozen banana bunches when the display is full. The manager of the produce department is supposed to make sure the display is restocked when it is 1/4 full. How many bunches of bananas will be on display when it's time to restock? So we know there's 6 dozen bunches. So in other words, there's 12 times 6 bunches, which we just saw in the last problem is 72 total bunches. The manager has to restock when it reaches 1/4 full. So 72 times 1/4 will get us that number. 72 can be thought of 72 over 1. When you multiply fractions, you multiply straight across. So you get 72 over 4 when you multiply straight across, which is the same as 72 divided by 4. 72 going to 7 just once. 4 times 1 is 4. Subtract 3, and you bring down the 2. 4 goes into 32, of course, 18 times. So the manager will restock when there's 1/4 or 18 banana bunches on display. Ron and Joy own a condo together. They decide to sell for $200,000. The two decide to split the proceeds according to the ratio of money each invested into the property. Rod put the most money at a ratio of 5 to 3. How much money should Joy get from this sale? Okay. So this one's tricky. You have to know how to set these problems up to get them right. We know the ratio is 5 to 3. We're given that. But what does that mean in terms of setting up this problem? If I were to do 5 over 3 equals x over 2,000 or 200,000, I'd be thinking on the right track, but this ratio does not hold true. This says 5/3 equals x over 200,000, which is not what we're looking for. To think about this one a little better, let's add these two. 5 plus 3 is 8. So we know Joy's share is going to be 3 to 8, whereas Rod's share is going to be 5 to 8. And when you think about that, when you add those two together, that's a total share of 8 to 8. Okay? Again, this is Joy here, so using 3 over 8 equals x over 200,000. Now we can find the right answer. Again, you're on the right track here, but you had to think about it in this way. So let's go ahead and do that. We cross multiply in this case. That gives us 8x equals 600,000. So let's go ahead and work this out. 600,000 divided by 8. 8 does not go into 6, but 8 goes into 60, I believe, let's say 7 times. Okay, and it goes in 8 times 7 is going to be 56. Subtract that out. 60 minus 56 is 4, and we just drag down these zeros. So we have 1 0, 2 0, 3 0, 4 zeros. 8 doesn't go into 4. 8 goes into 40 5 times. 8 goes into 40,000 5,000 times. Okay? Subtract that out. We can see there's no remainder. So as far as Joy is concerned, she's going to get a share of $75,000. That's directly proportional to the deal they made and the amount they invested. On a trip, you drive 350 miles at an average speed of 60 miles per hour. Then you return home driving an average speed of 70 miles per hour. How long did it take you to complete the trip? Again, it's asking you how long. It's giving you a rate, but not the distance. So we're going to be working again with the distance equals rate times time problem. Let's sketch it out to see if it makes sense. What does give us the distance and rate? We don't know the time. We know leaving, we go 350 miles and we travel 60 miles per hour, and coming home going the same distance we go 70 miles per hour. So you can do this of one of two ways. You can either combine the problems, or you can just do them separately. That is, you can solve this DRT problem and then this DRT problem and then add them together. And that, it turns out, is the simplest way to do it. So for the first one, we know we went a distance of 350 miles. We know we traveled at 60 miles per hour. We don't know how long this first trip took, so let's go ahead and solve for t in this case, and this is an equal sign. To get t by itself, we first subtract both sides by 60. So that gives us t equals 350 divided by 60. To make this math easier, I'm going to kick off these zeros and I'm going to do the long division. 35 divided by 6. 6 does not go into 3, but 6 goes into 35. 6 times 6 is 36. 6 times 5 is 30. So we're going to subtract 30 away. 35 minus 30 is 5. Carry down a 0. 6 goes into 50. 6 goes into 50, not 10 times. 6 times 10 is 60. 6 times 8 is 48. Okay. So let's go ahead and subtract that out. That's going to be 2. Bring down a 50 minus 48 is 2. Bring down an imaginary 0. 6 goes into 23 times. 6 times 3 is 18. Subtract that. 18 minus 20 is 2. Carry down a 0. And so this is just going to repeat. So we can actually round this to 5.8 hours. The first trip takes us approximately 5.8 hours. Let's go ahead and work out this second trip. Hopefully it works out as a whole number. Again, we know we're going a distance of 350 miles. We're traveling 70 miles per hour. We don't know how long it's going to take. Okay. Again, to get t by itself, we divide both sides by 70. This goes away. This becomes, if you look at it, 35 divided by 7. 35 divided by 7 is just 5. So we know T in this case is 5 hours. So we have 5.8 hours and 5 hours, which is going to be 10 point something hours. It's not going to be, it's going to be 10.8 hours. Okay? And we're done. Again, we work both problems separately, and then at the end just combine the hours together, and we were done. Okay, an empty 50-gallon barrel weighs 35 pounds. When completely filled with water, the barrel weighs 455 pounds. Assuming these factors to be true, approximately how much does 1 gallon of water weigh? So we got some barrel that looks like this. Let's imagine it's a steel barrel. We know that when it's empty, the steel barrel weighs 35 pounds. So that should be a B. So the steel, or the barrel itself, weighs 35 pounds. With 50 gallons of water, it weighs 455 pounds. How much does each gallon weigh? Well, first we got to subtract out this weight of the barrel. Okay? So 455 minus 35, 5 minus 5, 0, 5 minus 3 is 2. Still left with a 4 there. So the weight of the water inside this barrel is 420 pounds. We know there are 50 gallons of water, but we want to find out how much 1 gallon weighs. So we're going to take 420 and divide it by 50. To keep the math simple, we're going to kick off these zeros. 5 goes into 4. It doesn't. 5 goes into 42 8 times. Take a look. We can already stop if we wanted to, but let's keep working. 8 times 5 is 40. Subtract. Again, since we're going past that, we're going to need to drop a decimal in our answer. 42 minus 40 is 2, of course. Add a 0 down. 5 goes into 24 times, 8.4 pounds. If you're traveling in a car, traveling 50 miles per hour, how far have you traveled in 45 minutes? Again, we're given rate, 50 miles per hour, time, 45 minutes, and we want to know the distance. So again, this is a DRT problem. Distance equals rate times time. And at the beginning of this video, I warned you, if something's in miles per hour and you're given minutes, you need to convert those minutes to hours to get the problem correct. In other words, you have to keep miles per hour with hours. If this said miles per minute, you would be fine. But since this says miles per hour, we need to convert this to hours. Okay, so let's go ahead and do that. 45 minutes. How many hours is that? Well, we know there's 60 minutes in an hour. Okay. And we can reduce this. 15 goes into 45 3 times. 15 goes into 60 4 times. So 45 minutes is 3/4 of an hour. Okay. So now we can use this number and plug it in our formula to find our distance. So distance, unknown, equals 50 times 3/4. Okay, let's go ahead and do this math. 50 times 3/4 is the same as 50/1 times 3/4. Multiply straight across. This is the same as 150/4, or the same as 75 divided by 2. Let's go ahead and work that out, but it should be fairly obvious that it's going to be 37.5. 75 divided by 2. 2 goes into 7 3 times without going over. 2 times 3 is 6. 7 minus 6 is 1. Bring down our 5. 2 goes into 15 7 times without going over. 2 times 7, of course, is 14. Subtract. That's 1. We're going to drop down a 0. 2 goes into 10 5 times. So 37.5 miles per hour. Okay. If an average person eats 6.7 pounds of French fries per year, how much would that average person consume in a decade? There are 10 years in a decade, so this problem becomes 6.7 times 10. And since I've been showing you how to do multiplication with decimals, move this over 1, add it back in at the end. So 7 times 0 is 0. 6 times 0 is 0. Bring down a 0 since we're starting a new row. 7 times 1 is 7. 7 times 6 is 6. Add. 0 plus 0 is 0. 0 plus 7 is 7. 0 plus 6 is 6. And bring back in our 1 decimal. And the answer is 67 pounds. Okay. Maloney has 11 more nickels than quarters. How many quarters does she have if the total value of her coins is 265? These problems, it turns out, are very tricky. We know a nickel is worth 5 cents, which is 0.05, and we know a quarter is worth 0.25. Okay. We don't know how many quarters or nickels there are total, so let's represent the unknown as an x, but we know combined there's a total of $2.65. We're given this little tidbit of information that kind of throws us for a loop initially. Maloney has 11 more nickels than quarters. So we kind of got to work that into our equation or deal with it before we can work anything out. What I'm going to do is the easiest way to work this problem. So we know this would get us the number of nickels and quarters there are total, excluding the 11, right? To address the 11, let's just get rid of those out of the total right away. We know there's at least 11 nickels in this pile. So 11 times 0.05. Okay, move it 2 decimal places to give you just 5. Let's rewrite it to make it nice. 11 times 5. 1 times 5 is 5. 1 times 5 is 5. Throw your 2 decimal places back in. 1, 2. So we know at the very minimum there's going to be 55 cents in nickels that are extra. So let's go ahead and take that away from our 265. So we don't have to worry about them when we work this problem out. 265 minus 0.55. 5 minus 5 is 0. 6 minus 5 is 1. Bring down your decimal, 2. So now let's rewrite this, excluding the 11 nickels that we're not worried about. 0.05x plus 0.25x equals 2.10. Okay, let's solve for x. 0.05 plus 0.25 is 0.30x equals 210. Oh, I don't know why I put an 8 there. Now let's think about this. 0.3 or 30 cents into 210. That is actually going to be, x is going to be 70. You don't really have to do the math. 7 times 3 is 21. 7 times 30 will get you 210. So we know that, oh, it's just going to be 7, not 70. Why did I put that? So 7 times 30 will get you 210. So 7 times 0.3 will get you 2.10. Okay? Again, x represents the number of quarters and nickels. So let's see where we're going from here. We're going to say x represents the number of quarters that are in the pile. So if there are 7 quarters, there are 11 more nickels. So 7 plus 11 is going to be 18. And let's work that out. So if there are 7 quarters, that's 6 quarters would be $1.50. 7 would be $1.75. And that means there are 18 nickels. 18 times 0.05. 8 times 5, of course, is in 2 decimal places to make this just 5. 8 times 5 is 40. Bring over our 4. 5 times 1 is 5 plus 4 is 9. Bring over 2 decimals. 175 plus 90. Let's see if that adds to 265. Five plus 0 is 5. 7 plus 9 is 6. Carry the 1. 1 plus 1 is 2. Okay, so we know this represents the number of quarters, whereas this represents the number of nickels, so the answer is C. A little confusing there, but I think you, at the end of the day, will get these problems. And on that note, that's all I have for you. If you have questions, concerns, or comments, feel free to put those in the comments section below or to send me a private message. But apart from that, I am going to cut you guys loose. Welcome YouTubers to another episode of my Grammar Hero series. In this video, I'm going to be working out practice problems from the Arithmetic Reasoning section of the ASVAB. Before I do that, I just want to take a few minutes to make some general comments about the ASVAB itself. First, I want to point out that the ASVAB is comprised of 10 different subsections, including general science, arithmetic reasoning, word knowledge, paragraph comprehension, and so on. As you can see, the length varies, as does the time length or time limit for each section. Since we're talking about arithmetic reasoning today, I more specifically want to point out that on test day, you'll have 39 minutes to complete 16 questions. Okay? And of all the sections in the ASVAB, you're given the most amount of time to do this one. Okay. What's more, I also want to stress that there are a few sections you want to do especially well on. The arithmetic reasoning section, the word knowledge section, the math knowledge section, and the paragraph comprehension section. All of these subtests form what's called your AFQT score. That is your Armed Forces Qualification Test score. That, in other words, is the score that says, yes, this person's qualified to join the military, or no, this person's not qualified to join the military. In addition, your AFQT score is typically what opens up different career paths to you in the military. The higher you score in terms of your AFQT score, the more jobs that become available to you. As a rule of thumb, you want to try to score in the third category or higher. So in essence, these 3 composite scores are going to be added together in some formula, and you're going to be given a percentile rank. For example, if your AFQT test score was 65, that means you scored better than 65% of all the test takers. Okay. I just want to take another minute to point out that practice makes perfect for this test. As a rule of thumb, I would say you should take at least 10 full-length practice tests before you take the real ASVAB. And again, I would devote 100% of your studying efforts to focusing on these 4 sections rather than looking at electronics information or anything else. Okay? Because again, if you do if you get a good AFQT score, everything else will fall into place. Okay? Just a reminder, there's no calculator on the ASVAB at all, and that's not surprising given that this is the Arithmetic Reasoning section. This section is testing your ability to use some basic reasoning skills to set up your arithmetic problems. Okay? So if you're rusty with division, multiplication, and fractions, now's your time to pay close attention. I'm going to work out these 16 problems as slowly as I can. Okay? So that said, let's go ahead and get started. Question 1. A car headed west for north plot left at the same time a car headed east left the same place. The car headed west traveled at 55 miles per hour. The car headed east traveled at 70 miles per hour. How many miles apart were the cars at the end of 2.5 hours? Before I set this problem up, I'm going to say any problems involving distance times rate times time, or distance equals rate times time, you're going to see these problems on the ASVAB. You're going to see several of them. So I believe in this presentation I'm going to have 3 of them. Pay close attention to these problems. You will see them on test day. Guaranteed. So again, as far as this problem goes, we have 2 cars starting at the same spot. One's heading east, which is this way. One's heading west, which is this way. We know this car is traveling at 55 miles per hour, whereas this car is traveling at 70 miles per hour. The question is, how far apart were they after 2.5 hours? Okay? This formula says distance equals rate times time. I just want to point something out to you. We're talking about miles per hour, so our time is always going to be in hours. In other videos, I did problems where the time was in minutes. You need to convert minutes to hours or fractions of hours whenever you get DRT problems. Okay? Fortunately enough, this one's in hours, so we can proceed. The trick to this problem is to think about it this way. Imagine you had one car traveling this distance, just one direction, albeit at a combined rate of 55 plus 70 miles per hour. Okay? And I'll do that math in case you guys don't know what that is. 7, 8, 9, 10, 11, 12. So imagine if you had one car heading in one direction at 125 miles an hour for 2.5 hours. That's the same problem, okay? You're going to travel the same distance whether it's 2 cars heading in opposite directions at different speeds or one car heading in one direction at one speed. Okay, so that said, let's go ahead and plug in numbers to our equation and see what we come up with. So we don't know how far we're traveling, so we're going to leave distance in our D equal RT formula blank. We know we're traveling either at a 55 plus 70 miles per hour or 125 miles per hour combined. And for a total of 2.5 hours. Okay, so this just becomes a simple multiplication problem. 125 times 2.5. When we're multiplying fractions, it's easier to make them whole numbers and add the decimals in at the end. So we're going to take this 2.5, move it over here. We moved it one spot to make 2.5 25. At the end, we're going to add one decimal into the left. Okay, so 5 times 5 is 25. Carry the 2. 5 times 2 is 10, plus 2 is 12. Carry the 1. 5 times 1 is 5, plus 1 is 6. Bring down a 0 since we're starting a new row. 5 times 2 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. 2 times 1 is just 2. 5 plus 0 is 5. 5 plus 2 is 2. 6 plus 5 is 11. Carry the 1. 2 plus 1 is 3. Bring our decimal back in. And we can see that that's going to be a distance of 312.5 miles. Okay, so that's that one. If in another problem you had the cars traveling toward each other at a specified distance and it said how long before they meet, you would think of it the same way. That is, you combine their speeds, and in that case you'd be finding the time, not the distance. Joshua has a jar with 12 marbles. The jar contains twice as many red marbles as yellow marbles, 3 times as many green marbles as yellow marbles, and twice as many purple marbles as red marbles. How many yellow marbles are in the jar? So since all the other marbles seem to reference the yellow marbles, I'm going to let the yellow marbles be represented by X. Which I can then say is there are twice as many red marbles as yellow marbles, so I can say red marbles is 2x. There are 3 times as many green as yellow, so I can say the number of green marbles can be represented as 3x. And then there are twice as many purple as there are red, so I can say purple is twice of red, which I can represent as 4x. Okay, I want to know how many yellow there are out of 100, so I'm going to set up an equation that looks like this. X plus 2x plus 3x plus 4x equals 100. Combine our like terms. X plus 2x is 3x plus 3x is 6x plus 4x is 10x. So we're given 10x equals 100. Divide both sides by 10. This cancels. 100 divided by 10 is just 10. Again, we said yellow is just going to be represented by X. X is 10, so we know there are 10 yellow marbles. Mac travels 1,100 miles during a 40-hour work week. If he spends 2/5 of his time traveling, how many hours does he spend traveling? This is not a D equals RT problem. It's not a distance rate time problem. We're told he works 40 hours a week, and he spends a proportion of that, specifically 2/5, traveling. So in other words, we want to know what 40 times 2/5 is. We can think of 40 as 40 over 1. So we just, when we're multiplying fractions, we multiply straight across and then reduce. 40 times 2 is going to be 80. 5 times 1, of course, is 5. Now we have 80 divided by 5. Let me show you the long division in case you forgot how to do this, or you don't know, or it's not obvious to you. 5 goes into 8 one time without going over, so 5 times 1 is 5, subtract it out. 8 minus 5 is 3, bring down this 0. 5 goes into 36 times. So he spent 16 hours of his work week traveling. Okay? A teacher deposited $3,000 in a retirement fund. If she didn't add any more money to the fund, which earns an annual interest rate of 6%, how much money would she have in a year? So basically her funds earned her 6% a year. So that's going to look like this. 3,000 times 0.06. Okay? And again, when we're talking about percents, we have to be able to convert percents to fractions to decimals and vice versa. In this case, we would represent 0.06 like this. 6 over 100, which is the same as 0.06, which is the same as just 6%. So you got to be able to think about decimals, fractions, and percents in the same way. You have to be able to convert from one to the other fairly easily. Okay? Again, we're multiplying a decimal to make this math simpler. I'm going to move this over here. So this, in other words, is going to become this. 3,000 times 6. And again, I moved my decimal place twice. So at the end of this math, I'm going to add 2 decimal places back into the left. So 0 times 6 is 0, 0 times 6 is 0, 0 times 6 is 0, 0 times 6 is 18. Add our 2 decimal places back in, 1, 2. So after a year, the account has accrued $180 in interest. We take $180 and add it to $3,000 to get our total amount in the account after a year. It's going to be 0 plus 0, 0, 0 plus 8 is 8, 0 plus 1 is 1, and 3 plus 0, of course, is 3. So after a year, there should be a total of $3,180 in the account. A farmer constructs a wooden bin. The bin is 6 feet long, 4 feet wide, and 3 feet deep. The bin rests on legs that are 3.5 feet tall to keep grain away from the damp ground. How much grain can the farmer store in his new bin? So a bin is basically a cube. Let me go ahead and sketch one of those out real roughly for you. And if you take a look at our answer here, we're talking about cubic feet, so we know we're going to be working with volume. The volume of a cube or a rectangle is going to be this. Volume equals length times width times height. If it was a cube, it would simply be one side cubed. But since all these sides are different, we do length times width times height. We know it's 6 feet long, 3 feet deep or 3 feet tall, and 4 feet wide. Okay, and we know it's sitting on these legs. That's irrelevant. The information about the legs is extraneous information. So let's go ahead and plug these numbers into our volume equation. We know the length is 6, the volume is, or the width is 4, and the height is 3. Let's keep working that out. This becomes 12 times 6. And in case you don't know your times tables for 12s, let's work that out. 6 times 2 is going to be 12. Carry the 1. 6 times 1 is 6, plus 1 is 72. So the volume is going to be 72 feet cubed, or 72 cubic feet. Denise buys a soda for 90 cents, a candy bar for $1.20, and a bag of chips for $2.90. Assuming there a 3.5 sales tax, how much change would she receive from a $10 bill? Okay, so let's go ahead and total up how much she spent. We know she spent $2.90 plus $1.20 plus 90 on the food itself, excluding tax. 0 plus 0 plus 0 is 0. 9 plus 9 is 18, plus 2 is 20. Carry the 2. Bring down the decimal. 2 plus 1 is 3, plus 2 is 5. So on the food alone, she spent $5 excluding tax. We know this, since it's $4.82, is wrong. It's less than 5. Okay, let's find out how much she spent on tax. Let's do 5 times 3.5. And again, I'm going to move this decimal one place to the left, or to the right. At the end, I'm going to move it back in. So 25, or 5 times 5 is 25. Carry the 2. 5 times 3 is 15, plus 2 is 15, 16, 17. And I actually made a mistake. 3.5% is actually 0.035. So to get this to 35, I had to move it 1, 2, 3 decimal places. So disregard this 1 that I said. We moved it 3 decimal places to make 0.035 to 35. Let's add those 3 back in. 1, 2, 3. So we know she spent 17 cents and a half, or 18 cents on tax. So 17.5 or 17 and a half cents is rounded up to 18 cents. So in total she spent $5.18, including tax, for food. How much change will she get back from a $10 bill? Let's go ahead and do the subtraction. Some of you could probably do this without working it out. That's great. We have 8 minus 0 and 1 minus 0. We know we can't take anything away from 0. So I'm going to make this a 9. And I'm going to bring this. This is going to become a 10. So now I can do 10 minus 1, but I still can't do 0 minus 8. Let me make this a 9. And I'm going to make this a 10 now. Always keep your decimal place in the same spot. So 10 minus 8 is 2. 9 minus 1 is 8. 9 minus 5 is 4. So she's going to get back 482, which is the one I crossed out, it turns out. My mistake on that, I wasn't thinking when I said this, so disregard. It's going to be 482. If it costs $5.50 per square foot to build a new patio, how much would it cost to build a patio that's 9 by 20 feet? So a patio can be a square or a rectangle. In this case, it's a rectangle. It's 9 feet wide by 20 feet long. Costs $5.50 per square foot. So we need to find the area of this and then multiply by square foot. Area of a rectangle is simply length times width. We have 20 times 9, so let's plug that in. We know the length is 20, the width is 9. So 20 times 9, let's work that out. That's 0, 18. So we know this whole thing is 180 feet squared. We know it costs $5.50 per square feet or square foot. So let's take $5.50 and multiply it by 180 to determine how much we would spend to build the new patio. Again, we're going to move this 2 decimal places to the right, and we'll add those back in at the end. We got to be careful now because we're multiplying 3 digits by 3 digits. This can get very tedious. So let's take our time. 0 times 0 is 0. 0 times 5 is 0. 0 times 5 is 0. We drop down a 0 since we're starting the second digit. 0 times 8 is 0. 5 times 8 is 40. Carry the 4. 5 times 8 is 40 plus 4. That's 44. Starting a new row, so we drop down 2 more zeros, especially since we're on the 2 digits. Again, second digit, 1 0. Third digit, 2 zeros before you do anything. 1 times 0 is 0. 1 times 5 is 5. 1 times 5 is 5. Let's add everything up. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 0 plus 4 plus 0 is 4. 5 plus 4 is 9. 5 plus 4 is 9. Okay? We took 2 decimals away. Let's add them back in. 1, 2. So we know... Oh! What did I do wrong here? I made a mistake here. Answer should be 990. I made another math mistake. Let's see what I've done. It was right here. This would probably be a 0. So let's think about it. 8 times 0 is 0. 8 times 5 is 40. Okay. Which I put. 8 times 5 is 40 plus 4, which is 44. Let's see what I did wrong here. 550 times 180. Again, guys, I do make mistakes. This is proof of that. 0 times 0 is 0. 0 times 5 is 0. 5 times 0 is 0. Drop down a 0 since we're starting the second digit. Again, 2 decimal places. 8 times 0 is 0. 8 times 5 is 40. Carry the 4. 8 times 5 is 40. Add 4. That's 44. You can see my mistake. This should have been a 0, not a 4. Okay, let's work the final row. We're going to drop down 2 zeros since we're starting the 3rd digit. 1 times 0 is 0. 1 times 5 is 5. 1 times 5 is 5. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. 0 plus 0 plus 0 is 0. This is going to be 9 and 9. Let's add those 2 decimals back in. So this is going to be $990. Okay. When you multiply 3 digits by 3 digits, you're prone to make mistakes. If you ever make a mistake like this, always just redo the math. You already did the hard part here, and this is fairly obviously correct. This is where you make the mistake, so you would just have to simply pull it to the side and try it again. And you will experience that on test day. You will make at least one mental mistake. Okay, a road map is drawn on the scale of 1 inch equals 10 miles. When planning your trip, you notice that you'll have to travel 10 inches on the map to the first turn, 7 inches to the second turn, and then 15 inches to your destination. Your car gets 28 miles per gallon, and gas costs $2.73 per gallon. How much gas money will you need to spend for round trip? Whenever you hear miles per gallon, always think miles divided by gallon. And you'll see why in just a minute. But whenever you hear how much does it cost per gallon, or miles per gallon, always think miles divided by gallon. You'll never go wrong if that immediately pops into your head. So let's do a little sketch. You start here. You go 10 miles to your first turn. Let's say you make a turn to the right. You go 7 more miles to your second turn. Then you go 15 miles to get to your destination. And then you make the round trip, which is basically the same way back. So we're going to have to double this. We know 1 mile represents 10 miles according to our scale. So in total we went 10 plus 15 plus 7. Let's go ahead and add that up. That's 25, 26, 27, 28, 29, 30, 31, 32. That's 32 miles one way to go round trip. That is this way once, this way back. We have to multiply it by 2. So that's going to be 4, 6. So we traveled a total distance of 64 miles. Okay. And again, we know this is 1 mile equals 10 miles. So we're just going to add a 0 onto that. So we traveled a distance of 240 miles. Again, these are inches. So this should have been 64 inches, which is 640 miles. Okay. You get 28 miles per gallon, and gas cost $2.73 per gallon. How much did you spend? Okay. So we got to take this 640 divided by 28. This is going to give us how many tanks of fuel we used, and then we'll multiply that by 273. Okay, so we need to say how much our 28 times what gives us 64, or what gets us closest to 64. Let's try 2, and if not, we'll drop down to 1. This is 8 times 2 is 6, carry the 1. 2 times 2 is 4, plus 1 is 5, so this is going to be 2. It's going to be 56. Subtract it. 64 minus 56 is going to be, let's see, we're going to have to borrow 10 from there. This is going to become a 5. This is going to become 14. That's going to be what? 6 plus 6 is 12. 6 plus 8 will get you 14. 5 minus 5, 0. Drop down this 0. So now we're saying to ourselves, 28 times what will give us 80 or closest to 80? Well, 30 times 2 will give you 60. 30 times 3 will give you 90. So if we were to do 28 times 3, that would probably put us over. Let's just confirm that. 8 times 3 is 24. 2 times 3 is 6, plus 4 is 84. That puts us over, so we're going to have to do another 2 there. And we know that's going to get us 56. So 2 times 28 is 56. Subtract this out. This drops down to 7. This becomes a 10. This is 4. 7 minus 5 is 2. And we drop down an imaginary 0 because we're going to need it. Okay. And now we're actually going to be working on decimals here. So we're at 28 times what will get us close to 240? Well, 30 times 7 would get us 21. 30 times 8 would get us 240. So let's go with 28 times 8. 8 times 8 is 64. 8 times 2 is 16. Plus 6 is 22. So this actually gets us 224. Subtract. So we know this is going to be 0.8. Let's go ahead and take it to another decimal place, and then we'll stop and round, because as long as we got one decimal place, we know our answer is not going to be way off. We can't take away 0 from 4, so let's make this as 3 and this a 10. It's going to be 6. This is going to be 1. So 2 minus 2 is 0. Let's bring down another 0. 28 goes into 160. Well, 28 times, or 30 times 5 would get us 150. So let's go with 5. So we know this number is, if we round it, is going to be 22.9. Okay? And again, I'm just rounding to one decimal place. When you round, if it's a 5 here or greater, it kicks this up to the next digit. If it's a 4 or later or lower, you would just leave it as the 8. So now we know how many tanks of fuel it takes to go the 640 miles round trip. Let's take 22.9 and multiply it by 2.73 $. Let's move our decimals to make the math easy. 1, 2, and 1. So we moved it 2 here, 1 here, a total of 3. I'm going to rewrite it just so I don't make mistakes. This is 273 times 22.9, or 229. Again, we're working with 3-digit multiplication. Take your time. You can make mistakes pretty easily. And again, we moved it 3 decimal places, so we'll have to add those back in at the end. 9 times 3 is 27. Carry the 2. 9 times 7 is 63. 64, 65. Carry the 6. 9 times 8 is 18. Plus 6. 18, 19, 20, 21, 22, 23, 24. Bring down a 0. 2 times 3 is 6. 2 times 7 is 14. Carry the 1. 2 times 2 is 4. Add 1 is 5. Add 2 zeros now, since we're working with the 3rd digit. 2 times 3 is 6. 2 times 7 is 14. Carry the 1. Again, that's going to be 5. Add it up. 0 plus 7 is 7. 5 plus 6 plus 0 is 11. Carry the 1. 6 plus 4 is 10. Plus 4 plus 1 is 15. Carry the 1. 5 plus 4 is 9. Plus 1 is 10. Plus 2 is 14. 5 plus 4 is 9, plus 1 is 10, plus 2 is 12. Carry the 1. So this is going to be 62.517. I must have made a mistake somewhere, but the answer fairly obviously is going to be 62.14. Let me just grab a calculator to check my work. Okay, so I'm confident about the 640. Let's go ahead and check my math here. 640 divided by 28, 22.85, which I got right. I rounded it to 22.9, and I multiplied that by 2.73, which should give us 62.51. Let me check my math up here. 10 plus 7 plus 15, 32 times 2, that's 640 times 10, 640, we know it's 28 miles per gallon. Okay, 22.857. Let's not round it this time, and let's just multiply this by 2.73. Gets us 62.4. Okay. So in other words, they used a different rounding than we did. This 62.5 is different than 62.41 because of a rounding error. They should have told you to round to a specific number here, which I did not do. So we actually did this correct. And in the real ASVAB, you're going to see that sometimes these problems get very tedious, and sometimes you choose to round one way, but they rounded another way. As long as you're confident with your math and you get something close, you can chalk up the difference to a rounding error, which is what happened in this case. The smoke detector in your house has a malfunction and beeps every 5 minutes. If it first beeps at 10 p.m., how many times will it beep by 4 a.m. when you finally give up and take a hammer to it? So first, let's go from 10 to 4 and count how many hours that is. So we go 10 to 11, 11 to 12, 12 to 1, 1 to 2, 2 to 3, and 3 to 4. That's 1, 2, 3, 4, 5, 6 hours. Okay, so you finally smashed your alarm clock or smoke detector after 6 hours. Every 5 minutes it beeps. How many times does it beep in 6 hours? So we have this in hours and this in minutes. Let's make sure our question we're working with the same units. So 6 hours is the same as 6 times 60 minutes. Again, there are 60 minutes an hour. So 0 times 6 is 0. 6 times 6 is 36. There are 360 minutes in 6 hours. Those are equivalent. We know it's beeping every 5 minutes, so let's take this 360 divided by 5 to find out how many times it beeps total. 5 doesn't go into 36 or 3, but it does go into 36 7 times. 7 times 5, of course, is 35. Subtract that out. 36 minus 35 is 1. Bring down this 0. Just drag it down. 5 goes into 10, of course, just twice. So over the course of 6 hours or 360 minutes, it's going to beep 72 times. A display is selling bunches of bananas. A display selling bunches of bananas contains 6 dozen banana bunches when the display is full. The manager of the produce department is supposed to make sure the display is restocked when it is 1/4 full. How many bunches of bananas will be on display when it's time to restock? So we know there's 6 dozen bunches. So in other words, there's 12 times 6 bunches, which we just saw in the last problem is 72 total bunches. The manager has to restock when it reaches a quarter full. So 72 times 1 over 4 will get us that number. 72 can be thought of 72 over 1. When you multiply fractions, you multiply straight across. So you get 72 over 4 when you multiply straight across, which is the same as 72 divided by 4. 72 going to 7 just once. 4 times 1 is 4. Subtract 3, and you bring down the 2. 4 goes into 32, of course, 18 times. So the manager will restock when there's a quarter or 18 banana bunches on display. Ron and Joy own a condo together. They decide to sell for $200,000. The two decide to split the proceeds according to the ratio of money each invested into the property. Rod put the most money at a ratio of 5 to 3. How much money should Joy get from this sale? Okay. So this one's tricky. You have to know how to set these problems up to get them right. We know the ratio is 5 to 3. We're given that. But what does that mean in terms of setting up this problem? If I were to do 5 over 3 equals x over 2,000 or 200,000, I'd be thinking on the right track. But this ratio does not hold true. This says 5/3 equals x over 200,000, which is not what we're looking for. To think about this one a little better, let's add these two. 5 plus 3 is 8. So we know Joy's share is going to be 3 to 8, whereas Rod's share is going to be 5 to 8. And when you think about that, when you add those two together, that's a total share of 8 to 8. Okay? Again, this is Joy here, so using 3 over 8 equals x over 200,000. Now we can find the right answer. Again, you're on the right track here, but you had to think about it in this way. So let's go ahead and do that. We cross multiply in this case. That gives us 8x equals 600,000. So let's go ahead and work this out. 600,000 divided by 8. 8 does not go into 6, but 8 goes into 60, I believe, let's say 7 times. Okay, and it goes in 8 times 7 is going to be 56. Subtract that out. 60 minus 56 is 4, and we just drag down these zeros. So we have 1 0, 2 0, 3 0, 4 zeros. 8 doesn't go into 4. 8 goes into 40 5 times. 8 goes into 40,000 5,000 times. Okay? Subtract that out. We can see there's no remainder. So as far as Joy is concerned, she's going to get a share of $75,000. That's directly proportional to the deal they made and the amount they invested. On a trip, you drive 350 miles at an average speed of 60 miles per hour. Then you return home driving an average speed of 70 miles per hour. How long did it take you to complete the trip? Again, it's asking you how long. It's giving you a rate, but not the distance. So we're going to be working again with the distance equals rate times time problem. Let's sketch it out to see if it makes sense. What does give us the distance and rate? We don't know the time. We know leaving, we go 350 miles and we travel 60 miles per hour, and coming home going the same distance we go 70 miles per hour. So you can do this of one of two ways. You can either combine the problems or you can just do them separately. That is, you can solve this DRT problem and then this DRT problem and then add them together, and that, it turns out, is the simplest way to do it. So for the first one, we know we went a distance of 350 miles. We know we traveled at 60 miles per hour. We don't know how long this first trip took, so let's go ahead and solve for t in this case, and this is an equal sign. To get t by itself, we first subtract both sides by 60. So that gives us t equals 350 divided by 60. To make this math easier, I'm going to kick off these zeros and I'm going to do the long division. 35 divided by 6. 6 does not go into 3, but 6 goes into 35. 6 times 6 is 36. 6 times 5 is 30. So we're going to subtract 30 away. 35 minus 30 is 5. Carry down a 0. 6 goes into 50. 6 goes into 50, not 10 times. 6 times 10 is 60. 6 times 8 is 48. Okay. So let's go ahead and subtract that out. That's going to be 2. Bring down a 50 minus 48 is 2. Bring down an imaginary 0. 6 goes into 23 times. 6 times 3 is 18. Subtract that. 18 minus 20 is 2. Carry down a 0. And so this is just going to repeat. So we can actually round this to 5.8 hours. The first trip takes us approximately 5.8 hours. Let's go ahead and work out this second trip. Hopefully it works out as a whole number. Again, we know we're going a distance of 350 miles. We're traveling 70 miles per hour. We don't know how long it's going to take. Okay. Again, to get t by itself, we divide both sides by 70. This goes away. This becomes, if you look at it, 35 divided by 7. 35 divided by 7 is just 5. So we know t in this case is 5 hours. So we have 5.8 hours and 5 hours, which is going to be 10 point something hours. It's not going to be, it's going to be 10.8 hours. Okay? And we're done. Again, we work both problems separately, and then at the end just combine the hours together, and we were done. Okay, an empty 50-gallon barrel weighs 35 pounds. When completely filled with water, the barrel weighs 455 pounds. Assuming these factors to be true, approximately how much does 1 gallon of water weigh? So we got some barrel that looks like this. Let's imagine it's a steel barrel. We know that when it's empty, the steel barrel weighs 35 pounds. So that should be a B. So the steel, or the barrel itself, weighs 35 pounds. With 50 gallons of water, it weighs 455 pounds. How much does each gallon weigh? Well, first we got to subtract out this weight of the barrel. Okay? So 455 minus 35, 5 minus 5, 0. 5 minus 3 is 2. Still left with a 4 there. So the weight of the water inside this barrel is 420 pounds. We know there are 50 gallons of water, but we want to find out how much 1 gallon weighs. So we're going to take 420 and divide it by 50. To keep the math simple, we're going to kick off these zeros. 5 goes into 4. It doesn't. 5 goes into 42 8 times. Take a look. We can already stop if we wanted to, but let's keep working. 8 times 5 is 40. Subtract. Again, since we're going past that, we're going to need to drop a decimal in our answer. 42 minus 40 is 2, of course. Add a 0 down. 5 goes into 24 times, 8.4 pounds. If you're traveling in a car, traveling 50 miles per hour, how far have you traveled in 45 minutes? Again, we're given rate, 50 miles per hour, time, 45 minutes, and we want to know the distance. So again, this is a DRT problem. Distance equals rate times time. And at the beginning of this video, I warned you, if something's in miles per hour and you're given minutes, you need to convert those minutes to hours to get the problem correct. In other words, you have to keep miles per hour with hours. If this said miles per minute, you would be fine. But since this says miles per hour, we need to convert this to hours. Okay, so let's go ahead and do that. 45 minutes. How many hours is that? Well, we know there's 60 minutes in an hour. Okay. And we can reduce this. 15 goes into 45 3 times. 15 goes into 60 4 times. So 45 minutes is 3/4 of an hour. Okay. So now we can use this number and plug it in our formula to find our distance. So distance unknown equals 50 times 3/4. Okay, let's go ahead and do this math. 50 times 3/4 is the same as 50 over 1 times 3/4. Multiply straight across. This is the same as 150 over 4. Are the same as 75 divided by 2. Let's go ahead and work that out. But it should be fairly obvious that it's going to be 37.5. 75 divided by 2. 2 goes into 7 3 times without going over. 2 times 3 is 6. 7 minus 6 is 1. Bring down our 5. 2 goes into 15 7 times without going over. 2 times 7, of course, is 14. Subtract. That's 1. We're going to drop down a 0. 2 goes into 10 5 times. So 37.5 miles per hour. Okay. If an average person eats 6.7 pounds of French fries per year, how much would that average person consume in a decade? There are 10 years in a decade, so this problem becomes 6.7 times 10. And since I've been showing you how to do multiplication with decimals, move this over 1, add it back in at the end. So 7 times 0 is 0. 6 times 0 is 0. Bring down a 0 since we're starting a new row. 7 times 1 is 7. 7 times 6 is 6. Add. 0 plus 0 is 0. 0 plus 7 is 7. 0 plus 6 is 6. And bring back in our 1 decimal. And the answer is 67 pounds. Okay. Maloney has 11 more nickels than quarters. How many quarters does she have if the total value of her coins is 265? These problems, it turns out, are very tricky. We know a nickel is worth 5 cents, which is 0.05, and we know a quarter is worth 0.25. Okay. We don't know how many quarters or nickels there are total, so let's represent the unknown as an X, but we know combined there's a total of $2.65. $2.65. We're given this little tidbit of information that kind of throws us for a loop initially. Maloney has 11 more nickels than quarters. So we kind of got to work that into our equation or deal with it before we can work anything out. What I'm going to do is the easiest way to work this problem. So we know this would get us the number of nickels and quarters there are total, excluding the 11, right? to address the 11, let's just get rid of those out of the total right away. We know there's at least 11 nickels in this pile. So 11 times 0.05. Okay, move it 2 decimal places to give you just 5. Let's rewrite it to make it nice. 11 times 5. 1 times 5 is 5. 1 times 5 is 5. Throw your 2 decimal places back in. 1, 2. So we know at the very minimum there's going to be 55 cents in nickels that are extra. So let's go ahead and take that away from our 265. So we don't have to worry about them when we work this problem out. 265 minus 0.55, 5 minus 5 is 0, 6 minus 5 is 1, bring down your decimal, 2. So now let's rewrite this, excluding the 11 nickels that we're not worried about. 0.05x plus 0.25x equals 2.10. Okay, let's solve for x. 0.05 plus 0.25 is 0.30x equals 210. Oh, I don't know why I put an 8 there. Now let's think about this. 0.3 or 30 cents into 210. That is actually going to be, x is going to be 70. You don't really have to do the math. 7 times 3 is 21. 7 times 30 will get you 210. So we know that, oh, it's just going to be 7. Not 70. Why did I put that? So 7 times 30 will get you 210. So 7 times 0.3 will get you 2.10. Okay? Again, x represents the number of quarters and nickels. So let's see where we're going from here. We're going to say x represents the number of quarters that are in the pile. So if there are 7 quarters, there are 11 more nickels. So 7 plus 11 is going to be 18. And let's work that out. So if there are 7 quarters, that's 6 quarters would be $1.50. 7 would be $1.75. And that means there are 18 nickels. 18 times 0.05. 8 times 5, of course, is in 2 decimal places to make this just 5. 8 times 5 is 40. Bring over our 4. 5 times 1 is 5 plus 4 is 9. Bring over 2 decimals. 175 plus 90. Let's see if that adds to 265. Five plus 0 is 5. 7 plus 9 is 6. Carry the 1. 1 plus 1 is 2. Okay, so we know this represents the number of quarters, whereas this represents the number of nickels, so the answer is C. A little confusing there, but I think you, at the end of the day, will get these problems. And on that note, that's all I have for you. If you have questions, concerns, or comments, feel free to put those in the comments section below or to send me a private message. But apart from that, I am going to cut you guys loose. Welcome YouTubers to another episode in my Grammar Hero series. In this video, I'm going to work out a full-length practice test for the mathematics knowledge section of the Armed Services Vocational Aptitude Battery, that is the ASVAB. Before I do that, I just want to make a few comments about the ASVAB itself. First, I want to point out that the ASVAB is a computer adaptive test that's comprised of 10 different subsections, including general science, arithmetic reasoning, word knowledge, paragraph comprehension, mathematical knowledge, and so on. It's a test for which you'll have 154 minutes to complete 145 questions. And in addition to receiving a score for each of these 10 subtests, you'll also be given a AFQT score, that is an Armed Forces Qualification Test score. Above all, I want to stress that the AFQT test score is the score that says, yes, this person's qualified to join the military, or no, this person's not qualified to join the military. The AFQT is derived based on your score on 10 different subtests, namely arithmetic reasoning, word knowledge, paragraph comprehension, and mathematical knowledge. My advice to anyone who's preparing for the ASVAB is this. Focus 100% of your efforts on doing well on these 4 subtests and disregard all the other subtests. In preparing for these subtests, you should be able to maximize your AFQT score, and the higher you score in terms of your AFQT score, the more job opportunities that will open up to you. As far as the AFQT score itself goes, I just want to point out that it's a percentile-based score. So, for example, if you score a 50, that means, in other words, you've scored better than 50% of all test takers. Ideally, you want to score in category 3B or above. That is, you want to score somewhere between 31 and 99. Okay? All that said, let's go ahead and get started with this guided practice. As is the case for all the subtests on the ASVAB, you're not allowed to use a calculator. Instead, as you'll see in just a minute, you'll have to rely on your ability to do arithmetic to work out all these problems. Okay? So question number 1, which of the following fractions is the largest? So this is testing your knowledge of fractions. In case you forgot, all fractions can be regarded like this. Let's say I said what's 10%. You can put 10 over 100, and that would be the fraction. Again, all fractions can be put over 100. If I told you what is 70%, that would be, of course, 70 over 100, okay? So using this tidbit of knowledge, let's go ahead and approach this problem. Let's take a look. 13 over 20. If we were smart, we would say 10 over 20 is 1/2, which is 50%. So we know that this is slightly larger than 50%. At the same time, we could also say that 15 over 20 is 3/4, which is 75%. So this is somewhere between 50 and 75%. Again, in light of the fact that all fractions can be put over 100, let's go ahead and see what we can do here to make this easier to understand. So if I wanted to know what specifically this fraction was, there's 2 ways I can do it. I can either do long division or put it over 100. Let's go ahead and put this one over 100, since we know 20 goes into 100 5 times. And let's go ahead and multiply top and bottom of this fraction by 5. 20 times 5, of course, is 100. So you can see we're going to get a percentile pretty easily for this one. 13 times 5. 5 times 3 is 15. Carry the 1. 5 times 1 is 5, plus 1 is 65. So we know that 13 over 20 is the same as 65 over 100, which is the same as 65%. Okay? We can do the same thing with 3/5. 20 goes into, or 5 goes into 100 20 times. So let's multiply top and bottom by 20. 5 times 20 is 100, of course. 3 times 20 is 60. So we know that this is going to be 60%. 13 over 16. Now this is a case where we may not be able to, where 16 doesn't go into 100 evenly. So let's go ahead and instead of trying to put this fraction over 100, which we can't do easily in this case, let's go ahead and do long division. We would read this as 13 divided by 16. In other words, 13 divided by 16. We would say to ourselves, how many times does 16 go into 13 without going over? It doesn't. So we add a 0. We bring up a decimal place. Now the question is, how many times does 16 go into 130 without going over? Again, this is 65%. This is 60%. 3/4 we know is 75%. So if this decimal turns out to be 0.8 or greater, we know this is going to be our biggest fraction. Let's go ahead and, in light of that, multiply 16 times 8. See what that gives us. 8 times 6 is 48. Carry the 4. 8 times 1 is 8 plus 4, 8, 9, 10, 11, 12. So 16 times 8 is 128, which is less than 130. So let's go ahead and use that. 16 times 8 again is 128. Subtract. We're left with 2. 130 minus 128 is 2. Drop down to 0. 16 goes into 20 once. So we know that this one is going to be 81%. Okay, which, as we can see, is the largest fraction. Again, to make fractions easy, you have one of two choices. Do the long division, which I did for part C, or try to put the fraction over 100. If you do those two things, fractions should be fairly easy. Okay. Let's go ahead and jump to number 3. I'm going to work this practice test out of order just to keep things simple. Number 3 says convert 62% into a fraction. Again, as I said over here, you can put these numbers, percents, over 100 to get your fraction. So let's go ahead and do 62 over 100. We can see that this isn't one of our answer choices because this fraction isn't in reduced form. That is, it's not simplified. So now we have to look for a factor that can go into the 62 as well as 100 to reduce this. I know 2 goes into 62 as well as 100. So I'm going to divide top and bottom by 2. 100 divided by 2, of course, is 50. 62 divided by 2, let's do the long division. 2 goes into 6 3 times. 2 goes into 2 1 time. So we know this is going to be 31 over 50. 31 is a prime number, which means we cannot reduce this any further. And we can see that that is, of course, one of our answer choices. All right. Number 2 is a fairly simple problem. Let's just go ahead and work it out. Again, especially early on in your math computation test, you're going to be given some simple problems. And as you get those right, the problem should get more difficult. So 173 plus 150. 3 plus 0 is 3. 7 plus 5 is 12. Carry the 1. 1 plus 1 is 2. Plus 1 is 3. So this is 323. Number 4, the sum of the measures of the angles in the shape below is, okay, so we can see we have 4 angles, so this is a quadrilateral. There, it turns out, is a formula you need to know to figure out the sum of the measures of the angles in any shape, and it's this. It's 180 times n minus 2, where n is the number of sides in the shape. So a triangle has 1, 2, 3 sides. If we were asked to find the sum of the angles in a triangle, we would do this. We would do 180 times n, number of sides, 1, 2, 3. 3 minus 2. 180, 3 minus 2, of course, is 1. So the number of the sum of the measures of an angle in a triangle is always going to be 180. Similarly, the sum of the measures in any quadrilateral is always going to be 360. Doesn't matter if it's a square, a parallelogram, a rhombus, or so on. Again, let's just go ahead and plug that into this formula here. Here's 1, 2, 3, 4 sides. So we have 180, 4 minus 2. 180 times 4 minus 2, of course, is 2. So 180 times 2 is 2 times 0 is 0. 8 times 2 is 16. Carry the 1. 2 times 1 is 2. Plus 1 is 3. Okay? As a hypothetical, let's say the question asked you to find the sum of the measures of the angles in a decagon. A decagon has 10 sides. Now that you know this formula, the problem becomes very simple. So you would just do 180, 10 sides of a decagon minus 2, 180 times 8. Work that off to the side. 8 times 0 is 0. 8 times 8 is 64. Carry the 6. 8 times 1 is 1. Plus 6, 8, 9, 10, 11, 12, 13, 14. So that would be 1440. Again, if you can commit this formula to memory, it may be helpful. In addition to seeing questions like this on the ASVAB, you should also see questions like this on the SAT. So very simple formula. The concept's very easy to understand, especially when you link it to your knowledge of triangles. So again, just try to memorize this formula. Number 9, what is the point plotted on the chart below? It's referring to this point right here. The way ordered pairs works is like this. You have an x-coordinate and a y-coordinate. Of course, the x is how far left and right you go, whereas the y-coordinate is how far up or down you go. And here's the y-axis and the x-axis. Specifically, this would be y positive, y negative, x positive, x negative. So let's take a look. And you always go left and right first and then up or down second. So to get to this point, we're going to go 1, 2, 3, 4 to the right, which we can see is x positive. So this is going to be 4. And then down 1, 2, which is toward the y negative. So this is negative 2. 4, negative 2. Again, another simple problem. You'll see those on the ASVAB. What is the next number in the following sequence? We have 1, 8, 27, 64, and 125. The problem with sequence problems is there's no real formula to solving these. There's no mathematical knowledge that's going to help you see this pattern. You just have to play with the numbers in your mind until you actually figure it out or see it. In this case, I recognize 8, 27, and 64 and 125 as cubes. Specifically, 1 cubed equals 1 times 1 times 1, which is just 1. 2 cubed is equal to 2 times 2 times 2, which is 8. 3 cubed is equal to 3 times 3 times 3, which is 27. 4 cubed is equal to 4 times 4 times 4, which is 64. 5 cubed is equal to 5 times 5 times 5, which is 125. So we know the next number in the pattern is going to be 6 cubed. So let's work that out to the side. That's going to be 6 times 6 times 6. 6 times 6 is 36. Times 6 is going to be 36 times 6. 6 times 6 is 36. Carry the 3. 6 times 3 is 18, 19, 20, 21. So we know this is going to be 216. Number 10 is a very difficult problem. It says add all the numbers between 1 and 300. Again, this is a question for which you need to know a formula, namely this one. N first plus last divided by 2, where n is the total number of numbers between these two numbers. So between 1 and 300, there are 300 different numbers. Let's plug that into the formula. First number is 1. Last number is 300. We divide by 2. So this becomes 300 times 301 divided by 2. Let's go ahead and work this out. 301 times 300. 1 times 0 is 0. 0 times 0 is 0. 0 times 3 is 0. Drop down to 0 since we're starting the second number here. 1 times 0 is 0. 0 times 0 is 0. 0 times 3 is 0. Drop down 2 zeros since we're starting the third number. 3 times 1 is 3. 3 times 0 is 0. 3 times 3 is 9. Okay? Just add. So this is 90,300 divided by 2. Let's go ahead and work that out. There's two ways to think about this one. You can think about 90 divided by 2 and 300 divided by 2. 90 divided by 2, of course, is 45. 300 divided by 2 is 150. So we know that this is going to be 150. 45,150. Or we can actually do the math, the long division. And again, we would go 9 goes into 2, how many, or 2 goes into 9, how many times? 2 times 4 gets you 8. 9 minus 8 is 1. Drop down to 0, drop down to 3, drop down to 0, drop down to 0. 2 goes into 1, it doesn't. 2 goes into 10 5 times. 2 times 5, of course, is 10. Subtract 10 minus 10 is 0. Drop down to 3, drop down to 0, drop down to 0. And then you could just say 2 goes into 300 150 times and be done. Okay, so either way, you can either do this one mentally or you can work out the long division. Okay. Number 12, what is the average of 53, 27, 32, and 41? So to find the average, you add all these numbers up and divide them by the total number of items, or the total number of numbers themselves. So there's 1, 2, 3, 4 numbers. So this is going to be, in other words, 53 plus 27 plus 32 plus 41 divided by 4. Again, there are 4 numbers here. To find the average, we add them all up and divide by how many numbers there are. Let's go ahead and work this off to the side. Uh, 7 plus 3 is 10, plus 2 is 12, plus 1 is 13. Carry the 1. 5 plus 2 is 7, plus 1 is 8, plus 3 is 8, 9, 10, 11, plus 4 is 15. So this becomes 153 divided by 4. Let's do the long division there. 4 goes into 15 3 times without going over. 4 times 3, of course, is 12. 15 minus 12 is 3. Drop down this 3. 4 goes into 33 8 times without going over. 4 times 8, of course, is 32. 33 minus 32 is 1. Drop down to 0. Since we drop down to 0, we know we have to place a decimal here. 4 goes into 10 2 times without going over. And we can see right here that this is going to be the answer. but I'll go ahead and work it out. 4 times 2, of course, is 8. Subtract. 10 minus 8 is 2. Drop down to 0. 4 goes into 25 times with no remainder. Okay? Let's make sure I did all these other ones. What is the area of the shape below? So in this case, we don't know how to find the area of this big shape. Instead, we have to break this big shape down into two shapes, namely a square and a rectangle. So I'm going to make a cut right there. If this entire thing is 8 inches and this is 1 inch, we know that from here to here it's going to be 7 inches. Okay? So in light of that, we're going to find the area of this shape and the area of this shape and then add them together. Area, of course, for a square and a rectangle is either side times side for a square or length times width for a rectangle. We can see this is a 1 by 1 square, so the area is going to be 1 times 1. We can see this is a 7 by 10 rectangle, so the area is going to be 7 times 10. 1 times 1, of course, is 1. 7 times 10 is 70, so we know 70 plus 1 is going to be 71 inches squared, which is 71 square inches. Same thing. Okay? Fairly simple problem. Whenever you're given a problem like this, you have to be comfortable slicing the shape into things for which you can find the area, namely squares, rectangles, and circles. Okay, so number 7, convert 11 over 4 into a mixed number. So the way you do this is via long division. Again, you can read this as 11 divided by 4, which looks like this. 4 goes into 11 twice without going over. 4 times 2, of course, is 8. So we can get rid of number 1, and we can get rid of A and D right away. We know this is going to be 2 something. And let's take a look. A mixed number is always a fraction. This is a decimal, so we're going to get rid of that one too. So without doing too much more work, we know the answer is going to be C. But let's go ahead and work this one out just to see what it looks like. 8 minus 11 is 3. 4 doesn't go into 3, so we would have to drop down a 0 and add a decimal if we were trying to find the decimal answer. But in this case, 3 is going to be the remainder. We're going to take this 3, put it over the divisor, 4 in this case, and that's going to be our mixed number. So it's going to look like this: 2 and 3/4. Again, remainder over divisor. Let's try another one. Let's do 13 divided by 4. 4 goes into 13 3 times without going over. 4 times 3 is 12. 13 minus 12 is 1. 4 doesn't go into 1, so this is our remainder. To make this a mixed number, we're going to take this 1 and put it over this 4, so this becomes 3 and 1/4. Okay? So again, mixed numbers are fractions with remainders over divisors. Number 6, the square root of x squared. You can view square roots as this, to half power. Anything to the half power is a square root. So in other words, this problem looks like this: x squared to the half power. Your knowledge of the rules of exponents should tell you this. When you have something like this, x2 times x3, you would add these exponents, so this would become x2 plus 3, or x to the 5th. When you have a power raised to another power, you multiply the exponent. So this would be x squared times 1/2. 2 times 1/2, of course, would just be 1, so this becomes x to the 1. You don't see that as an answer choice, but you do right here. Now, if I were to put in a negative as this square, I would get the same answer as if I put a positive, so we know that this one can be plus or minus x. And let me just work that out. Let's say I let x equal -3. Again, let's plug it into this. Again, let's say I let x equals -3 and x equals 3. Again, we're going to plug it into this formula. So this would be 3 squared, or -3 squared. This would just be 3 squared. Anything squared is positive because this is -3 times -3. So this would just be the square root of 3. Or this would be the square root of 9, which would be 3. And this would be the square root of 9, which would just be 3. So we know that A is the correct choice. Okay, number 8, convert, let's see, 317,400,000,000 to scientific notation. We always know scientific notation is going to be in this form: some number to the decimal followed by some other numbers times 10 to some power. Okay? It's never going to be xx dot something. It's always going to be in this form: one whole number followed by decimals times 10 to the negative to some power. The way this works is as follows, and I'm just going to do a simple example with you. Let's say I wanted to convert 54,000 to scientific notation. This would be 5.4 times 10 to the, let's say the decimals there, 1, 2, 3, 4th power. Okay, again, the way this works is if this is positive, if this exponent is positive, you move the decimal place to the right that many times. If this decimal were negative, let's say I had 5.4 times 10 to the -4th, this would actually take this decimal and move it to the left 4 times, so this would go 1, 2, 3, 4, which would be 0.00054. Again, positive decimal moves it to the right, negative exponent moves it to the left. So in this case, all these that have commas right here, first of all, are wrong. Again, it's always going to be in this form: whole number, decimal, remaining of the whole number. So these two are wrong. This one is going to make it a small number like this one, so we know that this is the correct number. Let's go ahead and just work that out. 3.174 times 10 to the 11th. So this says we're going to take this decimal and move it to the right 11 times. Let's go ahead and do that to confirm that it is our answer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so this becomes 1, 2, 3, 1, 2, 3, 1, 2, 3. We can see that this is the same number as this one. Okay. Let me go ahead and erase this work real quick. Okay, so this one says 8 yards plus 15 feet. We can't add yards and feet since those are different units of measurement. So in this case, we're going to have to convert yards to feet or feet to yards and then add accordingly. I know there are 3 feet in 1 yard. Oh, let me fix this real quick. So, in light of that, I'm going to convert yards to feet and then add accordingly. More specifically, I'm going to do 8 times 3, because there are 3 feet in every yard, plus 15. 8 times 3 is 24, plus 15. Let's work this out. 4 plus 5 is 9. 2 plus 1 is 3. So this becomes 39 feet. Number 15, y to the 5th times y to the 3rd. Again, as I mentioned earlier, when you multiply exponents, when you multiply terms that have exponents, you add their exponents. So in this case, this would be y to the 5th times y to the 3rd, which would be the equivalent as y to the 5th plus 3 or y to the 8th. Okay? Again, just for comparison's sake, if this was y to the 5th to the 3rd, this would be y 5 times 3 or y to the 15th. If an exponent's raised to an exponent, it's multiplication. If you're multiplying like terms with exponents, you add them. So again, this is y to the 8th. Find the arithmetic mean of 4 and 9. So this is going to be 4 plus 9 divided by 2. Again, there are two numbers, 1, 2. You add them together and divide by how many there are. 4 plus 9 is 13 divided by 2. Let's work this out using long division. 2 goes into 13 6 times without going over, so right away we know all these are wrong. 6 times 2, of course, is 12. Subtract 13 minus 12 is 1. 2 doesn't go into 1, so we have to drop down to 0. We add a decimal. 2 goes into 10 5 times, so this is 6.5. Same thing here. This is going to be 5 plus 25 divided by 2. 5 plus 25 is 30 divided by 2, which is just 15. The shape below is a, let's see, 1, 2, 3, 4, 5. Has 5 sides, so it's a pentagon. So again, 3 sides is a triangle, 4 sides is a quadrilateral, 5 sides is a pentagon, 6 sides is a hexagon, 7 sides is a decagon, 7 sides is a septagon, not a decagon. 7 sides is a septagon, 8 sides is an octagon, 9 sides is a nonagon, and 10 sides is a decagon. If you know 1 through 10, you'll be fine. Or 2 through 10. Actually, 3 through 10. I misspoke. This one's testing your, number 19's testing your knowledge of being able to add like terms. So we have 4 minus 2x squared minus 7x plus y plus 2x squared plus 5xy. Again, all you're going to do is find like terms and add them. So here's a like term, negative 2x and 2x. Again, negative 2x squared plus 2x squared, this becomes 0, so they cancel each other out. We're left with negative 7xy plus 5xy. Of course, that's going to be negative 2xy. And there's no like term with 4x, so we just include that. So this is negative 2xy plus 4x, or 4x minus 2xy, which is right here. Let me erase this mark right here. Okay, so more questions with fractions. Let's just go ahead and see what we can do right off the bat to eliminate some bad answer choices. So let's see. 4 plus 1 plus 3. That's 5 plus 3, which is 8. So we know just by adding the whole numbers, this number is going to be greater than 8. So we know 6.5 is wrong right from the bat. Okay? There are two ways to add fractions. our mixed numbers rather, you can add the whole numbers separately and then add the fractions separately and then combine them. Okay, and that's what we're going to do in this case. So this is going to be 4 plus 1 plus 3, which is going to be 8. And then separately we're going to do 1/2 plus 2/5 plus 3/10. Okay. As far as adding fractions go, you can only add them if they have the same denominators. Okay. So in other words, we have to put all these fractions over the same denominator. To do that, we have to find a common multiple. So 5 goes into 10, 2 goes into 10, and 10 goes into 10. So let's put these all over 10. Since this one's already over 10, we'll just drop it down. 5 goes into 10 2 times. So to make this 5 at 10, I would multiply it by 2. When I do the bottom, I have to do the top. 2 times 2, of course, is 4. To make this base 10, or denominator 10, I would multiply 2 by 5. If I do the bottom, I have to do the top. 5 times 1, of course, is 5. Now we can simply just make it into this problem. 5 plus 4 plus 3 over 10. Again, this is 5 plus 4 is 9, 10, 11, 12 over 10. Again, this becomes 10 over 10 plus 2 over 10. Of course, 10 over 10 is 1 and 2/10, or 1 and 1/5. I just reduced 2 over 10 to 1/5. So let's go ahead and add this to our 8. 8 plus 1 and 1/5. This becomes 9 and 1/5, which is this one right here. Okay? And again, you could have thought about this 8 as this. 8 and 0 over 5 plus 1 and 1 over 5, which would just become 9 and 1 over 5. Okay, I skipped that step because I thought by now you should know it, but if you didn't, that's one way you can do it. Let's take a look at number 20. It says solve for x. We have x plus 3 cubed plus 2 times x plus 3 squared minus 8 times x plus 3 squared equals 0. So in other words, we want all this. We want to plug in a number for x such that this becomes 0 equals 0. Okay? Let's take a look here. We have x plus 3, x plus 3, x plus 3. If I let x be negative 3, this becomes negative 3 plus negative 3, which is 0. 0 cubed is 0. If I plug in negative 3 here, again, that becomes negative 3 plus positive 3, which is 0 squared times 2, which is 0. Again, if I plug in negative 3 here, I get negative 3 plus 3, which is 0 squared times 8 is 0. In other words, 0 equals 0. If negative 3 works, positive 3 must work, since that's the only 3 in our answer choice. And without doing any factoring at all, we've solved this problem using just logic. Again, on the ASVAB, you'll see questions in which they'll be very difficult to work out algebraically. In those cases, they're basically looking for you to find some shortcut, like I did in this case, to make the problem much simpler and quicker to work out. So again, always be mindful, if something looks hard, there's probably an easier solution to it. Okay, number 21 is in regard to factoring. It says a squared x minus bx minus a squared y plus by plus a squared z minus bz. We're asked to simplify or factor. So I'm going to factor by grouping. I can see that there are a's and b's in this problem. So let's go ahead and rearrange this problem like this. A squared x minus a squared y plus a squared z. And let's do minus bx plus by minus bz. Again, I just took these and I just took this equation and rearranged it so that all the a's are grouped together and all the b's are grouped together. I'm going to actually see if I can factor out an a squared from this group and a b or a negative b from that group. So let's factor out an a squared here. This leaves me with x minus y plus z. And if I factor out a negative b here, this leaves me with x minus y plus z. Let's take a look. Now in factoring by grouping, when these are the same, you know they're one factor and these two are the other factor. In other words, this would be a squared minus b, x minus y plus z. So we went ahead and reduced it to answer choice C by factoring by grouping. Fairly tough problem. If you were doing very well in the ASVAB, you might see something like that. 23, translate the following: n less than or equal to 15, n is less than or equal to 15. Pretty simple problem. Just read it out and select the answer choice accordingly. 22, what is the length of the sides of a square that has an area of 225 square inches? So again, we're dealing with a square here. We know the area of a square is side times side. We're told that or area equals side squared. So we're told that the area in this case is 225 square inches. So s squared equals 225, we're told. To find one side, we're going to take the square root of both sides. This becomes s equals the square root of 225, which of course is going to be 15. Okay. Again, you should be familiar with some common squares. Like 10 squared you should know is 100, 12 squared is 144, 13 squared is 169. You should know these, okay? That way when you get to something like this, you automatically know the answer. If you got to this and you didn't know what to do, you can simply do this. You can do 15 times 15, and then you would get 225, of course. So try to devote, I would say, 1 through 15 squared to memory. Okay? So 24, we have 5.12 times 10 to the negative 5. Again, since this is negative, as I mentioned earlier, we're going to move it this decimal to the left 5 times. 1, 2, 3, 4, 5, and fill in zeros. 1, 2, 3, 4. So this becomes 0.0000512, which is right here. Last problem, 93% of 75 is. In other words, what's 93% of 75? 75 times 0.93. Again, 0.93 is the equivalent of 93%. Move the decimal place over 2 to make this 93. At the very end, we'll move the decimals back in. So 5 times 3 is 15, carry the 1. 7 times 3 is 21, plus 1 is 22, bring down a 0. 9 times 5, of course, is 45, bring up a 4. 7 times 9 is 63, plus 4 is 67. Add. 5 plus 0 is 5, 5 plus 2 is 7, 7 plus 2 is 9. 6 plus 0 is 6. Bring our 2 decimals back in. 1, 2. This becomes 69.75, which is right here. Okay, so that's all I have for you for this video. If you found it helpful, of course, feel free to give it a thumbs up or leave some positive feedback in the comments section below. As a rule of thumb, I like to say that before you take the real ASVAB, you should take at least 10 practice tests. In each practice test, some concepts come up more than others. In this one, for example, you saw the area a lot, and we dealt with fractions quite a bit. So again, try to take at least 10 of these. I believe this will be my 5th or 6th mathematics knowledge video posted. Apart from that, I'll just say good luck on the ASVAB. If you need help, feel free to send me an email. But on that note, I'll go ahead and cut you loose. Welcome, YouTubers, to another episode in my Grammar Hero series. In this video, I'm going to be working out practice problems for the Arithmetic Reasoning section of the Armed Services Vocational Aptitude Battery, that is the ASVAB. Before I do that, however, I just want to take a few minutes to talk about the ASVAB itself. First, I want to point out the ASVAB is a computer adaptive test for which you'll have 154 minutes to complete 145 questions. In addition to receiving a line score for each of its 10 subtests, you'll also receive what's called an AFQT score. AFQT, of course, stands for Armed Forces Qualification Test, and it's the score that says, yes, this person's qualified to join the military, or no, this person's not qualified to join the military. The AFQT score is derived from your performance on the Arithmetic Reasoning subtest, the Word Knowledge subtest, the Paragraph Comprehension subtest, and the Mathematics Knowledge subtest. So my recommendation to anyone who's preparing for this test is to devote a significant amount of your studying efforts to preparing for these 4 sections. In general, the higher you score in terms of your AFQT score, the more job opportunities that open up to you. Again, the AFQT can be viewed in 2 ways. You're given a percentile score as well as placed into a category. For example, if you score a 50 in terms of your AFQT score, that means you have scored better than 50% of all test takers, and that would place you in category 3A. Okay, so all that said, let's go ahead and get started with today's guided practice. Okay, let me just maximize the page for you. Let me grab my pen now. Okay, great. Alright, so truthfully, to do well on the Arithmetic Reasoning section of the ASVAB, you need to be comfortable doing addition, subtraction, multiplication, and division, including with decimals and fractions. Okay, so throughout this video, I'm going to make an effort to describe each step that I'm taking. That way, if you're rusty with one of those things, you can probably pick it up just by watching me, and you won't necessarily have to go study a separate topic. The way you should use this video, what's more, is like this. As soon as I read a question, you should pause the video. And after you pause the video, you should make an effort to work out the problem yourself. Once you work out the problem yourself, go ahead and play the video and see if you and I come up with the same answer. And you can also at the same time see if you and I took the same approach to get the answer. In many cases, I'm going to give you the quickest route to the answer. And I'm also going to talk about some tips that will help you work accurately and intelligently throughout this test. So all that said, let's go ahead and get started with number 1. All right, question 1. If pencils are bought at 70 cents per dozen and sold at 3 for 20 cents, the total profit on 6 dozen is. So the first thing I'm going to do is multiply 70 cents by 6 dozen. Again, pencils are, we're told, 70 cents per dozen, and we're going to sell 6 dozen of them. The way you multiply decimals is like this. You actually turn the decimal into a whole number by moving its decimal. So in this case, I'm going to make this 0.70 to 70 by moving the decimal 2 places. So if I were to rewrite this, this would be 70 times 6, which we all know how to do. 0 times 6 is 0. 7 times 6 is 42. Add our 2 decimal places that we moved back in. 1, 2. So this becomes $4.20. In other words, it costs $4.20 to purchase the 6 dozen pencils originally. Now we're told we're selling the 6 dozen pencils 3 for 20 cents. So first we need to figure out how many pencils there are total in 6 dozen. So we're going to take 12, multiply it by 6. 2 times 6, of course, is 12. Carry the 1. 6 times 1 is 6, plus 2 is 7. So we know in 6 dozen pencils is the same as 72 pencils. And we're selling them 3 for 20 cents. So I'm going to take 72 divided by 3. 3 goes into 7 2 times without going over. Of course, 2 times 3 is 6. 7 minus 6 is 1. You want to bring down this 2. Now the question is, how many times does 3 go into 12? That is 4. Of course, 3 times 4 is 12. 12 minus 12 is 0. So we know there are 24 pencils. 24 sets of 3 pencils in 6 dozen. Now we're going to take 24 and multiply it by 20 cents. Again, like we did over here, we're going to turn this 0.20 into a whole number by moving it 2 decimal places. So this is going to become 24 times 20. 0 times 4, of course, is 0. 0 times 2 is 0. Bring down a 0 since we're starting this number. 2 times 4 is 8. 2 times 2 is 4. Let's add. 0 plus 0 is 0. 0 plus 8 is 8. 0 plus 4 is 4. Bring back in our 2 decimals. 1, 2. So this is our cost to purchase the 6 dozen pencils. This is what we're selling them for. As you can see, there's a 60-cent difference between $4.80 and $4.20. And if you need me to, I can work that out to the side. Got $4.80. That's what we profited minus our cost, $4.20. 0 minus 0 is 0. 8 minus 2 is 6. Bring down your decimal. 4 minus 4 is 0. Again, this is just 60 cents. Okay. Number 2, certain type of siding for a house costs $10.50 per square yard. What does it cost for the siding for a wall 4 yards wide and 60 feet long? Okay, so we're told the cost per square yard. We want to know what it costs for a wall that's 4 yards wide by 60 feet long. Well, you can't do this problem as it stands because we have something in yards, we have something in yards, and we have something in feet. So before we push forward, we need to convert either yards to feet or feet to yards. In this case, we have yards here, and feet here. So I'm going to make this 60 feet. I'm going to convert it into yards. Of course, we should know there are 3 feet in every yard. So what I'm going to do right out the gate is do 60 divided by 3. 60 divided by 3, of course, is 20. So instead of what is the cost for siding for a wall of 4 yards by 60 feet, this is 4 yards by 20 yards. Okay, now we're trying to find the area of a rectangle that's 4 feet wide and 20 yards long. 4 yards wide, 20 yards long. Sorry, I said feet there. To find the area of a rectangle, we do length times width, which is, let me write that out for you before I do it, length times width. In this case, that's 20 times 4, or 80. Okay, now we take this 80 and multiply it by our cost per yard, and we'll come up with our answer. So this is going to be 1050 times 80. And again, since we're multiplying a decimal, I'm going to move this 2 decimal places. So it becomes 1050, and I'll add the 2 decimal places back at the end. 0 times 0 is 0, 0 times 5 is 0, 0 times 0 is 0, 0 times 1 is 0. Bring down a 0 since we're starting this number. 8 times 0 is 0, 8 times 5 is 40, carry your 4. 8 times 0 is 0 plus 4 is 4. 8 times 1 is 8. Add. 0 plus 0 is 0. And we can see this is going to be just 8, 4. And I'm writing off to the side so I don't mess up the next problem. 8, 4, 0, 0, 0. Add our 2 decimals back in. 1, 2. And we can see that this is going to be $840. Okay? Again, the trick there was to convert feet to yards and then find the area accordingly and multiply that by the cost per yard, square yard. Number 3, a parcel delivery service charges $9.26 for their first 4 pounds of package weight, an additional $1.06 for each half pound over 4 pounds. What is the charge for a package weighing 6.5 pounds? So we know right off the bat the first 4 pounds of that 6.5 pounds are going to cost $9.26. So I'll write 4, $9.26. We know we're paying that. 6 minus 4, of course, is 2.5. And the way I look at 2.5 in light of the fact that we're told that it's $1.06 for each additional half pound, is I look at it like this: 1/2, 1/2, 1/2, 1/2, 1/2. Again, 1/2 plus 1/2 is 1, so we know that's 1. 1/2 plus 1/2 is 1, so we know 4 1/2 is 2, plus 1/2 is 2.5. We're told it's $1.06 per additional half pound. There's 1, 2, 3, 4, 5 additional half pounds. So we're going to take 106, multiply it by 5. And again, move this decimal 1, 2. We'll add those back in at the end. 5 times 6, of course, is 30. Carry the 3. 5 times 0 is 0, plus 3 is 3. 5 times 1 is just 5. Bring your 2 decimals back in so we can see this is 530. So now we do 926 times 530. Not times, plus 530. Sorry about that. To find the total cost to deliver this package. 0 plus 6 is 6. 2 plus 3 is 5. Bring down your decimal. This decimal just stays lined up. 9 plus 5, of course, is 14. So we can see this is going to be 1456. Guys, occasionally I do misspeak when I work out some of these problems. I'll say multiply when I'm really adding. If you see that, try to ignore it. Sometimes I have other stuff that I'm trying to do at the same time. So just bear with me on that. Again, I am human. Alright, number 4. A typist uses lengthwise a sheet of paper 9 inches by 12 inches. She leaves a 1-inch margin on each side and a 1.5 margin on top and bottom. What fraction part of the page is used for typing? So let me do a sketch. Okay, so we know this paper is 9 inches wide by 12 inches tall. Okay, so the first thing I'm going to do is I'm going to find the area of this right away. This is going to be our denominator. And 9 times 12 is 108. Again, one thing I always encourage people to do is try to remember their times tables from 1 to 12. But in case you needed me to work this one out, I'll go ahead and do that. 2 times 9 is 18, carry the 1. 9 times 1 is 9, plus 1 is 10. Okay? And now let's add the stipulations to this problem, because we know the stipulations are going to be the numerator. So we're told she leaves a 1-inch margin on each side, so that's right here. And a 1.5-inch margin on top and bottom. So the space she's typing in really looks like this. So now we got to figure out the dimensions of this smaller space. And again, this is 1 inch on each side. So this is 1 inch, this is 1 inch, this is 1.5 inches top and bottom. So we can see that we're going to take 9 and minus this inch over here and this inch over here. 9 minus 1 or 9 minus 2 is 7. So this smaller space, which I'm going to kind of write out separately, is 7. Again, 9 minus this margin, 9 minus this margin, 9 minus 2 is 7. 1.5 plus 1.5 is 3. So we see we're losing 3 inches total on top and bottom. So this 12 is subtracted by 3 to become 9. Again, this is going to be our numerator of the fraction since it's going to be smaller. 9 times 7, of course, is 63. Now we look for this as our answer choice. We don't see it. So in that case, we have to reduce this. The first thing I'm going to do is rewrite it off to the side here because reducing can get a little messy. And again, when you're reducing fractions, you're saying what can go into the top and bottom of this fraction to make it smaller. I'm going to first divide top and bottom by 3. 63 is easy. 3 goes into 6 2 times. 3 goes into 3 1 time. 108 is a little bit harder, so let's do the long division. 3 goes into 1, it doesn't. 3 goes into 10 3 times without going over. 3 times 3, of course, is 9. Subtract. 10 minus 9 is 1. Drop down this 8. 3 goes into 18 6 times, so this becomes 21 over 36. Is that an answer choice? It's not. I know 3 can go into 21 and 36. So again, I'm going to once again divide top and bottom by 3. 3 goes into 21 7 times. 3 goes into 36. Well, 3 goes into 3 once. 3 goes into 6 twice. 7 over 12. Answer choice B. Alright, number 5. Carpenter needs 4 boards, each 2 feet 9 inches long. If wood is sold only by the foot, how many feet must he buy? So what I like to do is convert everything from inches and feet to just inches. There are 12 inches in 1 foot. So 2 feet is 24 inches. 2 feet 9 inches is going to be 24 plus 9. 9 plus 4 is 13. Carry the 1. 2 plus 1 is 3. So that's the length of 1 board in terms of inches. To find the length of 4 boards, I'm going to take 33 multiplied by 4. 3 times 4, of course, is 12. Carry the 1. 3 times 4 is 12. Plus 1 is 13. Now the question is, how many feet of boards does he need to buy for this length of 4 boards? So we're going to take 132 divided by 12. Now, if you memorized your times tables, you would know that 12 times 11 is 132, and you would be done. Again, that's a little tip that would help you finish this problem more quickly. But if you didn't know that, let's go ahead and work it out by hand. 12 goes into 13 one time without going over. Of course, 13 minus 12 is 1. Drop down this 2. 12 goes into 12 once. 12 times 1 is 12. 12 minus 12 is 0. And there we got our answer. Exactly 11 feet of boards he would need to buy for these 4 boards. Okay? Number 6, an employee has 2/9 of his salary withheld for income tax. The percent of his salary that is withheld is most nearly, so we need to approximate this. Whenever I see fractions, I think of them as two different ways. I read this as 2 over 9, and at the same time I read it as 2 divided by 9. So in other words, I can turn 2 divided by 9 into this. 2 divided by 9. That is long division. And this will get me a percent. So 9 goes into 2. It doesn't. I have to add a 0 here. When I add a 0, I have to bring up a decimal. 9 goes into 20 2 times. 9 times 2, of course, is 18. Let's take a look. I know this is going to be 20-something percent, so I can cross out these automatically. 20 minus 18 is 2. Again, 9 doesn't go into 2, so I have to add a 0. 9 goes into 20 2 times. 2 times 9 is 18. Okay. Again, 20 minus 18 is 2. Have to bring down a 0 since 9 doesn't go into 20. 9 goes into 20 2 times. So we can see that this is going to repeat as 2, 2, 2, 2, 2. In other words, this is going to be about 22%. Number 7, on a blueprint in which 2 inches represents 5 feet, the length of a room measures 7.5 inches. The actual length of the room is. Okay, so if 2 inches equals 5 feet, I always want to know what the unit rate is. That is, I want to know what 1 inch represents. 1 inch is half of 2 inches. Half of 5 feet, therefore, is 2.5 feet. Okay, and since I have to deal with this half inch right here, I also want to know what half an inch represents. And a half of 1.5 or 2.5 is, again, 2.5 divided by 2. 2 goes into 2 one time. 2 times 1 is 2. Subtract. 2 minus 2 is 0, so we drop down this 5. Again, we're just going to bring our decimal right up. 2 goes into 5 twice without going over. 2 times 2, of course, is 4. Subtract. 5 minus 4 is 1. Bring down a 0 since 2 doesn't go into 1. 2 goes into 10 5 times. So I know half of inch represents 1.25 feet. Now, using these conversions that I did before I started the problem, I can actually work this out much quicker. I know I'm going to have 7 inches, so I'm going to do 7 times 2.5 and 1 half inch. So I'm just going to add this to this result. So I'm going to do 2.5 times 7. Again, move this decimal place 1 to make that 25. We'll add it back in at the end. 5 times 7 is 35. Carry the 3. 7 times 2 is 14. Plus 3 is 17. So we're going to add our 1 decimal back in. So that's 17.5 feet. Let's add the 1.25 feet. So this is going to be 17.5 plus 1.25, imaginary 0 there. 0 plus 5 is 5. 5 plus 2 is 7. 1 plus 7 is 8. Again, just drop down your decimal in order. 0 plus 1 is 1. 18.75 is right here. Again, 3/4 is the same as 0.75. Just a rule of thumb, 1/3 equals 0.3333. 1/2 equals 0.5. 3/4 equals 0.75. 1/4 equals 0.25. 2/3 equals 0.66666. You need to know these common fractions, because when you get something like this, you need to be able to go from decimal to fraction real quickly, which I just did. Otherwise, you might get this problem wrong. You might think you have made a mistake and then come up with a goofy way to try to answer this. Okay, number 8. During a 25% off sale, an article sells for $3.75. What was the original price of this article? So we know 0.75 of some unknown original price equals $3.75. So using a little bit of algebra, we can solve this. Again, divide both sides by 0.75. So we know the original cost of the article is going to be x equals 375 divided by 0.75. This can be somewhat of a challenging problem, but again, using the fact that I just mentioned here, let's turn 0.75 into a fraction. So I'm going to rewrite this as this. 375 divided by 3/4. When you divide fractions, you follow the keep, change, flip rule. That is, you keep 375. You change it from division to multiplication. And then you flip this fraction. So this becomes 4/3. To turn a whole number into a fraction, you put it over 1. So again, keep, change, flip. Keep this number the same, which I did. Change from division to multiplication, which I did. Flip this fraction from 3/4 to 4/3. And then multiply. Now, before I multiply, I'm going to make an effort to reduce this problem. 3 goes into 3 one time. 3 goes into 375, let's see. 3 goes into 3 once. 3 goes into 75 25 times. Now we just multiply straight across. And this becomes 4 times 125 over 1. Anything over 1's itself. So this problem just becomes 4 times 125. Let's go ahead and work that out. 5 times 4 is 20. Carry the 2. 4 times 2 is 8. Plus 2 is 10. Carry the 1. 4 times 1 is 1. Plus 1 is 5. So we know the original cost of the article, I imagine it's article of clothing, is $500. Okay. Number 9, the total length of fencing needed to enclose a rectangular area 46 feet by 34 feet is. We can see we're given everything in feet, but the answers are in yards. So in this case, we're going to have to make a conversion. But first, let's sketch it out. Told it's a rectangle that is 46 by 34 feet. And we want to know the total length of fencing to enclose this rectangle. Again, if I was interested in covering the face of the rectangle, I'd be using area. Since I want to know the distance of, or the length of fencing, I'm going to use perimeter. And perimeter of a rectangle or anything is to add up all the sides. So I'm going to do 46 plus 46 plus 34 plus 34. Add that up. 6 plus 4 is 10. 6 plus 4 is 10, so I know this is going to be 20. Carry the 2. 4 plus 3 is 7. 4 plus 3 is 7. 7 plus 7 is 14. Plus 2 is 16. So I know the perimeter of fencing I need in terms of feet is 160. That said, I have to divide 60 divided by 3 to get my yardage. Again, there are 3 feet in every 1 yard. So we'll do 160 divided by 3 to get our yardage. 3 doesn't go into 1. 3 goes into 16 5 times. 3 times 5, of course, is 15. 16 minus 15 is 1. Drop down this 0. 3 goes into 10 3 times. And right away, we know what our answer is going to be. It's not going to be 26. It's not going to be 52. It's going to be 53 and a third, but let's confirm that. 3 times 3 is 9. 10 minus 9 is 1. Bring down a 0 to start a new to make it divisible. 3 goes into 10. Let's see. Oh, we would actually be done since we're working with fractions. This 10 minus 9 would be 1, which would be your remainder that you would put over the divisor. So this would be 53 and 1/3. Again, this would be our remainder. We put that over the divisor, so this becomes 53 and 1/3. And again, let me give you another example of that because that was a little unclear. Let's say we had 13 divided by 4, and I wanted you to convert this to a mixed fraction, a mixed number like this. You would say 4 goes into 13 3 times. 4 times 3 is 12. Subtract. 13 minus 12 is 1. So you would take this remainder of 1, put it over 4 to make this a fraction of a mixed number of 3 and 1/4. Again, here's our 3 that we got using long division. We had a remainder of 1. We put that over the divisor to get a mixed number of 3 and 1/4. That's all you do when you're converting long division to mixed numbers. And I actually have a video of this under Mastering Fractions for the Test of Adult Basic Education. That is the TABE test. If you struggle with fractions, go ahead and watch that video. It should help clear everything up in terms of fractions. Alright, number 10. A piece of wood 35 feet 6 inches long was used to make 4 shelves of equal length. Number 10. A piece of wood 35 feet 6 inches long was used to make 4 shelves of equal length. The length of each shelf was. So again, we're dealing with feet. Let me grab my pen. Feet and inches. So what I'm going to do to keep everything simple, so I'm going to convert everything to inches like I did in the previous problem. So I'm going to do 35 times 12. Again, there are 12 inches in a foot. So 5 times 2 is 10. Carry the 1. 3 times 2 is 6. Plus 1 is 7. Add a 0 since we're starting this number. 1 times 5 is 5. 3 times 1 is 3. Add 0 plus 0 is 0. 7 plus 5 is 12. Carry the 1. So we know there are 420 inches and 35 feet. Let's add our 6 inches to that. So we know there are 426 inches and 35 feet and 6 inches. Those are equivalent. We know there are 4 shelves. So I'm going to take this 426 divided by 4. 4 goes into 4 one time. 4 times 1, of course, is 4. Subtract. 4 minus 4 is 0. So we drop down this 2 and 6. 4 doesn't go into 2, so we have to add a 0 here. 4 goes into 26 6 times. 4 times 6, of course, is 24. 26 minus 24 is 2. 4 doesn't go into 2, so I have to add a 0. When I add a 0 this time, however, I have to add a decimal here. 4 goes into 25 times. 5 times 4, of course, is 20, so there's no remainder on this one. So we know each shelf is going to be 106.5 inches. Now we got to convert this inches to feet. So we're going to do 106.5 divided by 12. In a previous problem, I did 12 times 9, which was 108. So we know that's too big, so we know this is going to be 8 something. Again, this is not going to work, this isn't going to work, and this isn't going to work. So 12 times 8, let me show you what that is. 2 times 8 is 16, carry the 1. 8 times 1 is 8, plus 1 is 9. So 12 times 8 is 96. Subtract. Again, just bring the decimal right there. 96 minus 106 is 10. And of course, we have the 0.5 there. So this is going to be 8 feet and 10.5 inches, which is right here. Again, you got to be able to see that. 8 feet, 10.5 inches. All right, number 11. A team won 2 games and lost 10. So let's write this out. Win, win, loss, 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 loss. The fractions of its games won is correctly expressed as, well, they won 2 out of how many games did they play in? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they won 2 out of 12 games. We reduced this by a factor of 2, which becomes 1 over 6. Right there. All right, number 12. What is the simple interest on $600 at 8% for 2 years? So you need to know the formula for simple interest. To do this problem, that's going to be I equals PRT. This might be worth committing to memory. You might see this on the ASVAB. I don't remember if I did. And this says interest, or simple interest, equals principal, the amount you invest, times the rate you're getting on your investment, times the time of your investment. So let's fill this in. Again, simple interest equals your principal, in this case that's 600, times your rate, 0.08, times time, which is 2 years. Okay, we just plugged all those points into this equation. To make this easy, I'm going to rewrite this as I equals 600 times 0.08 times 2 is 0.16. So now I just need to work out this to find my answer. So I'm going to do 600 times 0.16. Again, we're multiplying by decimals. I'm going to move this 1 2 times, and we'll add those back in at the end. 6 times 0 is 0. 6 times 0 is 0. 6 times 6 is 36. Bring down a 0 since we're starting this number. 1 times 0 is 0. 1 times 0 is 0. 6 times 1 is 6. Let's add. 0 plus 0 is 0. 0 plus 0 is 0. 6 plus 0 is 6. 3 plus 6 is 9. Add our 2 decimals back in. 1, 2. We know this, of course, is going to be $96. All right, 13. A change purse contained 3 half dollars, 4 quarters, 7 dimes, 6 nickels, and 9 pennies. Express in dollars and cents the total amount of money in the purse. Again, 3 half dollars. Half dollar is 50 cents, so I know this is going to be $1.50. 8 quarters. There are 4 quarters in $1. Therefore, there are $2 in 8 quarters. 7 dimes is 70 cents. 6 times 5 is 30 cents for the nickels, and 9 pennies is 0.09. So let's go ahead and add this all up. And I don't think people carry half dollars anymore, but that's irrelevant. Alright, let's add all this up. 0 plus 0 plus 0 plus 0 plus 9 is 9. 7 plus 3 is 10, plus 5 is 15. Bring down the decimal, carry the 1. 1 plus 2 is 3, plus 1 is 4. So in the purse there's $4.59, which is right there. 14. How much does a salesperson earn for selling $68 worth of writing paper if she is paid a commission of 40%? So that question is, what is 68 times 0.4? Again, to make this problem easy, I'm going to make this a whole number by moving it 1 decimal place. So this becomes 68 times 4. 8 times 4 is 32. Carry the 3. 6 times 4 is 24. Plus 3 is 27. Bring back in our 1 decimal place that we took away. So this becomes $27.20, which is right here. Number 15, if a certain job can be performed by 18 clerks in 26 days, the number of clerks needed to perform the job in 12 days is, again, 18 clerks take 26 days, so it would take 1 clerk 26 times 18 days to do the job by themselves. 8 times 6 is 48, carry the 4. 2 times 8 is 16, plus 4 is 20. Bring down a 0 since we're starting this new number here. 1 times 6 is 6. 1 times 2 is 2. Let's add. 0 plus 8 is 8. 0 plus 6 is 6. 2 plus 2 is 4. So it would take 1 clerk 468 days to do this job. How long will it take? How many clerks will it take them to do the job in 12 days? So we're going to do 468 divided by 12. Again, 12 times 4 is 48. 12 times 3 is 36, so we know this is going to be 3. 12 times 3 is 36. Subtract. So right away we can eliminate 52 and 24. We know the answer is going to start with a 3. 46 minus 36 is 10. Drop down this 8. 12 goes into 108, as we saw earlier, 9 times. 9 times 12 is 108, so there's no remainder. So the answer to this question is 39. This is a fairly difficult question, to be honest with you. Alright, number 16. A carton contains 9 dozen file folders. If a clerk removes 53 folders, how many folders are left in the carton? So 9 dozen, 12 times 9. We saw that was 108 in the previous problem. I'm not going to work that out. They take away 53 from 108. 8 minus 3 is 5. And you can do this. You can do you can make this 0 and borrow the 1 to make that 10 to make this 5. Or you can regard this as 10 minus 5, which is 5. So we know there are 55 files left in the carton. Number 17, a man had $25. He saw some ties that cost $4.95 a piece. How many of these ties could he buy with his $25? So, in other words, he has almost $5. So we know that 5 times 5 is 25. The ties cost less than 5, so we know he's going to be able to purchase at least 5 ties. We know 3 is not a choice because if he had $5 if the ties were $5 per tie, he could still buy them. And again, we're assuming there's no tax. Now let's just see if those ties. If he bought 6 ties for $4.95 a piece, would he have enough money? So let's see if that's going to work. If not, we know the answer is just going to be 5. So let's do $4.95 times 6. Again, at this point, I'm going to stop moving the decimal place. I'm just going to pretend it's not there, and I'm going to say we moved it 2 times, and we'll add those back in at the end. 5 times 6, of course, is 30. Carry the 3. 9 times 6 is 45. Plus 3 is 48. Carry the 4. 6 times 4 is 24. Plus 4 is 28. Add in our 2 decimal places. So we can see that 6 ties cost $28. He only has 25, so we know he can only buy 5 ties. Okay, number 18. A man earns $20.56 on Monday, $32.90 on Tuesday, and $20.78 on Wednesday. He spends half of all he earns during the 3 weeks. How much money does he have left? So we're going to add all those up and divide by 2. Again, decimal is going to stay in the same place. 8 plus 0 plus 6 is 14. Carry the 1. 5 plus 7 is 16. Plus 1 is 17. Plus 5 is 17, 18, 19, 20, 21, 22. Carry the 2. 2 plus 2 is 4. And 3 plus 2 is 5 plus 2 is 7. So over the course of the 3 days, he earns $74.24. Let's go ahead and divide that by 2 to find out what half is. 2 goes into 7 3 times without going over. 2 times 3, of course, is 6. So right away, we know our answer is going to be 3 something. Start with the 3. 7 minus 6 is 1. Bring down this 4, bring down this 2, bring down this 4. 2 goes into 14 7 times. 2 times 7 is 14. Subtract. 14 minus 14 is 0. So bring down this 2, bring down this 4. Again, keep your decimal in the same spot. 2 goes into 24 12 times. So we can see that this is going to be 3712. Alright, number 19. How many packages of candy containing 3/4 of a pound each can be filled from a 15 pounds of candy? So again, this problem becomes 15 divided by 3/4. Or you can rewrite all whole numbers as 15 over 1. Just put them over 1. So this problem becomes 15 over 1 divided by 3 over 4. Again, we talked about this earlier. Keep, change, flip. Keep this first fraction the same, 15 over 1. Change this from division to multiplication. And then flip this fraction to be 4 over 3 instead of 3 over 4. Before I work this out, I'm going to cross reduce. 3 goes into 3 1 time. 3 goes into 15 5 times. We can see that this is, now we just multiply straight across. We can see this is going to be 5 times 4 over 1 times 1. 5 times 4 is 20 over 1. Anything divided by 1 is itself, so we know this is just going to be 20. Alright, number 20. A champion runner ran the 100-yard dash in 3 track meets. The first time he ran it in 10.2 seconds, the second time in 10.4 seconds, and the third in 10 seconds. What is the average of his time? To find the average, you add all the numbers together and divide by how many there are. There are 1, 2, 3 numbers in this case. So we're going to do 10.2 plus 10.4 plus 10 and divide that by 3. That's going to give us our average. We can do this one. We can do part of this one in our head. 10 plus 10 plus 10 is going to be 30. 0.2 plus 0.4 is going to be 0.6. So this becomes 30.6 over 30. We can do this math in our head too. 3 goes into 30 10 times. Keep your decimal there. 3 goes into 6 twice. So we know the average is 10.2. You could have worked this out doing long division, and let me show you what that looks like just in case you're not comfortable doing mental math. 30.6 divided by 3. Again, keep the decimal right here. Bring it up here right now. 3 goes into 3. Well, 3 goes into 30 10 times. 10 times 3 is 30. Subtract. 30 minus 30 is 0. Bring down this 6. 3 goes into 6 twice. Okay? A crate containing a tool weighs 12 pounds. If the tool weighs 9 pounds, 9 ounces, how much does the crate weigh? Okay, so we know the tools weigh 9 pounds and 9 ounces. And we know we're dealing with 12 pounds total. There are 16 ounces in 1 pound. So I'm going to rewrite this 12 pounds in terms of a fraction. And that's going to be, and this should be 9 pounds, 9 ounces. I wrote a 1 there. Sorry about that. I'm going to rewrite this 12 pounds as 11 pounds and 16 over 16. Again, there are 16 ounces in a pound. So this 16 over 16 is 1 pound. 11 plus 1 is 12. And I'm going to do the same here for this 9. This is 9 and 9 over 16 ounces. Now we can just subtract. Since these are mixed numbers with the same denominator in their fractions. 9 minus 11, 9, 10, 11. That's 2. And we're subtracting those. 16 minus 9 is 7. So this is 2 pounds and 7 ounces, which is right there. All right, number 22. The area of a room measuring 12 by 15 feet is 9 square yards, 12 square yards, 15 square yards, 20 square yards. Again, we're going from feet to yards, so we got to make a conversion at some point. Again, there are 3 feet in every yard. So since these numbers are both divisible by 3, I'm going to divide them right off the bat. 12 feet is the same as 12 divided by 3, or 4 yards. 15 is the same as 15 divided by 3, or 5 yards. Now this problem is the area of a room that's 5 by 4 yards, not feet. And the area is length times width, so 5 times 4 are just 20 square yards. Okay? Alright, number 23. A woman purchased a blouse for $10.98. She returned the blouse the next day and selected a better one costing $12.50. She gave the clerk a $5 bill to pay for the difference in price. How much change should she receive? Okay. So first we need to find the difference in price between these two. So I'm going to do $12.50 minus $10.98. Because again, she already paid $10.98. So she has a credit of 1098. So we need to find how much she should get back minus her credit. So what I'm going to do is I'm going to borrow from this 5. I'm going to make this a 4. I'm going to make this a 10. 10 minus 8 is 2. Now I can't do 4 minus 9, so I'm going to have to borrow a 1 there and add 1 there. 14 minus 9 is 5. Again, your decimal just stays lined up. 1 minus 0 is 1. So we know there was a $1.52 difference between these two prices. So she gave the clerk a $5 bill. So we're going to do 5 minus 152 to get our answer for her change. Because again, this is basically saying she had to pay an additional $1.52 to buy the $12.50 shirt, and she gave her a $5 bill. So we're taking 5 minus 152 to find what her change is going to be. Again, 0 minus 2 we can't do, 0 minus 5 we can't do. So we have to make this a 4, and this becomes a 10. Now I can do this one, but I still can't do this one. So I'm going to borrow one more time. This is going to become a 9. That's going to become a 10. 10 minus 2 is 8. 9 minus 5 is 4. Drop down the decimal as it stands. 4 minus 1 is 3. So we can see we should give her back 348. Assuming I didn't make a mistake. Alright, number 24. The Daily Almanac report for one day during the summer stated that the sun rose at 6:14 a.m. and set at 6:06 p.m. Find the number of hours and minutes and the time between the rising and setting of the sun during that day. I'm going to let you in on a little secret. There's a reason that military time exists, and it's for this reason. Finding the length between two different times is much easier when we convert PM to out of a 24-hour time clock. So to do that, I'm going to do 6 plus 12, which is going to be 18. So in military time, 6:06 is represented as 18:06, which makes this math a lot easier. Again, this is going to be 6:14 or 06:14 if you're being more specific. We want to find the difference between those. Okay, so again, we can't take away 6 minutes from 14 minutes. So I'm going to make this a 17 and add a 60 here. So this is going to become 66. 4 minus 6 is 2. 6 minus 1 is 5. 17 minus 6 is going to be, let's see, 11. So in other words, there's an 11 hour, should be an H, and 52 minute, there's 11 hours and 52 minutes between these 2 points in time. Alright, number 25. In a 45-minute gym class, 30 boys want to play basketball. Only 10 can play at once. If each player is given the same length of time to play, how many minutes should each play? So we got 30 boys. We're doing 10 groups of 10. So we know they're going to go in 3 groups. And to give them even time, we're going to take 45 divided by 3. 3 goes into 4 wants. 3 times 1 is 3. Subtract. 4 minus 3 is 1. Bring down this 5. 3 goes into 15 5 times. 3 times 5 is 15. 15 minus 15 is 0. So we can see each group's going to get 15 minutes of playtime. Alright, 26. The library charges 5 cents for the first day and 2 cents for each additional day that a book is overdue. If a borrower paid 65 cents in late charges, for how many days was the book overdue. So right away we're going to subtract 5, because the first day it's late, you pay 5 cents. So 65 minus 5 is going to be 60. So this is 1 day late. You still owe 60 cents. So we're going to do 60 divided by 2. That, of course, is 30. So we know the book was 30 plus 1 day's late. That is 31 days late. Pretty quick and easy problem. Alright, 27. How many slices of bread, each weighing 2 ounces, are needed to balance 2 pounds of apples? So in other words, how many slices of bread weighing 2 ounces is equivalent to 2 pounds? Again, there are 16 ounces in 1 pound. So 2 pounds is going to be 32 ounces. So we're going to take 32 divided by 2, since we know each slice of bread weighs 2 ounces. 2 goes into 3 one time. 2 times 1 is 2. Subtract. 3 minus 2 is going to be 1. Bring down this 2. 2 goes into 12 6 times. So we can see we're going to need 16 slices of bread to balance out the 2 pounds of apples. Alright, number 28. If 1/2 cup of spinach contains 80 calories and the same amount of peas contains 300 calories, how many cups of spinach have the same caloric content as a 2/3 cup of peas? So I know 1/2 cup of peas, and let me grab my pen again. 1/2 cup of peas has 300 calories. If I double that, I know 1 cup of peas will have 600 calories. Okay? We're interested in finding out first how many calories there are in 2/3 cups of peas. And that information is not given to us. So what I'm going to do is I'm going to figure that out this way. Again, when we're dealing with fractions, we can really make this denominator whatever we want. So I can go 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12. I don't know why I wrote 18. Let me rewrite that. 7/12, 8/12, 9/12, 10/12, 11/12, and 12/12. 12 out of 12 is 1 cup. 6 out of 12 is 1/2 cup, right? So if I want to find out how many calories are in increments of 12ths of a cup, I can do that. And I would take this 600 divided by 12. 60 divided by 12 is going to be 12 times 5 is going to be 0. 5 times 2 is 0, plus 1 is 5 times 1 is, let me start over. 2 times 5 is 0, carry the 1. 2 times 5 is 10, carry the 1. 1 times 5 is 5, plus 1 is 6. So 12 times 5 is 60. 12 times 50 would be 600. So I know this goes up by increments of 50 calories each. Okay? You'll see why I'm doing that in just a second. So what is 2/3? Well, I know 2/3 is the same as 8 over 12. Again, if I were to reduce this 8 over 12 by a factor of 4, that is, I were to divide top and bottom by 4, 8 divided by 4 would be 2, 12 divided by 4 would be 3. This would be equivalent to 2/3. So if there are 50 calories in each 12th of a cup, I know 50 times 8 will give me the amount of calories in 2/3 of a cup of peas. 0 times 8 is 0. 5 times 8 is 40. So right here, there are 400 calories. Okay? What's more, I know there are 80 calories per 1/2 cup of spinach. So I'm going to take that 400 divided by 80. And to keep this math simple, I'm going to kick off these zeros. Again, 8 goes into 40 5 times. And again, that's basically saying there are 5 half cups of spinach in 400 calories. So I need to take 5 and multiply it by 1/2, which becomes 5 over 2. This is a improper fraction, so I'm going to convert it to mixed number by doing 5 divided by 2. 2 goes into 5 2 times. 2 times 2 is 4. 5 minus 4 is 1, so this is my remainder. Again, we talked earlier about making fractions into mixed numbers. So this is going to be 2, this 2, and 1/2 cups, which is right here. So again, I used this little trick to find out how many calories there were in 2/3 cups of peas, and then I found out how many half cups were in that amount, and then I converted a improper fraction into a mixed number to get our answer. Difficult problem. If you see this on the ASVAB, you're probably doing pretty well. Alright, number 29. If it takes 30 minutes to type 6 pages, how many hours will it take to type 126 pages at the same rate? So I'm big on finding the unit rate. If it takes 30 minutes to type 6 pages, let's do 6 divided by 30 to find out how many pages you type per minute. Again, 30 doesn't go into 6, so I have to add a 0. When I do that, I have to bring up a decimal. 30 goes into 60 twice. So in other words, every minute you're typing 0.2 of a page. Okay. So how many hours will it take you to type 126 pages? It's going to be 126 divided by 0.2. Again, as I mentioned earlier, you can't divide with the decimal on the outside, so you have to add this. You have to move it over 1. When you move it over 1 there, you have to move it over 1 here, in which case you have to add a 0. Okay, so 2 goes into 12 6 times. 6 times 2 is 12. Subtract 12 minus 12 is 0. Drop down this 6. Drop down this 0. 2 goes into 60 30 times. So this basically, and 30 times 2 is 60. Subtract, there's no remainder. So this says it will take you 630 minutes to type 126 pages at this rate. Well, of course, these answers are given in hours. There are 60 minutes in an hour. So we're going to take 630 divided by 60. And we can see that it's going to be close to 10. Again, you can look at this as 60 goes into 63, or 60 goes into 630. 60 times 10 would give you 600, so I'm going to do that first. 60 times 10 is 600. Subtract, we're left with 30. Again, this is our remainder, so we can put this over that, and this becomes 10 and 30 over 60 minutes, 10 hours and 30 over 60 minutes, which is 10.5 hours. Again, 30 over 60 is a half an hour, which is right there. Alright, final question. A night watchman must check a certain storage area every 45 minutes. If he first checks the area as he begins a 9-hour tour of duty, how many times will he have checked the storage area? So first we need to figure out how long his duty is going to be. We can make up a time if we want. So I'm going to say he's going to start at 12 a.m., in which case he's going to finish his shift at 12 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9. He's going to finish at 9 a.m. That's a 9-hour shift. So the way I like to do these problems when they're simple is he checks it once at 12 o'clock, checks it again at 12:45, checks it again at 1:30, checks it again at 2:15, checks it again at 3 o'clock, checks it again at 3:45. I'm just adding 45 to each of these numbers. Checks it again at 4:30. Checks it again at 5:15. Checks it again at 6. Checks it again at 6:45. Checks it again at 7:15. Or 7:30, sorry about that. Checks it again at 8:15 and checks it a final time at 9 o'clock. Let's add those up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So in total he checks it 13 times. Again, each time I just added 45 and just counted them up. So that's all I have for you in this video. If you found it helpful, of course, feel free to give it a thumbs up or leave some positive feedback in the comments section below. As you can tell, for some of the problems, they're pretty strenuous for me. As a rule of thumb, I like to say that you should try to do at least 10 practice tests before you take the actual ASVAB. In doing that, you're going to build up your endurance, and you're also going to see a wide variety of different types of questions, which of course will help you boost your score. So all that said, on that note, I'm going to go ahead and cut you loose. Welcome YouTubers to another episode of my Grammar Hero series. In this video, I'm going to discuss the ASVAB, that is the Armed Services Vocational Aptitude Battery. More specifically, I'm going to work out problems from the mathematics knowledge section of that test. Before we get started, I just want to make a few general comments about the ASVAB. The ASVAB is a test people take in order to join the U.S. military. Doesn't matter what branch you want to join. This is one of the first things you'll do as soon as you initiate contact with any branch. The test itself is, as you can see on the left here, broken down into 10 sections, including general science, arithmetic reasoning, word knowledge, and so on. What's more, the test is given in 2 different versions. So, for example, one version is called the CAT ASVAB, whereas the other version is called the P&P ASVAB. CAT, in case you're wondering, stands for Computer Adaptive Test, and P&P stands for Pencil and Paper. More often than not, you will be given the CAT ASVAB, so let me just highlight a few things about that particular version. Overall, it's 145 questions. It takes about 154 minutes to complete. And as far as the mathematics knowledge section goes, you can see that you have 20 minutes to do 16 questions. Similarly, in case you haven't taken a computer adaptive test before, it works like this. The first question you're usually given is moderate in terms of difficulty. If you get it right, you get a more difficult question. If you get that one right, you get a slightly more difficult question. And at the same time, if you get that first question wrong, you'll get a slightly easier question, and so on and so forth. Okay? For this test, there is no calculator whatsoever allowed. That goes for every single section that you'll take of this exam. but I do believe you'll be given either scrap paper or a white expo board on which you can work out some of these problems. So above all, I'm just going to note that no calculator is allowed on the test. In case you're not familiar with the ASVAB, you'll be given a score for each of these different sections, but what's most important is your AFQT score, your Armed Forces Qualification Test score. Basically, your AFQT score, I got a new mouse, so this isn't working out too well, is determined by how well you do on the Arithmetic Reasoning section, the Word Knowledge section, Paragraph Comprehension, and Knowledge is with a K, not a C, and the Mathematics Knowledge. Okay? So, in other words, these 4 subsections of the test will be taken, added together, put in a formula, and you'll be given a score anywhere from 1 to 99. You interpret your score like this. If you score a 95, for example, that means you scored better than 95% of all the test takers. Okay? It's important to do well to get a good AFQT score. The AFQT score is what tells the military, 1, whether you're qualified to join the military, and 2, what jobs you're qualified for. As a rule of thumb, I like to tell people, always try to score category 3 or above. So in other words, you want to score a 31 through a 99 on the ASVAB. Those requirements vary from service to service, as well as depending on each candidate's background. For example, if you have a GED instead of a high school diploma, you may have to score slightly higher, like a 50 or so on. Those are questions you can direct at your recruiter. So all that said, let's go ahead and get started with some guided practice. I'm going to be working out these problems fairly slowly, given that many of you probably haven't seen this material before. And if for some reason I touch on some concepts with which you're struggling, I would recommend that at some point you pick up a copy of ASVAB for Dummies. In that book, they actually break down each concept in greater detail. And in that book, there's also some full-length practice tests. I'm going to post the link to this practice test in the description of my video, so you're more than welcome to follow along as I work these problems out. Okay? So let's get started with number 1. And again, this is a mathematics knowledge test. It's assuming that by the time you graduate high school, you've seen all these concepts before. So number 1, we're looking at 10 exclamation point over 7 exclamation point. I said exclamation point because some of you might not realize that an exclamation point in mathematics is called a factorial. So that's 10 factorial over 7 factorial. It's a fraction. And in case you haven't seen it in a while, 1 factorial is equivalent to just 1. 2 factorial is equivalent to 2 times 1. 3 factorial is equivalent to 3 times 2 times 1. 4 factorial is equivalent to 4 times 3 times 2 times 1. 5 factorial is equivalent to 5 times 4 times 3 times 2 times 1. And when I say equivalent, that means 2 factorial is the same as 2 times 1, and when we do the math, we know that is just 2. 3 factorial is the same as 3 times 2 times 1, which is 6 times 1, which is 6. Okay, so these actually produce whole numbers. So let's go ahead and work out number 1 on the side here. We got 10 factorial, so that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's divided by 7 factorial, so that's 7 times 6 times 5 times 4 times 3 times 2 times 1. The trick to do this problem is first to recognize what factorials are, and then second to realize how you can reduce this. This actually reduces as such. You can simply cross out what you see in the numerator from the denominator. So you're just left with this. 10 times 9 times 8 times 7. Or not 7. 10 times 9 times 8. And we know that is 90 times 8. Which is just 720. Okay, so number 1 is D, 720. Number 2 involves dealing with exponents. Just as a rule, and I'll put that over here, when you multiply things to certain powers, or bases that are the same to certain powers, you add them, add their exponents, and when you divide bases that have different exponents, you divide it. So for example, 6 to the 5th, I'm going to change my the thickness of my pen here. 6 to the 5th over 6 squared. That's the same as saying 6 to the 5th minus 6 squared, which is the same as 6 to the 5th minus 6 squared, which is the same as 6 to the 3rd. Okay? So you can see the bases are the same. We have 6. We have different exponents. So according to the rule, we would just subtract those exponents and get 6 to the 3rd. Similarly, if we had 6 to the 5th times 6 squared, we would add the exponents, and this would become 6 to the 5th plus 6 squared, which is just 6 to the 7th. Okay? So let's take a look at what we have here. To do this problem, I'm going to go back to the thicker pen here. My mouse sensitivity is too high. To attack this problem, I'm going to work out the bottom first. That is, I'm going to add these two exponents, and then I'm going to deal with the division, because again, we're working with order of operations still. So let's go ahead and rewrite that over here. 6 to the 4th divided by 6 to the 3rd times 6 squared. Again, this is the same as 6 to the 4th over 6 to the 3rd plus 2, which is the same as 6 to the 4th over 6 to the 5th. Again, like I did up there, this now is subtraction since the bases are the same. So we got 6 to the 4th minus 5, which becomes 6 to the negative 1, which we can rewrite as 1 over 6 to the 1, or 1 over 6, which is right here, C. Okay. We all know how to take square roots of something. Like if I were to take the square root of 64, I'd be looking for a number by which I can multiply itself twice to get 64. So 8 times 8 gets you 64. So we all know that this would be 8 for that reason. Taking the cube root taking the cube root is the same idea. We need to find a number by which we can multiply itself 3 times. That will give us 64. We already know 8 times 8 is 64, so 8 times 8 is 64 times 8 would be a much larger number. 9 times 9 is 81, times another 9 is a very big number. 6 times 6 is 36, times another 6 is going to get us over 120. So just by eliminating answer choices that were obviously wrong, we could go with B. Let's go ahead and work it out though. So again, we're looking for this, 4 times 4 times 4. If this equals 64, we know it's the cube root of 64. So 4 times 4 is 16, and I'll do long division, times that remaining 4. Again, this is 16 right here, and we have 1 4 left. So 4 times 6 is 24, carry our 2. 1 times 4 is 4 plus 2 is 6, 64. Done. Okay. Number 4. This problem at first glance looks difficult, but what it's testing is your knowledge of the order of operations. That is, please excuse my dear Aunt Sally. That is, parentheses, exponents, multiplication, division, addition, and subtraction. The way this works is you do what's in parentheses first, you do exponents next, and then you do multiplication and division from left to right because these are considered equal, and then you do addition and subtraction from left to right. So if all the way on the left hand side you have subtraction, you can do that before addition. Let's go ahead and rewrite this off to the right, and then we'll go ahead and try to do it. So we got 2, 5 minus square root is 16 divided by, and I'm going to get rid of this real quick. Get our pen back. Divided by parentheses 14 minus 12 times 3. Okay, so again, order of operations, parentheses. We have parentheses right here and parentheses right here. Let's work those out first. So let's bring down the 2. Square root of 16, that's the same as 4. So let's just rewrite that as 4. 5 minus 4 is 1. Divided by 14 minus 12 is just 2 times 3. Okay? So now we just simply refer back to this. We've worked out our parentheses. We have no exponents to worry about. Now we're on multiplication and division from left to right. 2 times 1 is multiplication, so we'll do that. That's just going to be 2. Division, let's see. We got 2 divided by 2 times 3. Again, look, multiplication and division are equivalent, as I said, and you work them out from left to right. So we do 2 divided by 2, which is just 1, times 3, which is 3. Again, as long as you can remember this, you'll never get a problem like that wrong. Okay? Let me go ahead and get rid of that. Alright, number 5 says solve for a, and we have the equation 7a plus 2 equals 3a minus 5 plus 2a. Whenever I see solve for some variable, in this case a, I always think at the end I'm going to have my equation looking like this. A equals something. That is, a is going to be on one side and everything else is going to be on the other. So with that in mind, let's go ahead and get started. 7a plus 2 equals 3a minus 5 plus 2a. I really got to get a pen so I can write these a little better. So again, the goal is to get a by itself. So we're basically just going to rearrange the equation such that we ultimately get a by itself on one side. So what I'm going to first do is combine this 3 and 2a to simplify the equation a little bit. So we got 7a plus 2 equals negative 5. 3a plus 2a is 5a, and those are like terms. I couldn't add 3a to negative 5 because there's no a here. 3a and 2a are like terms, so I can add them. Okay, so now I'm going to do two things, but I'm going to break it down as simply as possible. I'm going to move this 2 over here. So I have 2 here. To get this to 0, I have to take 2 away from there. And what I do from one side, I have to do to the other. So this becomes 7a. Again, we're not doing anything with that right now. Plus 2 minus 2 becomes 0 equals negative 5 minus 2. That's negative 7. Again, we still have this plus 5a hanging out here. Now I'm going to move this 5a over here. And to do that, I'm going to do the opposite sign. This is plus 5a. So to get rid of it, I'm going to minus 5a from this side, or subtract 5a. And then what I do to one side, I have to do the other. Minus 5a from that side. 7a minus 5a becomes 2a equals negative 7. 5a minus 5a becomes 0. Okay? Now we got to get rid of this 2 in front of the a. Again, the goal is to get just a equal to something. So I'm going to divide this side by 2. What I do to one side, I have to do to the other. This cancels out. I'm left with a equals negative 7 over 2, which is the same as negative 3 1/2. Okay, I could work that out, but I'm not going to. Okay, let's get rid of some of this stuff. And again, if I was taking the CAT ASVAB, the questions would start ramping up in terms of difficulty fairly quickly. That said, there is a limit as to how difficult the questions are going to be. So if you're competent with math, you should reach that limit fairly easily. Oh, I don't want the pink one. Okay, number 6, solve for x. Again, it says solve for some variable, so at the end we want x to be on one side by itself. And I'll just rewrite this over here. 5 times 2x minus 1 equals 3 times 4x plus 3. Again, order of operations. That's going to be important. Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, subtraction. Can we do anything in these parentheses? 2x minus 1, those aren't like terms, so I can't take 1 away from 2x. 4x plus 3, again, not like terms. So in this case, what I have to do is distribute this 5x. Specifically, I'm going to multiply it here and here. So let's go ahead and do that. 5 times 2x becomes 10x. 5 times negative 1 is negative 5. And I have to do the same thing here. I'm going to take this 3 and multiply it there. And I'm going to take this 3 and multiply it there. I'm distributing it. 3 times 4x is 12x. 3 times 3 is 9. Okay, now this problem is no different than this one that we just did. We've just worked this one out. So now we're going to start rearranging the equation such that we get x on one side, and we're going to be careful how we do this so we make the least amount of work possible. I like x to be positive, so the first thing I'm going to do is I'm going to take this 9 and subtract it from this side. What I do to one side, I have to do to the other. 9 minus 9 becomes 0. Negative 5 minus 9 becomes negative 14. So this becomes 10x minus 14 equals 12x. Almost there. I want to move this 10x to this side, so I'm going to subtract it. And what I do to one side, I have to do to the other. Minus 10x. Positive 10x minus 10x becomes 0. I'm left with negative 14 equals 12x minus 10x becomes 2x. Again, I want to get x by itself, so I'm going to divide both sides by 2. This causes the 2 to cancel here, and I'm left with x equals negative 14 over 2, which is the same as negative 7. Okay. Let's get rid of that work real quick. Okay, number 7 says evaluate the expression if x is 0 and y is 3. Okay, again, please excuse my dear Aunt Sally, and I like to put the arrows over the multiplication, division, addition, subtraction to know that they're equal, and we work from left to right on those. So I'm going to go ahead and plug those into the equation to start. Again, x is 0, so we got 0 plus y is 3, so we'll plug in, oops, 0 plus 3 cubed minus 5 times, again, x is 0, so we'll plug that in, plus 7 times y is 3, so we'll plug that in. Again, we're given x and y, and it's telling us to evaluate this, so we're going to find a whole number at the end. Parentheses, exponents, multiplication, division, addition, subtraction. We do have parentheses that we can do. 0 plus 3. That just becomes 3 cubed minus 5 times 0 plus 7 times 3. We do have exponents. 3 cubed. So we just got rid of the parentheses right here. Now we're working on exponents. 3 cubed is 3 times 3 times 3. Well, 3 times 3 is 9 times 3 is 27. 27 minus 5 times 0 plus 7 times 3. That's bad 7. Now we're working from left to right on multiplication, division, addition, subtraction. So we got 27 minus that subtraction, so we're not going to do this one right now. We're just going to leave it there. 5 times 0, that's multiplication. So we can do that one. 5 times 0 is just 0. So that goes away. And I'm going to get rid of that subtraction since the 5 went away, or the negative 5 went away. And then plus 7 times 3. Again, that's multiplication. 7 times 3 is 21. Take a look what we have left. 21 plus 27, that's going to be 48. Number 8, we're dealing with inequalities. So let's go ahead and see how we're going to do this one. Again, it says solve, and as you can see, we're going to have x on one side. As a rule of thumb, or as a rule, when you add or subtract across this inequality sign, it doesn't flip the sign. But when you divide or multiply by a negative, it flips the direction of the sign. So like if I had negative 2x less than 1 and I wanted to solve for x, if I divide it by a negative 2 on both sides, this would go away. But since I divide it by a negative 2 on both sides, this inequality would flip. It'd be x is greater than negative 1/2. Okay? Addition and subtraction across the inequality sign, fine. Multiplication and division of negatives flips the sign. So let's go ahead and get started with this one. We got 3 plus 6x is less than or equal to 3x minus 3. Again, the goal is the same, to get x's on one side and whole numbers on the other. So to start, I am going to subtract 3 from this side. And what I do from one side, I'm going to do to the other. This becomes 0. Since I'm subtracting across the inequality, I do not have to flip it. So this gives me 6x less than or equal to 3x. Negative 3 minus 3, that becomes negative 6. Okay, now I want to move this 3x over to the left. So I'm going to subtract 3x here. And what I do to one side, I do to the other. This goes away to 0. 6x minus 3x becomes 3x less than or equal to negative 6. Now I want to get x by itself, so I'm going to divide both sides by 3. That leaves me with x is less than or equal to negative 6 over 3, or x is less than or equal to negative 2. And there it is, B. Okay. Number 9, what is the name of a quadrilateral with 4 equal sides? So we all know a square is a quadrilateral, has 4 equal sides. If that was there, we'd be done. Okay? All these sides are equal in length, but that's not there. Trapezoid. What's a trapezoid look like? One of these things. Are all those sides equal? No, just these two sides are equal. Parallelogram, that looks like this. Again, these two sides are equal. That side and that side's equal, so not all 4 are equal. Pentagon has 5 sides. What about a rhombus? Let me fix that real quick. Rhombus is a square just on a tilt. And yes, all the sides are equal. So C. 55-degree angle. So let's look at this one. 55-degree angle is. So let's take a look. If we go straight up from a line, we know that's a 90-degree angle. Okay. Anything past this 90 degrees is called obtuse. So anything from here over would be an obtuse angle, and anything from 90 degrees under would be an acute angle. Okay? Again, this is 90, our benchmark. 55 is less than 90. It's right about there. So it would be acute. Isosceles triangle. Isosceles triangle is simply a triangle with 2 equal sides and 2 equal angles, namely these. Okay. Alright, number 12. The side of an equilateral triangle is 20 centimeters. Its perimeter. Okay, so two concepts here. Equilateral triangle. It's a triangle that has all the sides that are the same. So that's equal to that, and which is equal to that. Perimeter is the distance around an object, and basically for a perimeter you would basically add up all the sides, which in this case there's 3 of them. If we know this one's 20, this one has to be 20, this one has to be 20, so we know our perimeter is side plus side plus side. So it's 20 times 3, so we know our perimeter is 60. Alright, number 13. The area of a rectangle is 144 inches squared. If the length of the rectangle is 16 inches, what is its width? So area of a rectangle is equivalent to length times width. In this case, we're given the information that the length is 16. But we're asked to find out what the width is. So in this case, we have this. Area equals 16 times some width. We're given the area, so we know 144 equals 16 times some width. To get W by itself, we divide by 16. Divide by 16. This cancels out. We're left with W equals, our width is 144 over 16, which is, my math's not that good. 16 times 3 doesn't get you 144. 16 times 5 doesn't get you to 144. 12 times 12 is 144, so it's going to be 9. Okay, number 14. And let me get rid of this real quick. The circumference of a circle is equal to 10 pi centimeters. Its radius is. So with regard to circles, it's useful to know that there are 2 measures of circles that we take in math more often than not. The area of circles and the circumference. And there are 2 formulas you need to be familiar with for this test. Circumference of a circle is equal to pi times the diameter, or pi times 2 radiuses, or 2r. Similarly, area is always going to be pi times the radius squared. As long as you know these formulas, you'll be fine. In this case, we're told that the circumference, and again, circumference is how I like to think of circumference. Circumference is let's say you were to start right here and walk this way around the circle. That's all that's measuring, how long it takes you to walk around the outside of a circle. Area, on the other hand, measures the face of the circle. Okay? So circumference of a circle is equal to 10 pi centimeters. Its radius is. Okay, this is where it's useful to know this. Circumference is equal to 10 pi. So we know the radius is going to be this. Pi times 2 times 5. Okay, because we're using this formula, 2 times 5 will get you circumference equals pi times 10, which is what we know. So we know the radius is going to be 5. Again, you have to be familiar with both of these forms. 2 more to go and we're done. How much will it cost to paint a circular patio of radius 7 meters if the cost of paint per square meter is $2? So again, we have some circular patio like that. We're interested in the area because they're painting the surface. Okay. So in other words, what is the area of this circle? So we have area equals pi r squared. We're given the radius is 7, so we have area equals pi 7 squared. Again, order of operations, please excuse my dear Aunt Sally. No parentheses, but we do have exponents. Area equals pi 7 squared is 49. Okay. Now this is where things get tricky. Pi, when you have to, we have 153 square meters. Let's go ahead and multiply this by the $2 and we'll get our total. Again, just move your decimal 2, add it back in at the end. 6 times 2 is 12. Carry the 1. 8 times 2 is 16. Add 1, 17. Bring the 1. 3 times 2 is 6. Add 1, that's 7. 5 times 2 is 10. And carry the 1. 2 times 1 is 3. Or 2, add 1, that's 307. So it will cost $307.72 to paint the circle, which is just 308. They round it. Last one. A rectangular box has a length of 7, a width of 3 feet, and a height of 2 feet. What is its volume? So immediately you want to note that volume is always going to be cubed. So let's go ahead and get rid of this one. If you don't see any answer choice with volume squared, that's referring to feet or surface area. Volume is always cubed. The volume of a rectangle is simply length times width times height. That's the formula. So if we have a rectangle, and I'm going to try to do it as best I can here. It's more cubish, but it's a rectangle with a length of 7, a height of 2, and a width of 3. We simply just plug those in. Volume equals 7 times 2 times 3. Volume equals 7 times 3 is 21 times 2. Volume equals 42 feet cubed. Again, they would have tricked you with the squared there. So that's all I have for this video. As you saw, it took a lot of knowledge of formulas as well as arithmetic to do well on this section. My advice to you is, again, to get the ASVAB for Dummies book. And once you get pretty comfortable with some concepts you haven't seen in a while, take as many practice tests as you can. I'd say to be safe, I would take anywhere from 5 to 10 practice tests. And when I say take practice tests, I'm not saying practice mechanical comprehension and stuff like that. Just practice what the sections that are going to boost your AFQT score. That is, practice arithmetic reasoning, practice word knowledge, practice mathematics knowledge, and practice paragraph comprehension. All this other stuff is unimportant. If you do well on the AFQT, let's say you get a 70 on the AFQT, you'll qualify for most jobs in the military. So all that said, I'd appreciate any comments or feedback in the comments section below. But on that note, I'll go ahead and cut you guys loose. Welcome YouTubers to another episode in my Grammar Hero series. In this video, I'm going to work out practice problems from the Arithmetic Reasoning section of the Armed Services Vocational Aptitude battery, that is the ASVAB. Before I do that, however, I'm going to take a few minutes to discuss the ASVAB itself. First, I want to point out that it's a test that's comprised of 10 different subsections, including general science, arithmetic reasoning, word knowledge, paragraph comprehension, mathematics knowledge, and so on. In addition to receiving a score for each of these subtests, you'll also receive what's called an AFQT score, that is an Armed Forces Qualification Test score. That score says, 1, you're either qualified to join the military, or 2, you're not qualified to join the military. And as you can see here, the score is broken down into two different ways. The first is a percentile score range, and the second is in categories. So for example, if you score a 31 on your AFQT, that means you'll have scored better than 31% of all test takers, and similarly, that would place you in category 3B. The AFQT score is calculated based on your performance on the arithmetic reasoning, the word knowledge, the paragraph comprehension, and the mathematics knowledge subtest of the ASVAB. So my advice to anyone who's currently preparing for the ASVAB is this: focus 100% of your studying efforts on these 4 sections. That way you can boost your AFQT score. Generally, the higher your AFQT score is, the more jobs that open up to you, and the better off you'll be in the long run. Okay? So all that said, let's go ahead and get started with today's guided practice. Again, I'm working out a full-length practice test from the Arithmetic Reasoning section of the ASVAB. I want to stress that on the ASVAB, you're not going to be given any aids such as a calculator or a formula sheet. Instead, you have to rely on your ability to do long division and multiplication, including with fractions and decimals, to be very successful on this section of the test. As you'll see in just a minute, I'm going to make an effort to work everything out in great detail. So that way, if you're rusty with long division or multiplication, you should be able to pick it up as you go through my practice test. That said, I am a human, so I may make a mistake on some of these problems. As you'll see shortly, some of these problems require a tremendous amount of work to get them done. So just bear with me if I make a mistake. Finally, I want to say the way you should use this video is as soon as I read a problem, you should pause the video, attempt to work it out yourself, and then as soon as you are confident you got the question right, or you're at a point where you're struggling and don't know how to move forward, go ahead and play the video and see what I do and go from there. So number 1, let me grab my pen first. Number 1, Barbara worked 30 hours last week. She earned $422. She's paid $455 this week. Approximately how many hours did she work? So we're interested in finding her hourly wage. And to do that, we're going to do dollars divided by hours to find the hourly wage. So we're told first that she earned $422 when she worked 30 hours. The way you can read this is 422 over 30, or as is the case with all fractions, 422 divided by 30. So let's go ahead and set this up. We're going to be doing long division to solve this problem. Again, this is going to be 422 divided by 30. And in case you forgot how to do long division, we say this. How many times does 30 go into 4 without going over? It doesn't. 4 is too small. How many times does 30 go into 42 without going over? The answer is 1 time. 1 times 30, of course, is 30. We subtract 42 by 30, which is 12. And then we drop down this 2. Now the question is, how many times does 30 go into 12? It doesn't. How many times does 30 go into 122 without going over? I'm going to go ahead and say, let's go with 4. Because 30 times 4, of course, is 120. Again, 30 times 4 is 120. Subtract. 122 minus 120 is simply 2. Does 30 go into 2? It doesn't. So we have to add a 0. When we add this 0, we have to bring up a decimal place. Okay? Does 30 go into 20? It doesn't. So we have to add another 0. And because we added a second 0, we have to add another 0 up here. So the first 0 I tacked on, I had to add a decimal place. The second 0 I tacked, in response to the second 0 I tacked on, I had to add a 0 here. Okay? So now the question is, how many times does 30 go into 200? Well, 3 times 10, not 10, 3 times 8, 3 times 6 is 180. 3 times 7 is, or 3 times 6 is 18. Therefore, 30 times 6 is 180. 3 times 7 is 21. Therefore, 30 times 7 is 210. So we know this is going to be a 6. Again, 30 times 6 is 180. Subtract. 20 minus 180, of course, is 20. And we can see that she gets paid 14. And there's going to be a remainder here. I'm just going to stop at this point because we have enough information to approximate, which is what we're asked to do, this answer. So now the question is, if she was paid $455 this week, approximately how many hours did she work? To make this math simple, I'm going to round this 1406 per hour to just 14. And again, we want to find out how many hours she worked. So we're going to do 400. Let me rewrite this somewhere down here. 455 divided by 14. Again, how many times does 14 go into 4 without going over? It doesn't. How many times does 14 go into 45 without going over? Take a look at our answer choices. They all start with 3. So I'm going to do 14 times 3. 4 times 3, of course, is 12. Carry the 1. 3 times 1 is 3, plus 1 is 4. So, again, 14 times 3 is going to be 42. Subtract. 45 minus 42 is 3. Drop down this 5. How many times does 14 go into 35? Again, we have 14, 28, and if I were to add 28 to 14, 8, 9, 10, 11, 12, carry the 1, 3, 4. These are the factors of 14. 14, 28, 42. We're asking ourselves, how many times does 14 go into 35 without going over? We can see it's 2. 14 times 2, of course, is 28. And as you can see here, we already have a good approximation of our answer, namely 32 hours. So in this problem, we had to do 2 instances of long division to get our answer. Number 2, Timothy runs every morning once around a circular track in a park close to his house. If the radius of the circular track is 50 yards, how far does Timothy run every morning? Okay, so Timothy's running around a circular track. We're told that the radius is 50 yards. Okay. And we're asked, how far does Timothy run every morning? So as far as circles go on the ASVAB, you need to know 2 formulas. You need to know the circumference formula, this formula for circumference, namely, and there's 2 of these formulas. 2 pi r, that is 2 times pi times the radius, are simply pi times diameter. These are equivalent. And you need to know the area formula, which is pi r squared. Okay? The key difference between circumference and area is this. Area refers to all the shaded portion, that is the face of the circle. Okay? Whereas circumference refers to this outer edge of the circle. Imagine if you were to start walking here and you were to walk in a circle. The distance it took you to walk around that circle would be the circumference. And if you think about it that way, it should help you keep them separate in your mind. In this case, we're asked to find out how far he runs around the track every morning. So we're going to be looking for the circumference. We're given the radius, so we're going to use this formula. So let's go ahead and start plugging stuff in. Circumference equals 2 pi. R in this case is 50. Circumference equals 50 times 2 is simply 100 pi. Now, for both of these problems, you can see that you have to address the fact that pi is there. Since you're not allowed to use a calculator, pi is always going to be 3.14. Okay? Again, in many cases, you're going to have to approximate answers like I did in the first problem. So you're going to have to use an approximation of pi, namely 3.14. So let's go ahead and rewrite this with pi. So this is 100 times 3.14. Now you could work this out by doing 100 times 3.14. That's the tedious way to do things when you have a whole number like 100. Instead, this is how you can do it. So whenever you multiply something by 10, 100, or 1,000, you count up the number of zeros. In this case, 100 has 2. And you move the decimal place twice to the right. 1, 2. So in this case, we know the circumference is going to be 314. So that math worked out pretty nicely for us. Again, you could have done this in my previous videos when I multiply a 3-digit integer by a 3-digit integer. I'm more likely to make mistakes. This is a lot of work. Knowing this shortcut reduces errors and the time it takes you to complete this problem. Okay. Number 3, Jack sets up a security camera in his backyard to take automatic pictures every 15 minutes. If the first picture is taken at 10 p.m. and Jack shuts the camera off at 2 a.m., how many pictures will Jack have? So first picture's at 10. And to make things simple, rather than trying to come up with a formula for this scenario, I'm just going to write out every 15 minutes. 10, 15, 10, 30, 10, 45, 11, 11, 15, 11, 30, 11, 45, 12, 12, 15, 12, 30, 12, 45, 1, 1:15, 1:30, 1:45, and finally 2 o'clock. So these timestamps are when pictures were taken on his security system. Just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So between 10 p.m. and 2 a.m., 17 pictures were taken. Again, don't overthink problems like this. I could have used a formula to solve this one. Since I knew it was fairly simple to write out, that's the approach I took. Again, like this example right here, I could have taken this approach and it would have created more work and more mistakes. Always go with what's going to be simple and quick and accurate. All right. All right, number 4. Joy is trying a new weight loss plan. The theory seems simple. Eat fewer calories and exercise more. The book says that Joy's body burns 2,000 calories per day to maintain her current weight, and every 2,500 calorie deficit is a pound of weight lost. If Joy burns 400 calories per day exercising and goes on a 1,500 calorie per day diet, how many pounds should she lose in one 7-day week? So first we need to find out what her daily caloric deficit is. Then we need to find out what that is multiplied by 7. And then we need to take that number and divide it by 2,500 to figure out how many pounds she lost. So we know that 2,000 is the number of calories she eats to maintain her current weight. We're told that she went on a 1,500 calorie diet. So in other words, every day, just by dieting, she's incurring a deficit of 500 calories. And we're also told that she's burning 400 additional calories by exercising. So we know each day she's incurring a 900 calorie deficit. She's doing that over the course of a 7-day week. So we're going to multiply that by 7. 7 times 0 is 0. 7 times 0 is 0. 9 times 7 is 63. So over the course of the week, she's burning and dieting 6,300 calories. Now we're told that there are 2,500 calories per pound lost. So we're going to take 6,300 and divide it by 2,500. Okay. Again, you can read this as 6,300 over 2,500, or in our case, 6,300 divided by 2,500. To make the division simple, I'm going to kick off these zeros. So this is going to become 63 divided by 25. Let's go ahead and work this out. Again, 63 divided by 25. 25 times 2 is 50. 25 times 3 is 75. So we know this is going to be 2. 25 times 2 is 50. 63 minus 50 is 13. And right away, we can see that we're done. This basically says she's losing 2-point-something pounds over the course of the week. Answer choice 4, answer choice 5, answer choice 3. We can see it's going to be 2-something. So we could stop at this point, and if you're taking the real ASVAB, you need to be able to see this and realize you're done. Okay? So if you wanted to continue working this out, that'd be fine. But I'm going to go ahead and stop. We already know it's going to be 2-point-something pounds. More specifically, it's going to be 2 and 13 over 25 pounds. 13 is very close to 1/2. So they clearly did an approximation on this. Okay, so this is our answer. Alright, number 5. Jimmy B's Diner runs a breakfast special. If a customer buys the special for $2, he can come back on consecutive days and eat for just $1.25. If a person paid $8.25 for breakfasts during the week, how many consecutive days did he eat breakfast at specials at Jimmy B's? So again, consecutive days means how many days in a row. Okay? So to answer this question, we want to find out how many days in a row did this person eat breakfast at Jimmy B's. We're told that the first breakfast costs $2. So right away we're going to take $8.25 and minus $2 from that, because this is the first day. 5 minus 0 is 0. 2 minus 0 is 0. Bring down your decimal place. 8 minus 2 is... Oops, I did that wrong. 5 minus 0 is 5. 2 minus 0 is 2. 6 minus 8, or 8 minus 2 is 6. Okay, so this is basically breakfast number 1 right here. Now we're told that after they pay once, they can come back each consecutive day for $1.25. So we're going to take $6.25 divided by $1.25 to figure out how many consecutive days after the first day they came back. So we're going to do some long division here. Here's how you do long division. You cannot do long division with decimals with this number, this 125, as a decimal. You just cannot do it. You have to move this decimal twice to make this a whole number, namely 125. When you move this one twice, you have to move this one that's under the division bar twice as well. Okay? So this, in other words, becomes 625 minus 125. I'm going to take a guess and say 125 goes into 625 5 times. 5 times 5, of course, is 25. Carry the 2. 2 times 5 is 10. Plus 2 is 12. Carry the 1. 5 times 1 is 5, plus 1 is 6. So it turns out that 125 goes into 625 5 times evenly. Again, that's 625. We subtract, that's 0. No remainder. So again, how many consecutive days did this person eat at Jimmy B's? The first day plus 5 consecutive days for a total of 6 days in a row. Okay, number 6. 40 soldiers in basic training are to undergo hand-to-hand combat training in a 60-minute training period, but only 10 can be trained at one time. In order for each soldier to get the same amount of time training, how many minutes should each soldier be trained? So basically, you're going to do 60. You know there are 40 people total, and they can only be trained in groups of 10. So you know there are going to be 4 groups at least. So this becomes 60 divided by 4. Again, long division. 4 goes into 6 one time without going over. 4 times 1, of course, is 4. Subtract. 6 minus 4 is 2. Bring down this 0. 4 goes into 25 times. 5 times 4 is 20. Subtract. That becomes 0. So for all the groups of 10 to get through, you're going to have to give them 15 minutes each. Okay? Number 7, Steve can make 9 candles in an hour. How long will it take him to make 126 candles? So we can set up a proportion to solve this problem. Again, Steve can make 9 candles in 1 hour. So I have candles over time. The question is, how long will it take him to make 126 candles? Again, candles over time, which is unknown, so I'm going to represent that with an X. Cross multiply. That is 9x equals 126. Divide both sides by 9 to get x by itself. This crosses out. We're left with x equals 126 over 9. Again, you can read this as 126 over 9 or 126 divided by 9. Let's go ahead and work that out to this off to the side. Does 9 go into 1? It doesn't. Does 9 go into 12 without going over? 1 time. 9 times 1 is 9. Subtract. 12 minus 9. 9, 10, 11, 12. That's 3. Drop down this 6. Does 9 go into 36 without going over? It does. 4 times. 9 times 4 is 36. So there's no remainder. So as we can see, the answer to this problem is going to be 14 hours. Okay, number 8. I'm just going to say this before I start this problem. This is, at first glance, an easy problem, but once we get into it, you're going to see that it's a very difficult problem. So if you're doing very well on the ASVAB, you're going to see something like this. If for some reason you struggle with what I explain here, bear in mind that this is a higher level problem. So number 8, your boss gives you a bonus and you decide to carpet the bedrooms in your house. The house contains one 12 by 14 foot bedroom, one 12 by 10 foot bedroom, and one 8 by 12 foot bedroom. If carpet costs $4.25 per square yard, how much will this project cost? So we can see we're given the areas of the rooms in terms of feet, but we're given the cost of carpet in terms of yards. That's a conflict. We cannot just simply find the areas and multiply them by this figure. That would not work. It'd be inaccurate. So what I want to point out first is this. And I'm going to do it over here with some in this blank space that I have. We're told that it's $4.25 per square yard, but we're given everything in feet. We know that there are 3 feet in 1 yard, and we know we're going to be dealing with area. How many square feet are there in 1 square yard? So again, think about it this way. A square yard looks like this. Length times width are side by side. Again, we know this can be 1 yard or 3 feet, and 1 yard or 3 feet. 3 times 3 is 9. So given this, we know there are 9 feet in 1 yard squared. Okay? So we're going to use this information once we get to a certain part in this problem to actually make a little conversion. So just stay tuned. Keep this in mind. And this is useful to know. 3 feet in 1 yard, most of you knew that. 9 feet in 1 square yard. If you didn't know how to make a little square here and figure that out, now you do, and this is very useful. Okay, so first I want to add up all these areas. We're told that one is 12 by 14. One room is 12 by 10. And another room is 12 by 8. Do this one right away. 12 times 10 is 120. Let's work out these other two by hand. Again, 14 times 12. 4 times 2 is 8. 2 times 1 is 2. Drop down to 0 since we're starting a new row. 1 times 4 is 4. 1 times 1 is 1. Let's add. 8 plus 0 is 8. 4 plus 2 is 6. 1 plus 0 is 1, so we know this is 168. Let's do 12 times 8. 8 times 2 is 16. Carry the 1. 8 times 1 is 8, plus 1 is 9. So that's 96. Let's go ahead and add these up. 8 plus 0 plus 6. 14. Carry the 1. We have 9. Or 6 plus 1 is 7. Plus 2 is 9. Plus 9 is 18. Carry the 1. 1 plus 1 plus 1 is 3. So we know the sum of all the areas of the room is 384 feet squared. Okay? So what I'm going to do is, at this point, I'm going to use this fact that there are 9 feet in a square yard to actually convert this to yards and then multiply by 425. So again, I'm going to do 384 divided by 9. Okay. Does 9 go into 3? It doesn't. Does 9 go into 38? It does 4 times. 9 times 4, of course, is 36. Subtract. 38 minus 36 is 2. Drop down this 4. 9 goes into 24 2 times. 9 times 2 is 18. Subtract. 24 minus 18. 18, 19, 20, 21, 22, 23, 24. 6. Does 9 go into 6? It doesn't, so we have to add a decimal. 9 goes, and when we add that decimal, we have to bring a 0 down. 9 times 7 is 63, which is too big. 9 times 6 is 54, so we're actually going to make this 0.6. 9 times 6 is 54. Subtract. 60 minus 54 is 6. So we can see here that we're kind of stuck with this remainder of 6 repeating over and over again. Again, this would be, if I were to work it out, 0.66666 repeated. So again, to get some of these questions right, it's always easier to get to this point and then make an estimation. So what I'm going to do is I'm going to round this up to just 42.7. Now when I do that, I know that the answer I get is going to be very close to the right answer, but it's going to be slightly bigger since I rounded up. So now I'm going to take 42.7 and multiply it by 4.25. Again, that's the total square yards of all the rooms. And that's the cost per square yard. Again, I did the conversion there. Now I'm multiplying decimals. To multiply decimals, like dividing decimals, you make everything a whole number. I'm going to move this decimal place once to make that 427. Move that decimal place twice to make that 425. So in total, I moved 3 decimal places. At the end of this problem, I'm going to tack those back on. So let me rewrite this so I don't make any mistakes. When you multiply 3-digit integers by 3-digit integers, your odds of making a mistake go way up. If you want proof of that, go watch one of my other videos. I've made a mistake on a problem like this before. These are very tedious. That's why calculators were invented. But if you're going to score, a 93 or higher on the ASVAB, got to be able to deal with stuff like this. So let's go ahead and work it out. 9 times 7 is 35. Carry the 3. 2 times 5 is 10. Plus 3 is 13. Carry the 1. 4 times 5 is 20. Plus 1 is 21. Bring down a 0 since we're starting the second integer. 2 times 7 is 14. Carry the 1. 2 times 2 is 4. Plus 1 is 5. 4 times 2 is 8. We're starting the third integer, so we bring 2 zeros down. 4 times 7 is 28. Carry the 2. 4 times 2 is 8. Plus 2 is 10. Carry the 1. 4 times 4 is 16. Plus 1 is 17. Let's add. 5 plus 0 is 5. 3 plus 4 is 7. 5 plus 1 is 6, plus 8 is 14. Carry the 1. 8 plus 2 is 10, plus 1 is 11. Carry the 1. 7 plus 1 is 8. 1 plus nothing is just 1. Again, 181,475. Got to add my 3 decimal places back in. 1, 2, 3. And we get 181.475, which, as we can see, is very close to number A. Again, if I didn't round, I would have gotten this exactly. But since I'm lazy and I want to work quickly and accurately, I know that my answer choice is going to be close, but it's going to be slightly off because I rounded a little bit. Okay? A lot of work for that problem. Again, if you're doing very well on the ASVAB, you'll start seeing stuff like this. Alright, number 9. In a manufacturing plant that produces new CD players, there is a 15% probability that a CD player will be defective. If 5 CD players are manufactured, what is the probability all of them will be defective? Okay? This is a statistics problem, and it's not a very easy one, to be honest with you. Again, if you're doing well in the ASVAB, you may start seeing problems like this. The way I like to think about this problem is the way I think about all statistics problems, that is in terms of dice. So we all know dice have 6 faces. There's a 1, a 2, a 3, a 4, a 5, and a 6 face. Don't count the dots on that last one. The odds of rolling any one of these faces on any given roll is 1 over 6. Okay? So if I were to ask you, what are the odds of rolling a 3? You would say 1/6. If I were to ask you, however, what are your odds of rolling a 3 2 times in a row? Well, that would be 1/6 times 1/6, or 1 over 36. Okay? This question is very similar. It's basically saying if there's a 15% probability that a CD player will be defective, what are the odds that 5 are manufactured and all of them are defective? So it's basically this. Again, 15% can be represented as 15 over 100, which is 0.15. So you can either do it this way, or this way. Again, just like this question, it's 15% times 15% times 15% times 15% times 15%. That is 15% times itself 5 times. It turns out when you do this, the number is going to be very, very small, and it's going to be this one. Okay? Just based on my knowledge of math alone, I wouldn't have to work this out to solve it. And you can see that it would be a tremendous amount of work to work this out. Again, if you get a question like this, chances are you're already scoring in the 90 percentile rank or above. So take the time to work this one out. I'm not going to do it because multiplying 0.15 by itself 5 times is a tremendous amount of work. This would take about 5 minutes in and of itself. Okay? If you want, pull up a calculator. right now and multiply that all out and see if this is what comes up. I guarantee it will. Okay, number 10. A box containing books weighs 60 pounds. If the books weigh 53 pounds, what is the weight of the box alone? 60-pound box full of books. Books weigh 53 pounds, so we know the books just weigh, or the box weighs 7 pounds. A simple problem. Not much to explain on that one. All right, number 11. Paul decides to buy his dad socks for his birthday. He has $30, and the socks he wants sell for $3.95 per pair. Assuming no sales tax, how many pairs of socks can he buy? So this becomes this problem. 30 divided by 3.95. Looks like a fairly simple problem, but you can see we have a decimal here. Remember what I said earlier. You have a decimal on the outside of the division problem. You have to make this a whole number. In this case, we're going to have to move it twice to make that 395. When I move this one twice, I have to take this one and move it twice. So this problem becomes 395 and 3,000. So this problem becomes 3,000 divided by 395. Okay? Again, if I were to round this up to 400, I know 4 times 7 is 280, so 395 times 7 is going to be close to 2080. So let's go ahead and just multiply this by 7 and see if that gets us close to 3,000. 5 times 7 is 35, carry the 3. 9 times 7 is 63, plus 3 is 66, carry the 6. 7 times 3 is 21, plus 6 is 27. Okay, as we can see, this gets us very close to 3,000 without going over, so we know this is going to be 7. 7 times 395 is 2,765. Subtract. Now I'm going to do this subtraction off to the side because it gets a little hairy. Again, 3,000 minus 2,765. I have to borrow. I can't do 0 minus 5. I can't do 0 minus 6, and I can't do 0 minus 7. So I have to borrow from this 3. I'm going to make this a 2. This will become a 10. Okay, now I can do this one, but I can't do these two. So I got to borrow from this 10 and make this a 9. This one becomes a 10. Now I just can't do this one. So I got to borrow from this 10, make it a 9, and this becomes a 10. So this is 10 minus 5, which is 5. 9 minus 6, which is 3. 9 minus 7, which is 2. And 2 minus 2, which is 0. So this is 235. Does 395 go into 235? It doesn't. So I have to add a 0. When I do that, I have to put a decimal up there. Now the question is, how many times does 395 go into 2,350? Again, think about this as 400. 400 times 6 would give you 2,400, which would be too big. 400 times 5 would get you 20, which is pretty close. So this would actually be 7.5. So let's take a look at the problem. Assuming no sales tax, how many pairs of socks can he buy? Well, he can afford 7 full pairs of socks and 1 half pair of socks. Well, you can't just buy a half pair of socks because that would just be 1 sock. So in this case, he can only afford 7 full pairs of socks. All right. Number 12. Penny makes $25.70 in tips on Wednesday, $32.30 in tips on Thursday, and $31.80 in tips on Friday. On Saturdays, she spends 1/4 of the money on dinner with her friend. How much money does she have left? So we know she made $25.70, $32.30, and 31.80. Let's go ahead and add those up to find out how much money she has total. 0 plus 0 plus 0 is 0. 7 plus 3 is 10. Plus 8 is 18. Drop down our decimal. Carry our 1. 5 plus 2 is 7. Plus 1 is 8. Plus 1 is 9. 3 plus 3 is 6. Plus 2 is 8. So we know she earned $89.80 from tips alone. That's not the right answer choice, because the question is, after spending a quarter of her money on tips, on dinner, how much money does she have left? So in other words, this is $89.80. Again, 1/4 is this, 1/4. So we know we're going to divide this into quarters, which is fourths. So we're going to divide this by 4. Again, since there's no decimal in this number on the outside of the division bar, we don't have to rearrange things. It's fine if you leave it here. Okay? And again, you can actually bring it up right here. Does 4 go into 8? It does. 2 times. 4 times 2, of course, is 8. Subtract. 8 minus 8 is 0. Again, just drop down all these numbers. Does 4 go into 9? It does. And again, oops, I didn't want to bring that decimal up. Sorry about that. I haven't done long division with decimals in a while. Does 4 go into 9? It does. It goes into it 2 times. 4 times 2, of course, is 8. Subtract. 9 minus 8 is 1. Drop down that 8. Drop down that 0. 4 go into 1? It doesn't. Does 4 go into 18? It does. 4 times 4 times 4 is 16. 18 minus 16 is 2. Drop down this 0. 4 goes into 25 times. So we know a quarter of 89.80 is 22.45. Okay? So in light of that, to answer this problem, we're going to do 89.80 minus 22.45. Again, that's a quarter. That's not going to be the answer, because that's what a quarter of 89.80 is. Subtract this out. 0 minus 5 we can't do. We have to borrow this. That becomes a 7. That becomes a 10. 10 minus 5 is 5. 7 minus 4 is 3. Drop down your decimal. 9 minus 2 is 7. 8 minus 2 is 6. So the answer is 67.35. Again, had to be comfortable adding decimals and dividing decimals. I hope some of these problems get a little bit easier. Right now they're a little tedious. Number 13. Your mom sends you to the store to buy peas. She said she needs 8 ounces of canned peas to finish her recipe, and tells you to choose the cheapest peas. Which would be the cheapest to buy? 2 4-ounce cans of peas at 79 cents a piece. So 79 times, oops, I wrote 72. 79 times 4. 9 times 4 is 36. Carry the 3. 7 times 4 is 28 plus 3. 28, 29, 30, 31. What did I do here? Oh, why am I multiplying that by 4? It's 79 times 2. Sorry about that. 9 times 2 is 18. Carry the 1. 7 times 2 is 14. Plus 1 is 15. So we know this is $1.58 total. Okay? 1 ounce can of peas at $1.49. That's cheaper than $1.58, so we can cross this one out. 2 3-ounce cans of peas at 59 cents each, so we're buying 3 cans at 59 cents. 9 times 3 is 27, carry the 2. 5 times 3 is 15, plus 2 is 17. So we know these are $1.77. And 3, oops, that's a mistake again. It's always the simple problems I make mistakes on. 2 3-ounce cans of peas at 59 cents. Again, the recipe needs 8 ounces. 2 3-ounce cans is only going to be 6 ounces, so we know that's not the right choice. 3 3-ounce cans of peas at 65 cents, so that's 65 times 3. 5 times 3 is 15, carry the 1. 6 times 3 is 18 plus 1, 19. So this is $1.95. So clearly B, or $1.49, is the cheapest option. Sorry about those mistakes. I usually make small mistakes like that in every video I upload, so sorry about that. Number 14 is very difficult to do. It's in regard to distance equals rate times time, albeit with a lot of twists and turns to it. I have a video called Mastering Distance, Rate, and Time Problems on the ASVAB, where I work out this problem specifically. Take a look at that video for practice on this problem, as well as I think there's 4 other problems I work out in that video. So I'm going to skip this one since I already made a video on it by itself. Okay. Uh, 15. A bin of screws at the hardware store contains 7 dozen screws when full. The stock clerk is supposed to reorder screws when the bin is 1/6 full. How many screws are in the bin when it comes time to reorder? So we know there are 7 dozen. So that's going to be 7 times 12. 2 times 7 is 14. Carry the 1. 7 times 1 is 7, plus 1 is 8. So we know there's supposed to be 84 screws in the bin. And the stock clerk has to refill the bin when it gets to 1/6 full. So we're going to take 84, multiply that by 1/6. Again, when you multiply fractions with a whole number, you can make a whole number a fraction by putting it over 1, and then you multiply straight across. So this becomes 84 over 6. Again, 84 times 1, 1 times 6. And again, you could read this as 84 divided by 6. So we have to do that in this case. 84 divided by 6. 6 goes into 8 one time without going over. 6 times 1, of course, is 6. Subtract. 8 minus 6 is 2. Drop down this 4. 6 goes into 24 4 times. 4 times 6, of course, is 24. So there's no remainder. So based on this, we know when there are 14 screws left in the bin, which is 1/6 of the 7 dozen, the clerk needs to order more. Number 16, Autumn found a wallet containing $900 in the street. She returned the wallet to its owner, who gave her a $130 reward. What percentage of 900 was the reward? So she was given a $130 reward. What percentage or proportion over 900 is that? So that's this problem. To make this problem easier, kick off these zeros. Rewrite the problem as 13 divided by 90. And again, that can be read as 13 divided by 90. Does 90 go into 13? It doesn't, so I have to add a 0 here. When I do that, I have to bring up a decimal. Now the question is, does 90 go on 130? Let's see. It does. Let me see here. I may have made a mistake. Bear with me. It does. So, sorry about that. I just had a little bit of a brain fart there. Does 90 go into 130? It does. One time. 90 times 1, of course, is 90. 130 minus 90 is 0 minus 0 is 0. 13 minus 9 is 4. So 130 minus 90 is 40. Does 90 go into 40? It doesn't, so I have to add a 0. Does 90 go into 400? And again, we can see that this answer is going to be 0.1 something. So it's not this one, nor is it that one. Does 90 go into 400? I'm going to say it does. I'm going to say it does 4 times. 4 times 0 is 0. 4 times 9 is 36. So 4. 90 times 4, of course, is 36. We subtract. 400 minus 360 is 40. Again, we're in the same scenario. We have to add a 0. 90 goes into 400 4 times. So this is just going to be 4444. Repeat it. Or, if we round, 14%. All right, number 17. A 12-yard long string was used to enclose a freshly painted flower garden, forming a square around the garden. If each side of the square used the same amount of rope, how long was one side of the square surrounding the garden? So again, we formed a square around the flower garden. All the sides are the same, and we know a 12-yard long string was used. So the perimeter is going to be side plus side plus side plus side. In other words, all the sides are equal since this is a square. And what's more, we know side plus side plus side plus side is going to be 12. That is 1, 2, 3, 4. 4s equals 12. Now we solve for s. Divide both sides by 4. That goes away. We're left with s equals 12 divided by 4, or 3. So we know each of these sides is going to be a distance of 3 yards, which is right there. All right, number 18. Brittany's on her high school track team. This year she placed first in 4 of her races, so she went first, second in 6 of her races, so second, and third in 8 of her races, so third. Okay. The fraction of races in which she placed first is correctly expressed as. So out of all of her races, how many times did she place first? Again, 1, 2, 3, 4. She placed first 4 times out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 races total. We can reduce this by a factor of 2. I'm going to divide the top by 2 and the bottom by 2. 4 divided by 2, of course, is 8. 18 divided by 4 divided by 2 is 2. 18 divided by 2 is 9. So this is 2 ninths. That is to say, she placed first in 2 out of every 9 races she was a part of. Okay, number 19. A rectangle is 3 times as long as it is wide. So we got a rectangle. The perimeter of the rectangle is 147 inches. What is the length of the rectangle? So we're told that it is 3 times as long as it is wide. So if it's x wide, it's 3x long, okay? And that's the length, this is the length, that's the width, this is the width. If the perimeter is 147, what is the length of the rectangle? So again, just like this problem, we're going to do 3x plus 3x plus x plus x, should be a plus there, equals 147. Again, to find the perimeter, you add up all the sides, which we've conveniently written as x and 3x. So this becomes 3x, 6x, 7x, 8x. 8x equals 147. Divide both sides by 8 to get x by itself. 147 divided by 8. Does 8 go into 14? It does one time. 14, 1 times 8 is 8. 14 minus 8, of course, is 6. Drop down this 7. Does 8 go into 67? It does 8 times. 8 times 8, of course, is 64. Subtract. 67 minus 64 is 3. Does 8 go into 3? It doesn't. We have to add a 0. Add a decimal when we add a 0. 8 goes into 33 times. 8 times 3, of course, is 24. 30 minus 24 is 6. Okay. Add a 0. Does 8 go into 60? Let's think about that. It does 7 times. So we know we're going to be working with the decimal here. We can round it to 8.4 since we know this 7 is going to kick that 3 up. So we know x is equal to approximately 18.4. We want to find its length. So we're going to take 18.4 and multiply it by 3. Again, we're going to make this a whole number by moving this decimal over 1. We'll add it back in at the end. 4 times 3 is 12 plus 1. 8 times 3 is 24 plus 1 is 25. Add 1. 3 times 1 is 3 plus 1 is 4. Again, bring that decimal back in. So this becomes 45.2, which we can see up here is going to be 45 inches. All right, number 20. Lyle bought a trampoline that measures 9 by 12 feet. If he wants to surround the trampoline with a fence so that the fence is 8 feet from each edge of the trampoline, how many feet of chain link fence will he need? So we know he's got a trampoline that is 9 feet wide by 12 feet long, and we know he wants a perimeter of at least 8 feet on it. So it's going to be 8 feet this way, 8 feet this way, 8 feet this way, and that's not drawn to scale. 8 feet this way. So you can see that the fence is going to look like this. This distance is 12, but we want 8 additional feet to get to the fence here. So this becomes 12 plus 8 plus 8. Again, this is going to be extended 8 to the fence and 8 to the fence. Similarly, this 9 is going to be extended 8 to the fence and 8 feet to the fence. So this becomes 9 plus 8 plus 8. And we're asked to find how many feet or the perimeter of the chain link fence we're going to need. So this is 9 plus 16. 6 plus 9, of course, is 15. Carry the 1. 1 plus 1 is 2. Again, this is 12 plus 8 plus 8, or 12 plus 16. 12 plus, or 6 plus 2 is 8. 1 plus 1 is 2. So we know we're going to have the fence is going to look like this. 25, not there, 25, 25, 28, 28. So we just have to add all these up. 25 plus 25 is 50. But let me write that out. 25 plus 25 plus 28 plus 28. Again, this is 50. Let's find out what 28 plus 28 is. 8 plus 8 is 16 plus 1, or carry the 1. 2 plus 2 is 4, plus 1 is 5. So this becomes 56 plus 50, or simply 106 feet. Alright, number 21. A painter has painted a picture on a piece of canvas that measures 10 by 14 inches. In order to accommodate a frame, he has left an unpainted margin of 1 inch all the way around. What part of the canvas has been painted? So again, we got a canvas here. We know the canvas is 14 by 10. And we're told that the painter has left a 1 inch border to frame his painting. So this is just the area that's going to get painted. We're asked to find out what proportion of the area of this canvas is going to be painted. So this becomes 14 minus an inch, so this becomes 12, and this becomes 10 minus an inch on the left and minus an inch on the right, or 8. So the total area on the canvas is 10 times 14, whereas the painted area on the canvas is 12 times 8. That would be the correct proportion. That is painted area over total canvas area. 12 times 8 is 8 times 2 is 6. Carry the 1, or 16. Carry the 1. 8 times 8 is 1. Plus 1 is 96. So this becomes 96 over 140. Again, we know 752% is not going to be equivalent to this. We know that this is much greater than 25%. So the question is 96 divided by 140 68.5% or 66.1%? So we got to do some long division. 96 divided by 140. Does 140 go into 9? It doesn't. Does 140 go into 96? It doesn't. We have to add a 0. In adding the 0, we have to bring a decimal up there. Now the question is, how many times does 140 go into 96? Again, we know it's going to be 6 to start things off. So let's do 140 times 6. 6 times 0 is 0. 6 times 4 is 24. Carry the 2. 6 times 1 is 6. Plus 2 is 8. So we know this is going to be 840. Subtract. 0 minus 0 is 0. 6 minus 4 is 2. And 9 minus 8 is 1. Now the question is, and again that was 6. Now the question is, how many times does 140 go into 120? It doesn't, so we have to add a 0. How many times does 140 go into 1200? It's either going to be 8 or 6. In this case, we know it's going to be 8. So we're going to do 140 times 8. 0 times 8 is 0. 8 times 4 is 32. Carry the 3. 8 times 1 is 8, 9, 10, 11. So we know this is 11, 20. And we can stop right there. We can see that this is going to be 0.685, which is answer choice A. Again, you do not have to work something out all the way if you know what it's going to be once you reach a certain point in the problem. Alright, number 22. A road map is drawn to a scale of 2 inches equals 3 miles. John wants to drive to a point that is 9.5 inches away. How many actual miles does this represent? So again, we're given the scale 2 inches equals 3 miles. I always like to put this in unit form. That is 1 inch equals how many miles? So this is going to be 1 inch equals 1.5 miles. And similarly, we know that half of an inch, or 0.5 inch, is going to be half of this, which is 0.75 miles. I like to do this right off the bat, just do these quick conversions. That way I can actually use these when I'm working out the problem. So we're told that he wants to drive to a point that's 9.5 inches away. So I'm going to use this 1 inch equals 1.5 miles to find out how far 9 inches is. Then I'm going to add 0.75 to represent the half mile, or the half inch. So 1.5 times 9. This will get us the 9 inches. Again, since we have a decimal in multiplication, we'll move it once, and we'll add it back in at the end. 5 times 9 is 45. Carry the 4. 9 times 1 is 9, plus 4 is 13. Add our decimal back in, 1. Again, that's 9 inches. We still have this half inch to account for, so we have to do 13.5 plus 0.75. 0 plus 5 is 5. 7 plus 5 is 2, or 12. Carry the 1. 3 plus 1 is 4. 1 plus 0 is 1. So we know this is 14.25 miles, or 14.25 miles. Again, 0.25 is equivalent to 1/4. Okay, 23. A field measures 100 yards by 75 yards. If one person wanted to walk diagonally from one corner of the field to the other corner, how far would she walk? So we know we got a rectangular field that measures 75 by 100. Question is, how far would it take someone to walk from this point to this point, that is diagonally? Well, as you can see, these are all right angles and rectangles. And when you draw a diagonal across a rectangle, you actually split the rectangle into 2 right triangles, okay? And this is the distance we're after. When you have a right triangle like this, you can use the Pythagorean theorem to find the hypotenuse, which I denoted with the x. Pythagorean theorem is this: a squared plus b squared equals c squared. And again, c squared is the hypotenuse, the distance of the hypotenuse, or the length of the hypotenuse. The hypotenuse is always directly across from the right angle, so the c squared in this case would be right here, the x or the c, however you want to denote it. And we have the 2 distances of our lengths of our legs. So we can plug these in. 75 squared plus 100 squared equals c squared, or x squared, whatever you want to put in there. And you might be looking at this and saying, wow, that's a lot of math. 75 times 75, 100 times 100, those are big numbers. Well, before I go any further, I'm going to reduce this all by a factor of 25. I know 25 goes into 75 3 times, and I know 25 goes into 100 4 times. So at the very end of this, instead of dividing c squared by 125, I'm actually going to reverse that and multiply it by 25 to get the actual distance. So this becomes this. 3 squared, of course, is 9. 4 squared is 16. Again, this all equals c squared. 9 plus 16 is 25 equals c squared. Square root both sides to find the answer. C just becomes 5. Now again, I divided both of these by 25 to make this math very simple. Now I'm going to take 5, multiply it by 25 to get the actual distance. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12. So we know this actual distance is 125 yards. Okay? Again, you have to be pretty comfortable using little tricks like this to make the math easier. You could have worked this out by doing 75 times 75. Again, and you could have done 100 times 100. When you work long multiplication problems out like these, you're apt to make mistakes. So long as you're comfortable reducing and then going ahead and adding and fixing that at the end like I did here, you should be fine. Okay, number 24. Let me just see how many more problems we have. So there's 30. Okay. And as you can probably tell if you've watched the video this far, this section of the test is pretty intense. It takes a lot of mental focus to work your way through it. 24. Michael owns a consignment shop in which he earns 35% commission on items he sells. If Michael had $8,434.80 worth of sales in the week, how much was his commission? So we're going to take 8,434.8 and multiply that by 0.35. That's 35%. Again, we're multiplying two decimals, so we're going to move this decimal 1, 2. Move this decimal 1, 2. So we move the decimal a total of 4 places. At the very end, we'll add those decimals back in. But in the meantime, I'm going to rewrite it just to keep things clear. Again, I just rewrote it without the decimals. 0 times 5 is 5. 8 times 5 is 40. Carry the 4. 4 times 5 is 20. Plus 4 is 24. Carry the 2. 5 times 3 is 15. Plus 2 is 17. 5 times 4 is, and I got to carry the 1. 5 times 4 is 20. Plus 1 is 21. Carry the 2. 5 times 8 is 40, plus 2 is 42. Alright, add a 0 since we're starting this second row. 3 times 0 is 0. 8 times 3 is 24. Carry the 2. 4 times 3 is 12, plus 2 is 14. Carry the 1. 3 times 3 is 9, plus 1 is 10. Carry the 1. 4 times 3 is 12, plus 1 is 13. Carry the 1. 4 times 8 is 24, plus 1 is 25. Let's add. 5 plus 0 is 5. 0 plus 0 is 0. 4 plus 4 is 8. 7 plus 4 is 11. Carry the 1. 1 plus 1 is 2. 2 plus 3 is 5. 4 plus 5 is 9. And 2 plus 0 is just 2. Add in our 4 decimals. 1, 2, 3, 4. So we can see this is 2,952.18, which is right there. Again, not a hard problem. If you're good at multiplying decimals, which you should be if you watch my videos, it's fairly easy. But that said, it's very tedious right in here where you can make a lot of mistakes. Alright, 5 more problems. 25, the sum of 3 consecutive odd numbers is 171. What are those numbers? There's a way you can do this with a math formula, but it's not necessary in light of how easy this one is. Just add up these numbers for A, B, C, and D, and when you get the right one, you're done. So I'm just going to try to get lucky and pick this one first. 61 plus 59 plus 57. 9 plus 7 is 16, plus 1 is 18. I know this isn't going to work because I got an 8 instead of a 1 there. Let's try B. 55 plus 57 plus 59. 7 plus 9 is 16, plus 5 is 21. Carry the 2. 5 plus 5 plus 5 is 15, plus 2 is 17. So we know this one is B. Don't worry about doing algebra on this one. Again, if it doesn't require you to use algebra and you're not comfortable doing that, just add them up and move on. Rod smokes 1.5 packs of cigarettes a day. Rod buys cigarettes by the carton. There are 10 packs of cigarettes in each carton. If Rod pays $35.80 per carton, how much does it cost him for each day of smoking? So again, we have $35.80 for 10 packs. So this becomes $35.80 divided by 10. As I mentioned earlier, when you divide or multiply by 10, 100, or 1,000, you just move the decimal place left or right accordingly. When you divide by 10 or 100, you move the decimal place to the left by the number of zeros. So there's a 1 0 here. This gets moved to the left 1. So this becomes 358. I'm done with that division. That quickly. Got to be able to do that. So it's 358 per pack. We know he smokes 1.5 packs a day. So we're going to do 358 times 1.5. Again, we're multiplying decimals. So we have to make these whole numbers. I'm going to move this decimal place twice. Move this decimal place once. 2 plus 1 is 3, so we move 3 decimal places total. I'm going to rewrite this. 358 times 15. Now these are whole numbers. Again, be careful doing this. You don't want to make any simple mistakes. 5 times 8 is 40. Carry the 4. 5 times 5 is 24. Or 5 times 5 is 25, plus 4 is 29. Carry the 2. 5 times 3 is 15, plus 2 is 17. Bring down a 0 since we're starting a new number here. 1 times 8 is 8. 1 times 5 is 5. 1 times 3 is 3. Add. 0 plus 0 is 0. 9 plus 8 is 17. Carry the 1. 5 plus 7 is 12. Plus 1 is 13. Carry the 1. 3 plus 1 is 4. Plus 1 is 5. We took 3 decimal places away here. Let's add them back in. 1, 2, 3. So this becomes 5.370, or $5.37, which is right there. Now, let's go back to 27. The price of daily admission at Wally World is $27. They do, however, sell season passes for $175. How many trips would you need to make with the season ticket in order to cost less than paying the daily admission? Okay, so we know it's $27 to get in one day, and it's $175 for season tickets. So just multiply, let's see, all these by 27. I'm trying to think if that's the best way to do this. Just bear with me. Actually, I'm going to do 175 divided by 27. Still thinking about the best way to explain this one. Let's multiply each of these days by... Actually, let's do 175 divided by each of these number of days, because when we divide our costs by days, we're going to get the cost per day, which we want to be less than 27. Okay? So disregard this. So first, I'm going to try to get away with doing this by dividing 175 by 7. I always like to pick in the middle with problems like these. So 175 divided by 7. Does 7 go into 1? It doesn't. Does 7 go into 17? It does twice. 7 times 2 is 14. 17 minus 14 is going to be 3. Drop down this 5. 7 goes into 35 5 times. So in other words, if you were to use your season pass and go to Wally World 7 times, it would be the equivalent of paying $25 each time, which is less than 27. Okay? Let's see if 8 is less than 27. If not, we know 7 is going to be our answer. So 175 divided by 8. 8 goes into 17 twice. 8 times 2 is 16. 17 minus 16 is 17 minus 16 is 1. Drop down this 5. 8 goes into 5 one time. So we know 8's going to be a lot less. Of course, that's a given. I shouldn't have done that one. Let's do 175 divided by 6. If this is less than 27, we know 6 is the answer. I shouldn't have done the 8. That was my error there. 6 goes into 17 twice. 17 or 2 times 6 is 12. 17 minus 12 is 5. Drop down this 5. 6 goes into 55 9 times. Okay, so if you go 6 times, you're paying $29 each time. If you go 7 times using your season ticket, you pay $25. If you go 8 times, you're paying $21. So clearly, the minimum number of times you can go for this to be cheaper than the $27 is B7. Okay? Uh, 28. If 8 people can run 16 machines, how many people can 2 people? How many machines can 2 people run? So if 8 people can run 16 machines, that means 1 person can run 2 machines. Okay, how many machines can 2 people run? Well, if 1 person can run 2, that means another person can run 2. So that's a total of 2 plus 2 are 4 machines. All right, couple more problems. $29. Sam earns 3 times as much per hour as Bob. Bob earns $2 more than Jeannie. As a group, they earn $55 per hour. What is Jeannie's hourly wage? So I'm going to say Jeannie earns X numbers of dollars per hour. We know Bob earns $2 more than her, so we can represent that as X plus 2. We know Sam earns 3 times as much as Bob, which is 3 times X plus 2. We know in total they all earn $55 per hour. I'm going to work this out real quick. Namely, I'm going to distribute this 3 to this x and this 3 to this 2. This becomes 3x plus 6. So we know Jeannie plus Bob plus Sam earn a combined rate of $55 per hour. Let's combine like terms. X plus x is 2x, and I'm just going to plus 2 plus 3x plus 6 equals 55. Let's combine some more like terms. 2x plus 3x is 5x. 2 plus 6 is 8. I don't know why I put an x there. So we're left with 5x plus 8 equals 55. Again, I just combined all these unknowns. Let's subtract 8 from both sides. We're left with 5x equals 55 minus 8. We have to borrow here. This becomes 4. This becomes 15. So 15 minus 8 is 7. 4 minus 0 is 4. So we're left with 5x equals 47. Divide both sides by 5. This goes away. So we're left with x equals 47 divided by 5. 5 goes into 4. It doesn't. 5 goes into 47 9 times. 9 times 5 is 45. Subtract. 47 minus 45 is 2. Add a 5 doesn't go into 2, so we have to add a 0. Bring a decimal up when we add that 0. 5 goes into 20 4 times. 5 times 4 is 20, of course. Subtract. So we know that X, our Jeannie's hourly wage, is $9.40 an hour. Okay? Number 30, a bricklayer charges $12 per square foot to lay a patio. How much would it cost for the bricklayer to lay a 10 by 16 foot patio? So again, area of the patio is 10 by 16, or 160 feet squared. So we're going to take 160 divided by 12. 2 times 0 is 0. 2 times 6 is 12. Carry the 1. 2 times 1 is 2. Plus 1 is 3. Bring down a 0 since we're starting a new row. 1 times 0 is 0. 1 times 6 is 6. 1 times 1 is 1. Add 0 plus 0 is 0. 2 plus 0 is 2. 3 plus 6 is 9. And 1 plus 0 is 1. So we can see this is $1,920, which is this one. And that's it. So this video was very intense in terms of the number of division and multiplication problems we had to do with fractions and decimals. Chances are that if you do well on the ASVAB, you're going to feel like you did during this practice video. That is, you're going to feel somewhat exhausted when you're done with this section. So just bear in mind that in my personal opinion, this practice section had quite a few difficult problems and quite a few problems that required a lot of work to find the answers. So don't beat yourself up if you found this difficult as well. Again, I've posted 3 of these videos already. This would be my 4th video if I'm not mistaken. So work out the other problems in the other videos, and hopefully you find some of those a little bit easier. But that said, if you like this video or found it helpful, leave some positive feedback in the comment section below, or thumbs the video up. But on that note, I'm going to go ahead and cut you guys loose.
Konnichiwa.